There's a roll. It's a lot easier at 3Gs. Welcome to space, everyone.
Yeah.
Good to be back. I don't remember liftoff being quite that violent. I do.
Yeah, I do too. Yeah.
7, 6, 5. All three engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis on the shoulders of the Space Shuttle. America will continue the dream.
Program, Houston.
Roger, roll, Atlantis. Houston now controlling the flight of Atlantis. The Space Shuttle spreads its wings one final time for the start of a sentimental journey into history.
And expected to remain good over the next 3 days. So no issues with that particular part of the forecast. The concern being that the weather we have currently around the Kennedy Space Center is described as socked in with clouds and a lot of rain and moisture. But it's a possibility that we'll have rain, not just showers, but rain and thunderstorms within 20 nautical miles of the shuttle landing facility. Also about 20 minutes after liftoff, which should be important when we do our forecast related to the return to landing site abort emergency landing scenario. It's a highly unlikely scenario. We have to not actually try to make it in orbit, don't have enough power with the engines to go over to one of our European emergency landing sites, and have to return to the Kennedy Space Center about 20 minutes after liftoff. So we have to protect for that weather option as well. Mike Moses, the Mission Management Team Chair, said that it may be silly. Some people might call us silly for trying to play in the rain this morning, but he said we're going to absolutely try for tanking. The shuttle launch director, Mike Leinbach, was in 100% agreement with him that trying for tanking is the right option to do, but throughout the overnight and closer to the dawn, early morning hours, around 6 and 7 o'clock, they'll keep their eye on the forecast, of course, all night long. But around that time, they'll start getting very focused look on the weather and see whether it's the right thing to proceed towards launch or whether the forecast really is getting worse and not something we should actually try for a launch attempt. But we'll look at perhaps standing down at that point. But at least at the moment, tanking operations are set to begin momentarily. And a unanimous agreement that's the right thing to do by trying tanking. And as they said, get some of the road underneath them and look for that break in the forecast. And we'll see whether we can hold back the storms of postponement for this morning and get ourselves a launch attempt. And we are about 35 seconds from coming out of our current built-in hold at the T-minus 6 hour point. When the count does resume, we'll go for 3 hours and then stop at the T-minus 3 hour point, which is also approximately the same time we should be wrapping up the tanking operation. We are at 5 seconds. 4, 3, 2, 1. We're at T-minus 6 hours and counting. The STS-135 countdown has resumed towards an 11:26 a.m. liftoff time. Turning our attention now a moment to the mission for Atlantis' STS-135 flight. There is an old English proverb that says, there is an end to everything, to good things as well. And this is the beginning of the end of the Space Shuttle era, is this morning, with the final launch of a shuttle, Atlantis' STS-135 mission. Discussing mission managers and engineers are directing and monitoring Atlantis' countdown on Kennedy's Launch Pad 39A from about 3 miles away in firing room number 4, here in the Launch Control Center. The launch pad that is looking right now at the Launch Control Center, firing room number 4. This team is preparing to start the fueling operations. The launch pad that you're looking at now is the same one that Space Shuttle Columbia lifted off in 1981 on the STS-1 mission, making Pad A the Alpha and the Omega launch complex for the Space Shuttle program. There are 4 astronauts who are currently still in their sleep period at Kennedy's Operations and Checkout building, about a 10-mile drive from the launch pad. Commander Chris Ferguson, pilot Doug Hurley, and mission specialists Sandy Magnus and Rex Walheim will carry out Atlantis' 12-day flight. Let's take a quick look now at the STS-135 mission.
4 veteran astronauts Atlantis STS-135 mission will fly the multi-purpose logistics module Raffaello, packed with supplies, to the International Space Station. During the 12-day flight, mission specialists will use the shuttle's robotic arm to lift Raffaello from the shuttle's payload bay and hand it off to the station's robotic arm for temporary attachment to the Harmony node segment. Crew members will transfer hardware, experiments, and logistics from Raffaello to the space station. Atlantis also will deliver to the outside of the station an experiment to investigate the potential for robotically refueling satellites and return a failed station ammonia cooling system pump to help NASA better understand the failure mechanism and improve future pump designs. Among the other items that Atlantis will carry is a U.S. honor flag that has been flown nationwide at Ground Zero in New York City and throughout the world to honor heroes who have lost their lives while serving their community and country. After the flag returns to Earth, it will continue as a traveling memorial. The STS-135 mission is the final flight for Atlantis and NASA's last Space Shuttle mission.
And we're back now live, looking at Launch Pad 39A. The Atlantis' astronauts are scheduled to wake up at 4:30 a.m. Eastern to start their launch day activities. This is a later wake-up time than usual, but it's not because Ferguson and his team just want to sleep in. It's actually because with only a 4-person crew, each astronaut has to do more per person than you would typically have for a 6 to 7 astronaut crew. So they'll be needing more time to carry out all of those responsibilities crews do have after a shuttle gets into orbit. And to keep the crew's overall workday about the same length as a typical launch day to the International Space Station, the mission planners traded some unused time earlier in the crew's launch day when they're in the Operations and Checkout building, the crew quarters, and scheduled for some much needed time after launch. There are 7 built-in holds for 70 hours and 21 minutes of countdown time that started at the T-minus 43-hour point to launch, and that countdown did begin on Tuesday at 1 p.m. Eastern. We're getting an official time momentarily, and we're just about ready to begin the tanking operation where we chill down or cooling of the pipes that will carry the 535,000 gallons of liquid hydrogen, liquid oxygen to Atlantis' external fuel tank. That is the official kickoff of tanking process. You can see the pumps related to the liquid oxygen side of the fueling process starting to spin up. Looking at the STS-135 mission by the numbers, this is the 135th shuttle flight and the 37th shuttle mission to the International Space Station. This will be Atlantis' 33rd mission overall, and yes, obviously it's its last flight. Currently, STS-135 is a 12-day flight, but with a launch this morning, and once Atlantis gets to the space station and managers can assess how well the crew is conserving the cryogenic reactants for the shuttle's 3 electricity-producing fuel cells, they may add an additional dock day to the mission. So that could put landing either on July 20th or around 7 a.m. Eastern, or July 21st, a little after 6 a.m. Eastern. Once Atlantis does safely return to the Kennedy Space Center, it will begin a slow deservicing process in preparation to eventually put on public display. And teams here won't have to take it very far, actually just down the road. The Kennedy Space Center Visitor Complex has the honor of to display Atlantis, the only space shuttle NASA will keep. Discovery is going to the Smithsonian outside of Washington, D.C., and Endeavour to the California Science Center in Los Angeles. NASA will transport the shuttles to their respective public display sites starting next spring. So this will be the last flight for Atlantis, the 4th of the space shuttle fleet for NASA, which flew its maiden voyage almost 26 years ago. Again, the launch team is not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern, but you are going to be hearing us talk about this all night long. We'll be closely watching the weather, and that is our main concern for the possibility of not being able to launch this morning. But right now we still have a 30% chance, and that's what mission managers are hoping we'll get that break in the weather at that time and give us a chance to begin the STS-135 mission to the International Space Station. At T-minus 5 hours, 53 minutes, and 5 seconds, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 5 hours, 45 minutes, 32 seconds and counting. Launch teams are not working any issues right now. They would prevent us from launching on time at 11:26 a.m. Eastern. The only issue that we'll be talking about all night long is the forecast. And currently they're calling for a 30% chance of good weather for this morning's targeted liftoff time. The start of tanking began by the book on schedule at 2:01 a.m. Eastern. As you can see, the spinning pumps, part of the liquid oxygen system. Tanking process involves loading more than 535,000 gallons of liquid hydrogen and liquid oxygen into the external tank, the biggest part of the Space Shuttle stack. Chill down to the orbiter main propulsion system, the cooling of those pipes inside Atlantis' aft compartment. Takes about a half an hour to do. That's underway. And the liquid hydrogen slow fill began at 12 minutes after the hour at 2:12 a.m. Eastern. So just 1 minute behind the initial timeline. So with an on-time start at 2:01 a.m. Eastern for tanking, it takes about 3 hours to fill up the external tank, which actually is comprised of two smaller tanks inside of it. The liquid hydrogen section holds about 390,000 gallons of that super cold propellant, and the bottom half of the liquid oxygen part, the upper part of the external tank. As you can see, it's separated by that ribbed section, which is known as the inner tank area of the external tank. So liquid hydrogen stored below, and above that, near the top, is the liquid oxygen side, and that middle section is a empty space in between wires and whatnot, but it's an open space that acts as a buffer that separates the two propellant tanks on the inside. The external tank bipod heater activation also started on time, also with the heaters on the bipod ramps for the external tank, and those are the attaching points for the tank to the Space Shuttle near the very top of the Space Shuttle itself. The heaters prevent ice from building up on those two attaching struts. Ice, of course, could become a debris source that could come off during launch and hit the shuttle. As you would recall, foam insulation from that area broke off and hit the left wing of Space Shuttle Columbia in 2003 during its STS-107 mission, and that damaged the shuttle's heat shield wing panel, the reinforced carbon-carbon. You can see the actual bipod ramps we're talking about here. Well, initially they were covered with foam. That foam damage did ultimately cause the Columbia accident, so the engineering solution was to remove the foam insulation from those bipod area and replace it with heaters. We are scheduled by the book to start the liquid oxygen slow fill at 2:41 a.m. Eastern. But again, we had an on-time start to tanking at 2:01 a.m. Eastern. The liquid hydrogen slow fill process began at 2:12 a.m. Eastern. And launch director, shuttle launch director Mike Lambach just came into the fire room here in the Launch Control Center. Talked to him for a moment. Again, he reiterated that it was the right thing to do to start the tanking process. And of course, he'll be talking a lot with the shuttle weather officer, Kathy Winters, all this morning to keep track of it and see whether we get that 30% break in the weather around launch time, which is set for 11:26 a.m. and hold off all the storms that are forecast to start popping up with rain and thunderstorms in the vicinity of the Kennedy Space Center around launch time. Coming up at the bottom of the hour, we'll be talking with Allie Mendoza, the external tank solid rocket booster vehicle manager here at Kennedy Space Center, and she'll go over all the work that's been taking place on Atlantis' external tank and boosters to get us to this point this morning for a launch attempt. And again, the launch team is not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. So at T-minus 5 hours, 40 minutes, and 35 seconds and counting. This is shuttle launch control. This is Shuttle Launch Control at T-minus 5 hours, 30 minutes, 23 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. And it's obviously that 30% chance of good weather means there's a 70% chance of not having good weather, and that's really what we're going to be watching all morning long as we head towards our targeted liftoff time at 11:26 a.m. The possibility of thunderstorms and rain to be enveloping the Kennedy Space Center area along Florida's central east coast. And that's going to have our attention pretty much the entire night long. The mission management team said it was the right thing to do to go with the tanking operation, which began on time at 2:01 a.m. Eastern. And that's the process of loading about 535,000 gallons of liquid hydrogen, liquid oxygen into the tank. It takes about 3 hours to fill the 154-foot tall external tank with those two super-cold propellants. And those propellants are used to fuel the shuttle's 3 main engines during the 8.5-minute climb into orbit. Liquid hydrogen slow fill process began at 2:12 a.m. Eastern. And we're set to begin the liquid hydrogen slow fill process at 2:41 a.m. During their 12-day mission, Atlantis' 4 veteran astronauts will bring more than 8,100 pounds of cargo to the space station. It includes food, equipment, research materials, and critical spare parts that will keep the station in good supply shape through 2012. Coming up in a couple minutes, we'll be talking with Ali Mendoza, the external tank solid rocket booster vehicle manager here at Kennedy Space Center. She'll be with us, joining us momentarily. In the meantime, again, launch team is not working any issues that would prevent us from launching on time at 11:26 a.m. Eastern. So at T-minus 5 hours, 27 minutes, and 55 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 5 hours, 25 minutes, 38 seconds and counting. The launch team is not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. And as you'll be hearing, much like you have all morning already, I'll be the broken record talking about weather, because that is really the main concern that we have with having that 30% chance of good conditions around 11:26 a.m. Possibility of thunderstorms and rain around that time, as we've had for the better part of a day here at Kennedy Space Center. But before we can get to that, straight to the STS-135 mission before we can get underway, and we've had to have the external tank and the boosters and those rockets you can see on the side of the white rockets and the orange external fuel tank start the Space Shuttle program's final flight. They have some of a bit of interesting history to them that we're going to go into now. We're fortunate to be joined here in the Launch Control Center, firing room number 4, by Ali Mendoza, the external tank and solid rocket booster vehicle manager here at Kennedy Space Center. Good morning. Thank you for talking to us and taking a few minutes out. A relatively dry times right now out there, but keep our fingers crossed and see what happens later in the morning. Thanks for joining us.
Good morning, Alex. Thank you.
First, again, with that long title, what exactly have you been doing for the Space Shuttle program and to get STS-135 ready to fly?
Okay, as the vehicle manager for tank and booster, I'm pretty much responsible for the integration and processing of the tanks and boosters from their hometowns in Utah and Louisiana, their arrival here at Kennedy Space Center, processing through, integrating them, putting them together, and rolling out to the pad and processing out the pad. So soup to nuts from home to lunch.
Or I guess would be nuts to bolts, I guess, in some of the cases. But let's see, this external tank is designated ET-138, and it is the newest tank, the last actually tank manufactured. Can you tell us a little bit about what it took to get from the assembly plant, as you mentioned, in Louisiana, all the way here to the Kennedy Space Center and on launch pad 39A this morning?
Yeah, ET-138 has had a pretty long flow. It actually left MAF on July 8th, 2010, so a year ago today. It left MAF. It arrived here July 13th, and as you see here on the film, it comes on the barge, and the barge is pulled by the SRB retrieval ships and into the Port Canaveral. It takes about a 5-day trip. So it arrived at Port Canaveral on the 13th of July, and here you see it offloading here at the turn basin. And we offloaded it on the 14th of July, the next day. It took a little while. We weren't able to lift it the same day. Just as we were going into the VAB, we did have a little leak issue with the transporter, but that resolved itself pretty good. But we made the call to just roll it into the VAB out of the weather and then do the lifting operations on the 15th. So what you're seeing here is the actual lift. We bring it off the transporter in a horizontal position, and then we slowly rotate it to a vertical position before bringing it into the checkout cell. Now, normally this process, from the time it arrives here at the VAB in the checkout cell, we're about 15 days before we make the boosters. ET-138 has had a long extended time in this checkout cell for a little over 9 months, and during that time frame, and here you see it in the checkout cell, we actually did x-rays of the LO2 flange stringers, and we also did the stringer radius block mod from the previous 2 tanks that we had issues with, and just to make sure that this is a good tank and very well. So here you see it lifting out of the checkout cell, and we move it across to the high bay where the boosters are. So it's a very high view. What you're seeing here is from floor level up. It's about 30-some stories up in the air as it moves across. And right now it is being lowered in between the 2 boosters, and the boosters actually arrived also like May of 2010, so they were here for an extended amount of time as well. We did this operation was on April 25th, actually. And after this, the orbiter would come over, we roll out to the pad, and there's nice, beautiful shots of our early morning rollout. Now, while we were at the pad, though, we did do a tanking test on June 15th. So that was one of the things we rolled out a little bit longer at the pad due to the tanking test. And for those of us who don't know what tanking tests are, that's actually doing what we're doing this morning, but in a test procedure, filling up the external tank with And post-tanking tests, we had to perform x-rays of the flanges to make sure that we were in a perfect configuration for launch and that the mod did its job. So here you have the ND folks working. We actually built a couple enclosures out there for them to actually process and analyze the digitized x-rays out at the pad. It's computed radiography. It's for just a high-tech x-ray. People would understand as an x-ray. And what came out of that? No cracks were found. It was just a perfect tank for launch.
And that was actually what you guys had expected, but just to get people who are just maybe joining us, following the Space Shuttle program, who obviously don't follow as closely as you do, we had an issue back with the external tank for Discovery's flight for the STS-133 mission. That was back in November for the first launch attempt, and of course, what we discovered after our first launch attempt was there were cracks in the support beams. You want to go into a little bit about that and walk people through it?
Sure, yes. For STS-133, post-tanking, we did see foam cracked on the outside. When we further looked into it, we noticed that the stringer supports that are in the inner tank, which are those vertical lines that are pretty visible from offset, we did have a couple cracks in those. So we repaired those for STS-133, and all subsequent tanks we were inspecting. Now, ET-138 is the same pedigree as ET-137. It was built around the same time frames, so we wanted to make sure that ET-138 didn't have the same issues. So that's why we took all the precautions and all the inspections on this tank to make sure that it was a good tank.
Right, and the program, obviously, you were very confident. We've had 2 other successful launches since finding those cracks. The reinforcement of those stringers, those modifications you made that strengthened the ends of them, worked exactly as they were designed to do for both Discovery's launch and Endeavour's. So when you did your tanking tests, a few weeks ago, you obviously didn't expect to find anything, and engineering analysis confirmed that was the case.
Correct. And also, one thing we did additional to ET-138 that we didn't do to the 2 previous tanks is that we also x-rayed the LH2 flange, which is the lower portion of that inner tank. And on this one, we had the opportunity, and the NDE team actually developed a technique to actually place the film down in the lower section of the inner tank inside, which we weren't able to do for the other 2 tanks. So we were able to acquire imagery and actually confirm and actually confirm the engineering analysis that the cracks would not appear on the LH2 side as well. So it was a very good effort by all involved.
This is obviously that makes it the most verified tank, I guess, we have. So hence the confidence level going into this morning's launch attempt. Just in case, and we mentioned this a couple minutes ago when you were looking at the video, just to make sure that everyone realizes, even though it had a longer amount of time here at Kennedy Space Center, both the external tank and the solid rocket boosters, that's obviously no reason for concern, right?
Oh, no, absolutely not. Actually, in the past, we've had tanks and boosters here for longer than that. And also, like, the boosters were here for an extended amount of time. And there's requirements, engineering requirements that are levied if they're here after a certain amount of time before you stack, you do additional inspections. So for the forward segments, we did have to perform additional grain inspections prior to stacking just to make sure that everything was still, perfect. There wasn't no issues with the propellant inside the boosters.
Now, that's sort of a full circle Space Shuttle program thing associated with the solid rocket boosters. Do you talk to us a minute about that?
Yes, absolutely. We have a couple elements on the boosters that flew on STS-1 back in 1981. We have the left-hand forward segment, the cylinder of the left-hand forward segment flew on STS-1, and we also have on the right-hand booster, the forward skirt, which is up at the pointy piece, was also flew on STS-1, and they've flown many times before. Like the segment has flown 8 times, and the forward skirt has flown 13 times. So they are reused, but it's kind of neat that it was STS-1 and on the final STS-135 mission.
It really is, and that's obviously the important part that people realize, that we do pick them back up out of the water after launches, and you do refurbish them and put them back into service, and you've got a couple of pieces that really verify that when you go back for 30 years of flights.
Absolutely, yes, they are reusable.
So this is obviously, we can't avoid talking about this. This is the final Space Shuttle flight ever, so you've been with the program for some time. Please take a couple minutes, if you wouldn't, and this is my Oprah moment to see whether I can get you to tear up. Yes, that's exactly what.
No, there's no crying in spaceflight.
That's right. But could you take a couple minutes and just let us, how does this make you feel?
I guess it is disheartening to see the Space Shuttle program end. We've worked on it for so long, and we have a one-of-a-kind, amazing team that has worked so hard. And we're about to all go in separate directions, so that's kind of sad. But there's also a little element of excitement to see what the future holds for us, the future of the agency, and what the future of the space program for our nation holds. We still have a lot of work here at the Space Center. I mean, our expendable launch vehicle brethren still have 4 more launches this year. A few from here from the Cape Side, one from Vandenberg. So we've got still a lot of work here at Kennedy and for the space flight. It's just human space flight will be a little while before we see that again here. But we have funding for development of new technologies and capabilities. So even though it's heartening, we do have something to hopefully look forward to here in the near future. It's definitely quite different than what we're all been used to, but nonetheless, it'll be exciting for our future. And I just look forward to the U.S. return, to dominance in the human spaceflight arena.
And arguably, with the International Space Station, international cooperation that we have there, that obviously we aren't going anywhere in human spaceflight in the sense of not removing our presence. It's just, as you mentioned, a temporary.
It's just a temporary hold on us
of not
launching
from here at Kennedy Space Center. Exactly.
Yes.
and
launching humans from the United States. Yeah.
And let's at least not mention that you gave a little plug there to the Launch Services Program, which is good. That's the NASA's program that does all the launches for the science missions and the rovers and launch next month to Jupiter. That was no coincidence that you plugged that. I guess. You might be giving a little plug to your new team, apparently.
Yes, apparently that's my future job will be a mission integration manager for the launch services providing. So.
Well, before we obviously let you go to the launch services program, and the shuttle program isn't quite done yet.
Oh no, not at all. And actually, I wanted to mention, when I mentioned the team that we have, just amazing team. It's not just the folks here at Kennedy, the folks in the fire room, and everybody knows about all the major contractors that we have, the ATKs, the Lockheed Martins, the Boeings, the Hamilton Sunstrands, those guys. But there's thousands of team members around the country that have provided nuts and bolts and refurbishment. The orbiter itself has about 2,200, at least 2,200 contractors that support us with things as small as bolts to nuts, and you have tank side and the booster side. Just quickly, the boosters here, just the forward assemblies and the aft skirts, you have over 450 vendors that provide some type of support around the country for us. So it's not just the folks here, and it was just been such amazing to work with such a multifaceted team, and the support that we get from across the country for the Space Shuttle program. And everybody should be really proud that how we've ended and we're just finishing strong.
And that has really been the theme that management has said. It's that building on that legacy of the team members and all the work that they've done. And you're a part of that team. And Allie, thank you for taking a couple minutes. Hopefully we'll get a good launch this morning and won't have to drag you back to do this again. That's gonna be our.
Have you done your rain dance for the day?
I think somebody has already done that, and that's why we may have an issue this morning. Again, Allie, thank you for joining us. That's Allie Mendoza, the external tank and solid rocket booster vehicle manager here at Kennedy Space Center. Thanks for talking to us this morning.
Thank you very much, Allard. My pleasure.
And coming up in our next segment, we'll actually take a little closer look at the external tank that we were just talking about and how that works. So again, the launch team is not working any technical issues that would prevent us from launching on time at 11:26 a.m. Eastern. As you heard, we are going to be watching the weather very closely, and hopefully we'll get a break with that 30% chance of good weather around the liftoff time. At T-minus 5 hours, 11 minutes, 43 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida at T-minus 5 hours and 45 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. And that 30% chance means we have a 70% chance of not having good weather at launch time, and that is going to be the main concern that we have and are going to be dealing with for the rest of the morning, as has been talked about for the past several days. The possibility of having thunderstorms and rain around the Kennedy Space Center at that time keep us from lifting off. On the technical hardware side, we're not working any issues. The start of the tanking process began on time at 2:01 a.m. Eastern. It takes about 3 hours to fill Atlantis' external fuel tank with 535,000 gallons of liquid hydrogen, liquid oxygen. We went into the liquid hydrogen fast fill process at 2:51 a.m., immediately followed by the liquid oxygen fast fill at 2:52 a.m. So we're running a little bit ahead of schedule for the fueling process. On the liquid hydrogen side of the tank, it went to about 5% full at 2:32 a.m. That's when they conducted a engine cutoff sensor test. And the liquid hydrogen part of the external tank at that point was about 5% full. And the low-level engine cutoff sensors, also known as eco sensors, are at the bottom of the tank. At that point, they're covered over, and to test to make sure that all 4 sensors are working properly, the computer simulates a dry command sent, and the teams monitor the sensor's performance. This will be continually monitored for a period with the engineers here on the console in the firing room number 4. The eco sensors act as one of the shuttle's low fuel warning systems, and in a worst case situation, could actually shut down Atlantis' engines if the tank were unexpectedly very low on fuel. A few years ago, the Space Shuttle program had issues with the eco sensors, but since they were worked on and fixed early in 2008, we haven't had any issues with them, and that's exactly what we expect this morning, and will be the case with Atlantis' launch today. The managers and engineers are directing and monitoring Atlantis' countdown on Kennedy's Launch Pad 39A from about 3 miles away in firing room number 4 here in the Launch Control Center. About 90 minutes ago, the Space Shuttle program managers met, and the mission management team gave a unanimous approval to go ahead with the fueling operations for this morning. You can see the Launch Control Center here, about 3 miles away from where Atlantis is sitting. And on time, the team started the fueling process. Tanking got underway at 2:01 a.m. Eastern. And it takes about 3 hours to fill the tank. Those 2 super cold propellants are used to fuel the shuttle's 3 main engines during the 8.5-minute climb into orbit. There are expected to be no weather issues with our transoceanic abort landing sites in Europe. Zaragoza, Spain is our prime emergency landing site, our prime TAL site. And again, good forecasts actually pretty much for the next 3 days for those particular landing sites. Atlantis' STS-135 mission will bring more than 8,100 pounds of cargo to the space station. It's all packed inside the Raffaello multi-purpose logistics module inside Atlantis' payload bay. More than a third of that 8,100 pounds is food for future station crews. With the supplies aboard Atlantis, the International Space Station will be in good shape through all of 2012, when U.S. commercial companies under contract with NASA are expected to begin resupply flights to the space station. Atlantis' 4 astronauts also are bringing in an experiment called the Robotic Refueling Mission, which will be put on the station, on the exterior, and during the next 2 years with the Canadian Dexter robot arm. We'll test tools and technology and techniques to robotically refuel satellites. The crew also will be returned to Earth a failed space station cooling system ammonia pump, and the flight also has 1 spacewalk associated with it, which will actually be carried out by the 2 space station astronauts and supported by Atlantis' crew members. Looking at the STS-135 mission by the numbers, this is the 135th shuttle flight and the 37th shuttle mission to the International Space Station. This will also be Atlantis' 33rd mission overall, and yes, obviously its last flight. Currently, the STS-135 mission is a 12-day flight, but with a launch this morning. And once Atlantis gets to the space station, managers can assess how well the crew is conserving the cryogenic reactants for the shuttle's 3 electricity-producing fuel cells. They may actually add an additional dock day to the mission. So that could put landing either on July 20th, a little after 7 a.m. Eastern, or July 21st, a little after 6 a.m. Eastern. Once Atlantis does safely return to the Kennedy Space Center, it will begin a slow deservicing process in preparation to eventually be put on public display. And the teams won't have to take it very far, just down the road, in fact, to the Kennedy Space Center Visitor Complex, which does have the honor of being able to display Atlantis, the only space shuttle NASA will keep. Shuttle Discovery is going to the Smithsonian outside Washington, D.C., and Endeavour to the California Science Center in Los Angeles. NASA will transport the shuttles to their respective public sites starting next spring. Over in the crew quarters at Kennedy's Operations and Checkout Building, Atlantis' 4 astronauts are scheduled to wake up in about 90 minutes at 4:30 a.m. Eastern to start their launch day activities. This is a later wake-up time than usual for a shuttle crew, but it's not because Ferguson and his teams just want to sleep in. It's actually because with only 4 people on the crew, each astronaut has more to do per person than you typically have, obviously, with a 6 or 7 person crew. So they'll need more time to carry out all their respective responsibilities after the shuttle gets into orbit. So to keep the crew's overall workday about the same length as a typical launch day to the space station, mission planners traded some unused time earlier in the crew's launch day schedule for some much needed time after launch. With 4 astronauts, this is the smallest shuttle crew we've had since Shuttle Columbia's STS-6 4-person crew back in 1983. This time around, it's because STS-135 originally was only designated as a potential rescue flight for Endeavour's STS-134 mission, which was scheduled to take place in April, but ended up being a May 16th launch. That was going to be the last shuttle flight, but shuttle rescue flights were, at that, of course, made up of 4-person, but when Atlantis' flight was designated an actual flight and put on the shuttle schedule earlier this year, the 4-member crew was kept, as it also works for carrying out all the mission objectives while still making it relatively easier for a potential rescue flight versus having a 7 or 6-person crew. Only this time, a rescue flight will be carried out using Russian Soyuz spacecraft. Since there are no more shuttle flights, obviously, to mount a potential rescue mission to the space station, in the unlikely event that Atlantis would be damaged somehow that would prevent it from making a re-entry, the plan is to have Atlantis' astronauts become long-term space station crew members and then, over the coming months, stagger their departure and have them fly down on Soyuz spacecraft as part of the originally scheduled crew rotations. So that means Atlantis' crew would be staying aboard the station a lot longer than they had planned into 2012. Of course, we actually don't expect that to happen, but it's good to have that worst-case plan prepared just in case. The pilot for STS-135 is Doug Hurley. He's a 44-year-old U.S. Marine colonel who will be taking his 2nd trip into space. Hurley says shuttle crews on flights to assemble the International Space Station have carried out some of the most complicated missions in all of human spaceflight.
I would argue that some of the space station assembly missions were the most complex space missions, including going to the moon, that we've ever done. I mean, these 16-day assembly missions with multiple days of robotics, 5 EVAs. I definitely would argue that from a complexity standpoint, we've not done anything more complex than those missions.
Mission Specialist Rex Walheim will be making his 3rd trip into space, and all have been aboard Atlantis. The 48-year-old retired U.S. Air Force colonel has logged more than 24 days in space already and has conducted 5 spacewalks during his previous 2 Atlantis missions. As is tradition, each astronaut crew comes up with its own mission patch. Walheim says the STS-135 patch was designed with the end of the Space Shuttle era in mind.
Well, we wanted to make it a celebration. We wanted to make it a happy patch that really encompasses the kind of history of the Space Shuttle program. So in some respects, it mirrors a little bit the STS-1 patch with the full shuttle on there. And we wanted to also honor the whole NASA contractor team, the whole team that has made the Space Shuttle possible. And we did that by putting a portion of the NASA emblem in the middle with the swoosh on there. And then we also want to signify that it was the last mission. We did that with the Omega. The gold Omega is the last letter of the Greek alphabet, so that was kind of our way of symbolizing the last mission. And we worked with my wife. We told her kind of what we wanted, and she came up with a bunch of different designs. My wife Margie is a graphic designer by trade, and so she gave us some ideas, and we refined them, and we think we came up with a great patch.
Mission specialist Sandy Magnus is the most experienced space flyer on the STS-135 crew. Her first flight was also aboard Atlantis during the STS-112 mission to the International Space Station in 2002. And she was a member of the space station's Expedition 18 crew, where she spent 4 months working from space, from November 2008 to March 2009. The 46-year-old holds a PhD in materials science and engineering. Magnus will also be what's known as the load master, which means she is in charge of making sure all the cargo that needs to get transferred to the station does, and all the things that need to be returned to Earth are. And obviously she also will be the last female space shuttle astronaut, but Magnus says that actual factoid isn't as important in the grand scheme of the space shuttle era as one might think.
So I think it's more important to focus on the fact that this is the last shuttle flight, and in doing so reflect on what an amazing vehicle the shuttle is and all the things that we've been able to accomplish with it. Some things not even foreseen when they designed it. So, you know, being the last woman on the space shuttle, I don't think is really the important point. The important point is this is the last space shuttle, and we have to celebrate what this program has given to the country.
And finally, the commander for Atlantis' STS-135 mission is retired U.S. Navy Captain Chris Ferguson. The 49-year-old will be making his third spaceflight on this mission. Ferguson says the significance of leading the final space shuttle mission ever isn't lost on him, and he has a clear idea of how the shuttle will be remembered by future generations.
The space shuttle will be viewed in 100 years as the culmination of that aerospace work that we did in the 1950s with these X vehicles, and this was the product of it, and it's going to be held kind of as the granddaddy, if you will, because I think it's going to be a long time before we see a vehicle certainly of the magnitude of the space shuttle. I mean, if you look at it, it's huge. If you look at what we want to replace it with, they're all fairly small and compact, and they have different shapes and sizes, but the magic of the space shuttle is just its enormity. It's huge. And it flies up and back, and there will be no parallel like that, I think, for 100 years. So it'll be remembered for, I think, its pioneering in aerospace and just the magnitude of the program, and the fact that it served the world for 30 years and built the International Space Station will be what everybody remembers.
And we'll actually take a little closer look at the Atlantis astronauts coming up later during our taking commentary. And in the meantime, the launch control team is not working any technical issues that would prevent us from launching on time at 11:26 a.m. Eastern. The weather, however, may be an issue. It's something we're going to be watching throughout the night into the early morning hours. Teams will take a closer look in the 6 to 7 o'clock time frame and continue evaluations of the weather and see whether we have a shot at the 11:26 targeted liftoff time, or if circumstances come up with the thunderstorms that are predicted to pop up and rain to inundate this particular area known as the Space Coast along Florida's central east coast. If that actually takes place, might be making another run at this tomorrow. But in the meantime, mission managers were very confident that beginning the tanking process was the right thing to do. So that's where we are, and we're started at 2:01 a.m. Eastern. Look to wrap that up around 5 a.m. And we'll continue monitoring the weather, see whether we get a break and Well, if we'll be dealing with the storms of postponement later this morning. At T-minus 4 hours, 45 minutes, 47 seconds and counting, this is shuttle launch control. This is Shuttle Launch Control at T-minus 4 hours, 30 minutes, 45 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. And with that 30% chance of good weather comes, of course, the opposite side, which is 70% of not having acceptable weather around the launch time. And that's unacceptable weather in the form of thunderstorms and rain around Kennedy Space Center. Moving up from the south to the north, as has been the case over the past day or so. Start of the tanking process, which is filling the large orange external fuel tank with about 535,000 gallons of liquid oxygen and liquid hydrogen, began on time at 2:01 a.m. Eastern. We went into the liquid hydrogen fast fill at 2:51 a.m. Eastern and the liquid oxygen fast fill at 2:52 a.m. Eastern. So tanking should be complete by about 5 a.m. or perhaps a little earlier than that, since they've been running a little ahead of the tanking process schedule. During their 12-day mission, Atlantis' 4 veteran astronauts will carry to and from the International Space Station the Raffaello Multi-Purpose Logistics Module. And this will be the 4th flight for Raffaello. Last time it flew was aboard Shuttle Discovery for the STS-114 return-to-flight mission in 2005. But this time around, Raffaello is packed with more cargo than any other MPLM has ever been packed with. More than 8,100 pounds of supplies, and about a third of that food for future station crews. There's science gear, such as a new ultrasound machine for medical and biological research, and an advanced carbon dioxide scrubber technology demonstrator. Raffaello also is holding more than 4,300 pounds of spare parts, critical for space station operations, including a new reusable filter tank for the water recycling system, a GPS antenna, and a spare gyroscope for the station treadmill. All in all, the 6 months worth of supplies Atlantis and its crew are bringing to the space station are intended to keep the station in good shape through all of next year, through 2012. Next year is when 2 commercial U.S. companies NASA has contracts with, that's SpaceX and Orbital Sciences. That's when they're expected to begin regular cargo flights to the International Space Station and take over the U.S. resupply responsibilities for the station that the shuttles have been doing. In addition to the resupply of the space station, there are more than a dozen experiments that will be carried out during the STS-135 mission, and that's on top of the 115 integrated experiments already taking place aboard the International Space Station. Some of these short-duration experiments that will be conducted during the STS-135 flight are 2 studies looking at combating bone loss in astronauts, including one that will check the effectiveness of experimental drug therapies. Another study will look at using experimental therapeutic countermeasures to stop muscle atrophy. There are also some planned experiments for long-term space flights that can also address food supply issues here on Earth. The crew will test a system designed to convert dirty water into a fortified drink that could be used for spacewalking astronauts or in an emergency backup water supply for the space station, as well as using for possible use in future long-term space exploration flights. After undocking, Atlantis' crew will launch a very small satellite for the Defense Department called the PicoSat Solar Cell Experiment for the Defense Department, which will relay data back to engineers on the ground on the performance of these solar cells on the 5-inch by 5-inch by 10-inch satellite. Atlantis also will be delivering new experiments to the space station for longer-term study. These include further evaluations of a salmonella vaccine, a Defense Department experiment studying the effects of tissue regeneration and wound healing in space, and using 2 different types of commercially available smartphones to test for potential use as navigational aids and as a mobile assistant for astronauts aboard the station. The largest experiment that's being brought to the space station is a washing machine-sized device that is designed to test new technologies and techniques to robotically refuel satellites in space, even ones that were never originally intended to be refueled in space. It's called the Robotic Refueling Mission, or RRM, and it will be installed on the outside of the station during the mission's only spacewalk, which will be carried out by 2 space station astronauts. During the next 2 years, the RRM will use the station's Canadarm robotic arm 2, known as Canadarm 2, along with the station's robotic hand, the dexterous manipulator system, or Dexter, to test these tools and hardware in and on the RRM. So let's take a few minutes now and take a closer look at the robotic refueling mission experiment. And we're back now looking live at Kennedy Space Center's Launch Pad 39A, where Space Shuttle Atlantis is being fueled, although not robotically, for this morning's flight to the International Space Station. As we've been saying, launch teams are not working any technical issues right now that would prevent us from launching on time at 11:26 a.m. The only potential issue is that forecast of 70% no-go weather around our scheduled liftoff time. Potential of thunderstorms and rain might keep us on the ground here an extra day in Florida. But the launch team would like to be guardedly optimistic about having that 30% chance of favorable weather and more drying conditions actually be around on 11:30 this morning, and get that shot at starting Atlantis' STS-135 mission to the space station. At T-minus 4 hours, 22 minutes, 5 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 4 hours, 13 minutes, 55 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. And they're hoping that that 30% chance is all they need, since it has been done in the past. We've launched with a 90% chance of not having good weather. So the launch team decided unanimously to go ahead with fueling operations, which began on time at 2:01 a.m. Eastern. The tanking process, which is filling the external tank with about 535,000 gallons of liquid hydrogen and liquid oxygen. That process began on time and has been running ahead of schedule, or on schedule with most of their milestones. The liquid hydrogen fast fill process began at 2:51 a.m. Eastern, followed a minute later by the fast fill for liquid oxygen at 2:52 a.m. So that would put the completion of tanking on time or slightly before 5 a.m. Eastern. Out in the Atlantic Ocean, there are a couple of NASA ships that are standing by to see whether we launch this morning. Those two ships, the booster retrieval ships Liberty Star and Freedom Star, left port yesterday morning to be in position in the Atlantic this morning to recover the solid rocket boosters. Boosters land in the Atlantic Ocean approximately 7 minutes after liftoff. Splashdown area is a box about 7 to 10 miles, located 160 miles or so downrange from the launch pad. The boosters separate about 28 to 29 and a half miles up. Their maximum height after separation is about 45 miles up. Liberty Star and Freedom Star will each pick up one of the boosters. Freedom Star will pick up the left one, and Liberty Star will pick up the right one. They'll return to Port Canaveral with the boosters Sunday night. We launched this morning, and then they'll arrive at their docks at Hangar AF on Cape Canaveral Air Force Station Monday morning. Obviously, during the tanking process, as you'd imagine, the external fuel tank is the main focus of attention for the launch countdown. So let's take a few minutes now and have a closer look at the Space Shuttle external tank.
A space shuttle requires more than 500,000 gallons of fuel and oxygen to power its engines for the crucial climb to orbit. That is far too much propellant for a shuttle to store on board, so it carries a fuel tank along that is jettisoned as the shuttle reaches orbit. That fuel tank is called the external tank, or ET, and this is how it works. The external tank is the familiar orange structure that dominates most images of the shuttle at liftoff. At more than 15 stories tall, it's the largest single part of a shuttle stack. It's so large that a barge is used to haul it from its manufacturing plant in Michoud, Louisiana, to NASA's Kennedy Space Center in Florida, where it is processed for a mission. It gets its unique signature orange color from the foam insulation sprayed on the tank's aluminum structure. The insulation helps the tank act as a thermos bottle to keep the supercold propellants from evaporating too quickly. It also helps prevent ice from forming on the tank's exterior and promotes the right aerodynamic shape for launching into space. The main job of the tank is to hold about 535,000 gallons of supercold liquid hydrogen and liquid oxygen. The chemicals are funneled from the tank into the shuttle's 3 main engines at liftoff and throughout the shuttle's 8.5-minute climb into space. During the Space Shuttle fleet's 30 years of operation, the tank, like the shuttle itself, has undergone numerous upgrades and weight-saving improvements. Following a few revisions to designs and materials, the latest version of the tank, known as the super lightweight tank, is 17,000 pounds lighter than the first one Columbia used in 1981. The tank also received extra attention after 2003's Columbia accident, which was blamed in part on a piece of the insulating foam on the tank breaking off, striking the left wing and creating a hole in the shuttle's heat shield. Engineers implemented changes to the foam and the way it is applied and refined before the next launch. Some foam was removed altogether to eliminate risk further. NASA also mandated cameras be attached to the tank so engineers could see any possible debris coming off the tank during ascent. By providing the propellants for the Space Shuttle's main engines during launch, the external tank plays a critical role in the Space Shuttle program, and that is how it works.
And we're now back live looking at Launch Pad 39A at NASA's Kennedy Space Center. What you're looking at is what's known as the flare stack. That burns off the excess hydrogen gas. It goes through the, if you've been following the Space Shuttle program in the past year or so, you've heard this particular acronym used before, the GUP, the Ground Umbilical Carrier Plate. This particular interface between a venting hydrogen pipe that takes this excess hydrogen that comes off during the tanking process. As more liquid hydrogen is pumped into that portion of the tank, the excess gas is funneled out through this pipe and is sent to the flare stack, where it's burned off much like an oil refinery. Burns off at the excess gas. We use the flare stack to burn off the excess hydrogen safely, about 750 feet from the pad. Of course, during the daytime, it's much more difficult to see, but overnight hours like this, we get the question a lot that the fire is out at the launch pad. And in this case, it's a very good thing. We want that fire there. It's a controlled burn that allows us to make the shuttle and the launch pad actually safer. So again, the launch team is not working any technical issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. What we'll be doing is what often happens in the summer in Florida. You watch the weather. And that's exactly what the launch team will be doing to see whether we'll get that 30% chance turned into a 100% chance of launching on time today. At T-minus 4 hours, 6 minutes, 48 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida at T-minus 3 hours, 58 minutes, 44 seconds and counting. We're about an hour away from finishing up the fueling operations for Space Shuttle Atlantis' STS-135 mission to the International Space Station. And about an hour away from going to our next built-in hold in the launch countdown at the T-minus 3 hour point. Launch teams are not working any technical issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of the final Space Shuttle mission ever. And they'll be monitoring the weather throughout the morning to see whether we really do get that 30% chance and get an opportunity to send Atlantis on its mission to the space station on time. And we'll see where we are. So far, so good, with no issues being worked with the with technical on the hardware side, or any issues with the schedule, which started with tanking on time at 2:01 a.m. Eastern, and takes about 3 hours to fill the external tank with 535,000 gallons of liquid hydrogen and liquid oxygen. We went into the liquid hydrogen fast fill process at 2:51 a.m. Eastern, followed a minute later by the liquid oxygen side fast fill at 2:52 a.m. We are shortly about to go into what's known as liquid hydrogen topping. Means we're about 98% filled with the liquid hydrogen portion of the external tank, and that's slightly ahead of schedule. 4 NASA astronauts, Commander Chris Ferguson, pilot Doug Hurley, and mission specialists Sandy Magnus and Rex Walheim, will carry out Atlantis' 12-day flight to resupply the space station. Let's take a closer look now at the STS-135 mission.
The flight of Atlantis marks the 37th shuttle mission to the space station. The flight was originally manifested only as the Launch on Need rescue mission for STS-134, which at the time was scheduled as the shuttle's final flight. With the launch of Atlantis, there will be no rescue shuttle standing by. In case of an unexpected problem or emergency, Atlantis' astronauts would remain aboard the space station, ultimately returning to Earth aboard a series of Russian Soyuz spacecraft. America's leadership ultimately recognized the value of one additional shuttle mission, and the STS-135 flight plan evolved into an historic 12-day mission, delivering valuable equipment, parts, and supplies to the completed and fully operational station.
It's an effort to posture the space station for about a year, put it in a good position until we can get our commercial cargo resupply system up and running.
On Flight Day 4, the crew of Atlantis will install the Raffaello Logistics Module moving van to the ISS. The station crew and shuttle astronauts will unpack about 15,000 pounds of cargo for the current and future ISS crews, items such as food, clothing, spare parts for the station, and scientific experiments. At the same time, the joint crews will be repacking Raffaello with over 12,000 pounds of shuttle-related equipment stored on the ISS, other items marked for return to Earth, and trash offloaded from the station.
We'll take stuff out of the Node 2 nadir spot, translate down the lab, and most of the stowage and transfer that we're doing will be in the permanent MPLM that's on board.
Magnus serves as Raffaello's loadmaster, with assistance from Walheim.
The very first most important rule is do what Sandy says, because Sandy's lived up there and she's our load master, so she knows where things go, and we'll figure out ways to make that shell game happen.
And I didn't realize this until we got into the planning of the mission, is that the space station software was never designed to accommodate more than one logistics module. We've had to perform a little, I guess, sleight of hand to get the space station to believe that there's actually 2 logistics modules on board.
Atlantis will also deliver the robotics refueling payload, which will be tested using the space station's Dexter robot. The space station has a robotic arm for heavy lifting, but Dexter is a robotic hand, capable of performing fine, minute tasks. The payload will be its first workout to see how well it can perform. On Flight Day 5, the crew of Atlantis will support one station-based performed by Expedition 28 astronauts Mike Fossum and Ron Garan. The pair flew 3 years ago on the STS-124 mission, performing 3 spacewalks together to help install the Japanese Kibo laboratory module. During this EVA, Magnus and Hurley will provide robotic support for Fossum and Garin. Walheim will serve as the IV, or intravehicular officer, for the spacewalk. A failed cooling pump, temporarily stowed outside the station during a spacewalk during the STS-133 mission, will be removed and brought home by the shuttle. Thanks to the shuttle's ability to return cargo, engineers will have the opportunity to study the cause of the pump's failure.
While we're in the payload bay attaching the pump module to the logistics carrier, we'll retrieve this experiment for the special purpose dexterous manipulator that will allow the robotics community to show the ability to do remote refueling and other dexterous tasks that might be involved in servicing satellites.
Fossum and Garin will install the robotics refueling payload on a temporary platform near the Dexter robot and the Destiny lab.
It really is the chance to show how well the SPDM can function in space.
And we're back now live looking at Launch Pad 39A at NASA's Kennedy Space Center, where about 10 miles away, at least a 10-mile drive, Atlantis' astronauts are scheduled to wake up at the bottom of the hour at 4:30 a.m. Eastern to start their launch day activities. This is later than crews usually wake up. It's because the 4-person crew that will be Atlantis' final flight means that each person has more to do per person than you would have for the typical 6 to 7 person astronaut crew, so they'll need more time to carry out all those responsibilities that a crew typically has once a shuttle gets into orbit, to keep the crew's overall workday about the same length as a typical launch day to the station. The mission planners traded some unused time earlier in the crew's schedule for some much needed time after launch. So they'll set to be waking up in about 20 minutes from now in the operations and checkout building crew quarters here at Kennedy. Looking at the STS-135 mission by the numbers, this is the 135th shuttle flight and the 37th shuttle mission to the International Space Station. This will be Atlantis' 33rd mission overall, and yes, obviously its last mission. Currently, STS-135 is a 12-day flight, but with a launch this morning, and once Atlantis gets to the space station and managers can assess how well the crew has been conserving the cryogenic reactants for the shuttle's 3 electricity-producing fuel cells, they may actually add another day to the docked schedule. So that could put landing either on July 20th, a little after 7 a.m. Eastern, or July 21st, a little after 6 a.m. Eastern. Once Atlantis does safely return to the Kennedy Space Center, it will be slowly deprocessed and prepared to eventually be put on public display. And the launch team won't have very far to take it. It'll be just down the road, in fact, at the Kennedy Space Center Visitor Complex, which has the honor of being able to display Atlantis, the only space shuttle that NASA will keep. Atlantis' partners in spaceflight. The shuttle Discovery is going to be going to the Smithsonian outside Washington, D.C., and the Endeavour is going to the California Science Center in Los Angeles. The test shuttle Enterprise, which currently is in the Smithsonian outside Washington, D.C., will be moved up to New York City in the Intrepid Sea, Air, and Space Museum. NASA will begin transporting the shuttles to their respective public display sites starting next spring. But before all that can happen, Atlantis' STS-135 mission needs to be safely carried out. And right now, the launch team is not working any technical issues that would prevent us from doing that and starting the Space Shuttle program's final flight with an on-time liftoff at 11:26 a.m. Eastern. The only concern is the possibility of thunderstorms and rain around launch time that could keep us on the ground an extra day. But the launch team is hoping that that 30% chance of good conditions will be what actually does take place. At T-minus 3 hours, 49 minutes, 20 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 39 minutes, 52 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. The start of our tanking process began on time at 2:01 a.m. Eastern. Tanking is filling the external fuel tank with about 535,000 gallons of liquid hydrogen and liquid oxygen. We went into the liquid hydrogen fast fill phase at 2:51 a.m. and went into liquid hydrogen topping about 15 minutes ahead of schedule at 4:02 a.m. Liquid oxygen fast fill began slightly ahead of schedule as well at 2:52 a.m. Liquid hydrogen topping is when the hydrogen side of the external tank is about 98% filled and engineers slow down the flow of the propellant, which is called topping the tank. And they do that until the tank is filled to 100%. However, because the tank is warm and the propellants are extremely cold, with liquid, some of the propellant burns off and therefore must be continually added to keep it at a constant 100% level. Stable replenish is the point where the engineers have stable control of the propellant entering the tank and keep it at that 100% level. And of course, as the tank cools, the liquid becomes denser, and by continuing to add propellant, it packs or squeezes more propellant into the tank. And once the tank is filled, engineers stop the replenish phase and the tank and propellants are configured for launch. So we are been running on time or ahead of our tanking process all morning long, which obviously is a good thing, and we've had no technical issues. And would be remiss that I have not mentioned this, but during a tanking test, which was essentially the same process but not for launch, it was done to look at the external tank and then confirm later that the stringers, which are support beams on the exterior inner tank part of the external tank, near that upper 2/3 section, they had no issues with it. During that tanking test mid last month, the main fuel valve in engine number 3 for Atlantis began to leak. Well, that is not the case this morning. That valve was, of course, changed out a couple of weeks ago, and the launch team has said that the main fuel valve number 3 is rock solid and therefore performing exactly the way it's supposed to. So I have not mentioned it this morning because we've not had an issue, but it's definitely worth mentioning that we don't have an issue with the main fuel valve. So that particular trap was apparently sprung during our tanking test last month. Of course, you are looking at Kennedy's Launch Pad 39A. It's the last remaining shuttle launch pad, and about a mile away in the dark is Pad 39B, which has been undergoing deconstruction since last year to get it ready to be able to launch spacecraft other than the shuttles, such as NASA's under development Orion multipurpose crew vehicle, or the heavy lift rocket, or a commercial company rocket and spacecraft. Launch Pad 39A has been used to launch NASA spacecraft since the 1960s, including humanity's first moon landing, Apollo 11. That was almost 42 years ago. This is also the same launch pad that Space Shuttle Columbia lifted off from in 1981 on the STS-1 mission, making Pad A the Alpha and Omega launch complex for the Space Shuttle program. So let's take a closer look for one last mission, how a shuttle launch pad works.
Here's how the shuttle's launch pad or launch complex works. The launch pad does more than just provide a stand for the space shuttle to lift off from. Automatic systems inside the launch pad make the last few important steps before a shuttle mission begins. The payload typically arrives at the launch pad before the space shuttle. A built-in crane hoists a canister holding the payload into a clean room inside the rotating service structure, or RSS. The space shuttle is fastened to a mobile launch platform and carefully rolled to the launch pad. Precise measurements and careful adjustments place the launch platform and shuttle in exactly the right place. A small army of technicians begin running data and power cables to the launch platform. It's a critical step that connects equipment on the platform and inside the shuttle with the information network needed for launch. The RSS is wheeled into place to protect the orbiter, and the payload is carefully maneuvered into the shuttle's payload bay. Arms on the fixed service structure also move into place, including a metal bridge that meets the shuttle's hatch. On launch day, super-cold liquid hydrogen and liquid oxygen are pumped from massive tanks near the launch pad into the mobile launcher platform. A network of lines carry the propellants into a pair of masts that pump it into the orbiter and then into the external tank. Once the tank is filled, the astronauts are driven to the launch pad. They ride the elevator up to the 195-foot level, where they walk down the orbiter access arm and climb into the shuttle. With the crew strapped in and the shuttle fueled for launch, signals are sent to the launch pad to execute a number of precise commands during the final few minutes of the countdown. The crew's access arm swings back into the fixed service structure first, then the vent arm retracts. A set of igniters known as sparklers burn off stray hydrogen as the shuttle main engines come to life. A 290-foot tower next to the launch pad dumps water onto the pad and into the flame trench. This sound suppression system, as it is known, is not to protect from the flame, but to dampen the intense vibrations from the thundering boosters and engines so that the sound does not hurt the launching shuttle. With the engines firing, the solid rocket boosters ignite, and the 8 bolts holding the shuttle to the pad explode on command to release the shuttle on its path into space. That's how the shuttle launch pad works.
And we're back looking at live video now of Launch Pad 39A, where the launch team is not working any issues right now that will prevent us from launching on time at 11:26 a.m. Coming up in a couple minutes, Atlantis' crew members are scheduled for their wake-up call. We'll take a look at the 4 NASA astronauts who will carry out the STS-135 mission at the bottom of the hour, and we'll also take a rare look inside the crew quarters here at Kennedy. Take you for a brief tour around that. That's coming up in a couple of minutes. At T-minus 3 hours, 32 minutes, 25 seconds and counting, this is Shuttle Launch Control. This is your launch control at T-minus 3 hours, 27 minutes, 33 seconds and counting. The launch team is not working any technical issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. The tanking process began on time at 2:01 a.m. Eastern. It takes about 3 hours to fill the external tank with about 535,000 gallons of liquid hydrogen and liquid oxygen. We went into liquid oxygen fast fill at 2:52 a.m. and we went into liquid hydrogen topping at 4:02 a.m. That means that the hydrogen side of the tank is about 98% full. As you heard, we've been talking about the weather forecast being the probability of having good weather and favorable conditions at liftoff time is only 30%. Shuttle Weather Officer Kathy Winters just finished up briefing Shuttle Launch Director Mike Leinbach just a couple minutes ago, saying it's been a relatively quiet evening, especially compared to what we had yesterday here at the Kennedy Space Center. We've had no lightning, unlike what we had yesterday afternoon. Relatively benign conditions for the weather. She described the forecast as definitely not a no-go, but it's something they're going to have to watch and keep themselves in a position to be able to launch on time, and that's what they've been doing so far, hoping that they'll get that break in the weather and they'll get that fortuitous forecast and actually have that 30% chance of good weather, be 100% chance of a good, safe launch for Atlantis this morning. The 4 astronauts for the STS-135 mission, Commander Chris Ferguson, pilot Doug Hurley, and mission specialists Sandy Magnus and Rex Walheim, were scheduled to wake up about 5 minutes ago and start their launch day activities. They're at the crew quarters at Kennedy's Operations and Checkout Building. We were able to get into that crew quarters about a week ago before the crew actually arrived. And you're taking a look at the quarters. This is an example of what their rooms look like. This is their breakfast room. You can see that's very much like has been described as a college dorm room, and it has that very similar feel, very Spartan conditions. This is where the crew will be having their traditional breakfast, which is scheduled for 5:45 this morning. Crew quarters is about a 10-mile drive from the launch pad. Their meals are prepared there. They have a kitchen staff. They also, of course, have a gym in the crew quarters to help keep their physical fitness at peak conditions. When the crew's getting ready for a launch, they're in quarantine, so therefore they're not allowed to have a lot of contact with people who are not what are known as health stabilized. You know that their conditions, they're in good health and not have the possibility to get them sick before their mission. This particular briefing room has computer simulators that allow them to practice docking and other last-minute refresher information. Of course, it's also the medical facilities at crew quarters where they are checked out, where they're expected to get their final checkups, and that'll take place at about 5:30 or so. And of course, this is where they get suited up as well, ready for their flight, and that'll take place a little after 7 o'clock this morning. That clock there is apparently, they describe it as extremely important. They change it every single time, and the crew really knows when they have to suit up and when they have to leave, and that is the clock apparently the crews go by. Of course, let's take a few minutes now and take a closer look at the 1 woman and 3 men who will fly the shuttle program's final flight.
With the final flight of Shuttle Atlantis and its crew of 4 astronauts, the Space Shuttle era comes to a close, and America and the world bids a final farewell to a sleek and one-of-a-kind ship that has helped history unfold in low Earth orbit. It all started more than 3 decades ago. 2 Americans, John Young and Robert Crippen, blast off on a winged spaceplane named Columbia. Now, more than 30 years later, with the 33rd and final flight of Atlantis, NASA adds a fitting coda to the Space Shuttle program. Even as the shuttle program ends, the STS-135 mission will help ensure humankind can continue to live and work in space. Atlantis carries the Raffaello Multipurpose Logistics Module, or MPLM, to deliver a year's worth of supplies and spare parts for the International Space Station. The orbiter delivers a system designed to remotely test the robotic refueling of satellites and return a failed cooling pump to Earth. From a historical perspective, the STS-135 astronauts are the first crew of 4 since STS-6 in 1983. Retired Navy Captain Chris Ferguson commands Atlantis' crew as he makes his 3rd trip to orbit. He first flew on Atlantis as the pilot of STS-115 in 2006, then returned to orbit as commander of Endeavour on the STS-126 mission. The pilot of Atlantis is Marine Corps Colonel Doug Hurley. His first spaceflight, STS-127, coincided with the 40th anniversary of Apollo 11 in 2009. He will be at the controls as Atlantis undocks from the ISS for the shuttle's historic departure from the station. Dr. Sandy Magnus is Mission Specialist 1. A veteran of 2 space flights, she served as ISS Science Officer for Expedition 18. She first flew on Atlantis during STS-112 in 2002. Mission Specialist 2 is retired Air Force Colonel Rex Walheim. This is his 3rd and final spaceflight aboard Atlantis after STS-110 and STS-122.
And we're back here live at NASA's Kennedy Space Center in Launch Pad 39A, where the launch team is not working any technical issues right now that would prevent us from launching on time to start the STS-135 mission at 11:26 a.m. Eastern at T-minus 3 hours, 19 minutes, 22 seconds and counting. This is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours, 13 minutes, 8 seconds and counting. The launch team is not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. Start of tanking began on time at 2:01 a.m. Eastern. That's the process of filling the external tank with about 535,000 gallons of liquid hydrogen and liquid oxygen. We went into liquid hydrogen stable replenish at 4:34 a.m. and the liquid oxygen fast fill started at 2:52 a.m. So we have been running on time or ahead of schedule the entire tanking process. Stable replenish is when technicians have control and continue to top off essentially the liquid hydrogen part of the tank, keep it at a 100% level. We went into stable replenish again at 4:34 a.m. Eastern on the liquid hydrogen side, and the liquid oxygen side should be coming up next 10 minutes or so. Atlantis' 4 astronauts woke up about 20 minutes ago to start their launch day activities. For them, coming up at the top of the hour at 5 a.m., they'll begin their final medical checks in the operations and checkout building crew quarters here at Kennedy. Also at 5 a.m., just 1 minute after, we'll be just about ready to go into the next built-in hold in the launch countdown, and that's at the T-minus 3 hour point. And of course, we'll then actually be right about where we should be, finishing up the tanking process for Atlantis' flight. So again, the launch team is not working any technical issues that would prevent us from launching on time. We've had a relatively quiet weather morning so far. The concern is that around launch time, when we get that heating we experience about mid-morning, you might start having some thunderstorms and rain encircle the launch pad and be around the Kennedy Space Center and prevent us from actually launching this morning. But right now, no weather issues or technical issues to worry about, and the launch team is trying to be guardedly optimistic about having good weather conditions for a favorable on-time liftoff this morning at 11:26 a.m. At T-minus 3 hours, 10 minutes, 24 seconds and counting. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours, 37 seconds and counting. We're less than a minute away from going into our next built-in hold to the T-minus 3 hour point. And this will be a 2.5 minute scheduled stop in the countdown. We've also completed the fueling process. It was officially complete at 4:58 a.m. Eastern. It started on time at 2:01 a.m. Eastern. The launch team is not working any technical issues that prevent us from launching on time at 11:26 a.m. this morning. And we are in 5, 4, 3, 2, 1. We are at T-minus 3 hours and holding. The launch team has been on time or ahead of schedule with the entire tanking process. Tanking is what's known as really filling the external fuel tank with approximately 535,000 gallons of liquid hydrogen and liquid oxygen. Their technicians are at a point right now where the engineers can keep stable control of the amount of propellants entering the tank and keep it at the 100% level on both the liquid oxygen and liquid hydrogen side. The current 2.5 hour built-in hold is the third to last stop in the countdown. There are 7 built-in holds, intentional clock stops, with a total full 70 hours and 21 minutes of countdown time. And it starts at the T-minus 43 hour point. This particular launch countdown began at 1 p.m. Eastern on Tuesday. Managers and engineers are directing and monitoring Atlantis' countdown on launch pad 39A from about 3 miles away in firing room number 4 here in the Launch Control Center. Atlantis' STS-135 mission has 4 veteran astronauts: Commander Chris Ferguson, pilot Doug Hurley, and mission specialists Sandy Magnus and Rex Walheim. They woke up about 30 minutes ago to start their launch day activities, and now are currently scheduled to be receiving their final medical examinations inside the crew quarters at Kennedy's Operations and Checkout building. This final space shuttle flight actually is exactly what the original dreamers of a shuttle had in mind: a spacecraft resupplying an orbiting space station. And the STS-135 mission will bring more than 8,100 pounds of cargo to the station, all packed, the majority of it packed inside the Raffaello multi-purpose logistics module. And of that 8,100 pounds, more than a third of it is food for future station crews. With the supplies on board Atlantis, the International Space Station will be in good shape through all of 2012, when U.S. commercial companies under contract with NASA are expected to begin resupply flights to the space station. Atlantis' crew also is bringing an experiment called the Robotic Refueling Mission, which we put on the station's exterior during the next 2 years, together with the Canadian Dexter robotic arm. We'll test tools, technology, and techniques to robotically refuel space, in particular satellites, including those that were never intended to be refueled while they're in space. The crew also will return to Earth a failed space station cooling system ammonia pump, and the flight also has 1 spacewalk while Atlantis is docked at the space station, but it'll be carried out by the 2 NASA astronauts aboard the International Space Station right now and supported by the Atlantis' crew members. Looking at the STS-135 mission by the numbers, this is the 135th shuttle flight and the 37th shuttle mission to the International Space Station. This will be Atlantis' 33rd mission overall, and obviously, yes, its final flight. Currently, STS-135 is a 12-day flight, but with a launch this morning, and once Atlantis gets to the space station, and managers can assess how well the crew has been conserving the cryogenic reactants inside the shuttle's 3 electricity producing fuel cells, they may add a day of docked operations to the mission, so that could put landing back here at the Kennedy Space Center either on July 20th, a little after 7 a.m. Eastern, or July 21st, a little after 6 a.m. Eastern. Once Atlantis does safely return to the Kennedy Space Center, it will begin a slow deservicing process and preparation to be eventually put on public display. And teams won't have very far to take Atlantis, just down the road to Kennedy Space Center's visitor complex, which has the honor of being able to display Atlantis, the only space shuttle NASA will keep. Discovery is going to the Smithsonian outside Washington, D.C., and the Endeavour is going to the California Science Center in Los Angeles. NASA will transport the shuttles to their respective public display sites starting next spring. So this will be the last flight for Atlantis, which was the 4th space shuttle in NASA's fleet. And it made its first maiden voyage almost 26 years ago. Shortly, now that we're in stable replenish and we've done with the refueling, the fueling process for Atlantis, the closeout crew and final inspection teams will be dispatched to Launch Pad 39 to begin their respective jobs. Closeout crew goes to the pad's white room, and it's the access area to the hatch for Atlantis, where the astronauts will board the shuttle. And this 7-person crew will help secure the astronauts into the shuttle and then close Atlantis' hatch. The 7-person final inspection team, which is also known as the ICE team, will go to the pad surface to begin its inspections. Those team members provide the direct eye contact with the shuttle to make sure things aren't amiss. And the group actually is part of a much larger team looking very closely at the shuttle. So let us take a look now at all the imagery activities that will go into this morning's final space shuttle launch.
2, 1. Booster ignition and the final liftoff of Discovery.
Perhaps one of the most impressive images is that of a space shuttle lifting off the launch pad, riding plumes of bright orange flames. But more than just providing an impressive sight, shuttle images play a critical role in launch safety. Each successful launch depends heavily on still and video images that allow the launch team to closely scrutinize the spacecraft both before and during liftoff. Long before the main engines fire and the solid rocket boosters ignite, the entire shuttle stack has been thoroughly photographed and continually monitored by TV cameras as the countdown clock ticks down. Members of a group called the Final Inspection Team play a key role, providing the imagery directly from the launch pad and analysis from the Launch Control Center.
The images we take on the Final Inspection Team are sent back to the LCC. When we give the report to the mission management team and to the launch director, to the SPE, they can look at our imagery, and in particular ones we single out and tell them that we know there's a problem here. They can do analysis of their own on those images.
The team members can identify and photograph problems that might go undetected without their on-the-spot inspection. But the launch director and his team aren't limited to just images from the inspection team.
In the LCC, we have the ICE-Frost console, and we continuously monitor upwards of 135 different camera locations. Those assets are controlled by NASA and other contractors. Some as far as, I believe, close to 20 miles south and 20 miles north of the launch complex. And some of these assets are basically large telescopes, and they will be able to film the orbiter several minutes into its flight profile. We also have about 60 cameras within the actual perimeter of the launch pad. Some are various assets, some are infrared, some are HD, some are standard, some are at higher speed and slower speed. A lot of them are at about the 400 frames per second, so we can catch a very, very slow behavioral aspect of each vehicle component. Because some components we want to watch how they work the moment they're supposed to go to work. And we'll see them frame by frame. We watch them frame by frame.
So as the final space shuttle pierces the sky over NASA's Kennedy Space Center in Florida, both technology and trained eyes will once again be keenly focused to ensure a safe and successful mission.
And we're back now live looking at Space Shuttle Atlantis on Launch Pad 39A, where it is fully fueled for its launch attempt this morning. Again, we started the tanking process on time at 2:01 a.m. Eastern and wrapped up the tanking process slightly ahead of schedule at 4:58 a.m. Eastern. See from this shot in the distance the xenon lights bathing the shuttle in its launch pad. And on the, you can also see fire at the launch pad, which of course is okay because that's fire from the flare stack, which is burning off the excess hydrogen gas that comes from the external tank during the tanking process. Earlier this evening, before the tanking meeting at 1:30 this morning, as we were driving in, there was a large cloud deck that was over the pad, and these xenon lights were illuminated, casting shadows on those clouds. Since then, the forecast has, although it's remained at 30% for favorable conditions at launch time, the overnight hours have been very benign, and we've had no issues at all with the weather, no lightning, unlike what we had yesterday, and no real weather to speak of. The concern is that around mid-morning, with the sun heating the Florida landscape, we'll get these thunderstorms and rain could be around the Kennedy Space Center, and that's why we have only a 30% chance of having good weather. But based on the conditions they've seen overnight, the launch team has been guardedly optimistic. While the forecast is obviously not great, as NASA likes to say, it's been trending in the right direction. The closeout crew and final inspection team are making their way up to the launch pad surface now to begin their respective jobs. The final inspection team will begin on the pad surface and start its inspections, and of course the closeout crew will head to the white room to start preparing it and the hatch and interior parts of the shuttle's flight deck and middeck for when the astronauts will arrive around 8 o'clock this morning. So again, the launch team is not working any issues that would prevent us from launching on time at 11:26 a.m. Eastern. We currently have 2 hours, 18 minutes, and 5 seconds remaining in this built-in hold. So at T-minus 3 hours in holding, this is shuttle launch control. This is Shuttle Launch Control at T-minus 3 hours in holding. We currently have 2 hours, 11 minutes, and 40 seconds remaining in this scheduled stop in the countdown. Launch teams are not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are still calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station. What you're watching right now is members of the final inspection team, also known as the ICE team. They're at the pad surface beginning their walk down, an inspection of various parts of the gantry and of course looking at the Space Shuttle itself. Quickly recapping the times of tanking, which began on time at 2:01 a.m. Eastern. That process to fill the external tank with approximately 535,000 gallons of liquid hydrogen and liquid oxygen did start on time and actually wrapped up a few minutes early. Went into stable replenish for both of those propellants at 4:58 a.m. Eastern. The final inspection team is a 7-person crew that evaluates the external tank under cryogenic conditions now that those 2 supercold propellants are loaded into the external tank. I'm looking for any frost or ice that could possibly build up and be a debris source during launch. And they look at, of course, anything else that could be amiss out there at the launch pad. Team plans to take about 2 hours to perform its inspections, and which of course begin at the pad surface and then move up to the top to the 255-foot level, and then proceed down the fixed service structure of the pad to the 215-foot level, the 195-foot level, which is where the astronaut walkway, orbiter access arm, where the crew enters the hatch and gets into Atlantis, and where another 7-person team, the closeout crew, is setting up to begin its work, preparing the white room in the shuttle for the astronauts. You can see the view right now from the white room. This final inspection team outside and the closeout crew inside, getting the what's known as the white room ready. A little after 8 o'clock this morning, Atlantis' 4 astronauts are scheduled to be joining the closeout crew in that very room to crawl into the hatch and begin getting strapped into the shuttle itself. So once the final inspection team is done with the 195-foot level, and the crew members then move down to the 135-foot level, and then actually down to the mobile launcher platform surface itself, where they are currently. So everything has been going on time or ahead of schedule this morning. The launch preparations for Atlantis. The only concerns have been so far the forecast of having unfavorable weather around mid-morning, the possibility of thunderstorms and rain in the area after we get the mid-morning heating. Currently, all of our observed conditions are green. It's been a very benign night for weather, actually, especially when compared to yesterday when we had a couple of lightning strikes at the pad. You can see that launch commit criteria, which is our launch rules, currently all in the green. Shuttle Weather Officer Kathy Winters has been talking to Shuttle Launch Director Mike Lambach periodically this morning, providing him updates. One of her last ones, she said that the forecast is definitely not a no-go. So it's nothing as she could say is there is no possibility of having good weather. It's just that given the forecast they have, it still keeps them at that 70% chance of not having good weather. But the launch team, of course, is hoping for, since we've had such a good run at on the hardware side, that we'll get a fortuitous forecast that will allow us to have a on-time liftoff, and the weather will cooperate. Again, the team is not working any technical issues that would prevent us from launching on time at 11:26 a.m. Eastern. We have 2 hours, 6 minutes, and 48 seconds remaining in this current 2.5 hour built-in hold. So at the T-minus 3 hour and holding point, this is shuttle launch control. This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida at T-minus 3 hours in holding. We currently have 1 hour, 54 minutes, and 20 seconds remaining in this 2.5-hour scheduled stop in the countdown. The launch team is not working any technical issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station, which is the final flight for the Space Shuttle program. Obviously, with a 30% chance of favorable conditions, that means we have a 70% chance of not favorable conditions. But the launch team is hoping that as things have been going this morning and kind of trending in the right direction, as we like to say here at NASA, that will hold up, and the mid-morning heating that could trigger thunderstorms and rain around Launch Pad 39A won't take place, and that'll give us just the opportunity we need to safely start Atlantis' mission. Tanking started on time at 2:01 a.m. Eastern. That's a 3-hour process. Filled the external tank with approximately 535,000 gallons of liquid hydrogen and liquid oxygen, and we wrapped up that, went into stable replenish, slightly ahead of schedule at 4:58 a.m. Eastern. The 4 veteran astronauts for Atlantis' STS-135 mission, Commander Chris Ferguson, pilot Doug Hurley, and mission specialist Sandy Magnus and Rex Walheim, are finishing up their final medical exams inside their crew quarters at Kennedy's Operations and Checkout Building. They'll be settling down to the most important meal of the day in a couple minutes, breakfast. In the Mission Control Center at NASA's Johnson Space Center in Houston, the ascent team that will guide Atlantis and its crew during the first steps of the STS-135 mission, immediately following launch, of course, are on console now. They'll do that at 5:30 a.m. Eastern. But here in the Launch Control Center at Kennedy, the teams have been on console around the clock for days leading up to this morning's launch attempt. And we're being joined right now in fire room number 4 of the Launch Control Center by Charlie Blackwell-Thompson, the head of NASA's Test Director's Office and the STS-135 Chief NASA Test Director. Charlie, thanks for taking a couple minutes out of your schedule to come talk to us on camera.
It's my pleasure to be here, Allard. Thank you for having me.
Well, let's see, we always like to start off, if you're just joining us, and what does a NASA Test Director do?
Well, let's see. Before I launch into what the NASA Test Director does, I'd like to talk.
Launch, that's good. I like that.
I'd like to talk a little bit about what the other folks in the room do, and I think that's a good way to lead up to it. Let's see. As you can see here in Fire Room 4, at all of our consoles, we have our system engineers and our system specialists, and they're monitoring and controlling hardware. There are similar rooms in other areas of this building and in other centers across the country that are also monitoring hardware. And within our STS system, we have different element test conductors. Roberta Wyrick is our orbiter test conductor this morning, and she's working with the ASP and the closeout crew as they prepare for the flight crew arrival. And the element test conductors are responsible for sequencing and integrating the work for a particular element. And so, as I said, Roberta is currently focused on the orbiter, getting it ready for the flight crew. Similarly, we have a tank and booster test conductor, and you probably heard them working with the C3, C4 team this morning as we work through our tanking operations. There's also a payload test conductor, and they're focused on the payloads and the mid-decks and any activities associated with the payload elements. And then the support test management folks are really focused on the ground systems and making sure that that all of the work there is accounted for and integrated. And so the NTD works across those different test conductors and different test elements to make sure that we integrate across elements well and to sequence the work appropriately. In particular, we always focus on those major hazardous activities or those activities that involve the flight crew.
And it seems like you guys are integrating quite well this morning. The internal loops, the talkback system that you use here in the firing room, it's been very quiet this morning.
It has been we don't like to say that word too much.
Oh, sorry.
It's been a good morning. We got into our tanking operations just after 2 o'clock, as you said, right on time. Gave the go for tanking and got both of the commodities into stable replenish. I think we had hydrogen at right around 0433, and then about 0458 LOX was in stable replenish. Again, a little bit ahead of schedule, but very good tanking. No issues to report at all. It was very smooth.
And the count overall since Tuesday when you started the official countdown at the T-minus 43 hour point, it seems it's been pretty smooth at least.
It has been. You know, yesterday we watched the weather close. We had some weather that rolled through the area, delayed our RSS rotation back to the park position a bit, but you know, certainly nothing that, you know, we couldn't recover from. But we watched it closely yesterday, and really nothing really to talk about from that. We did go ahead and do some walk downs as a result of some of the weather that came through, but that was probably the most exciting thing yesterday. And it has been a very, very smooth launch countdown so far.
Well, the weather did keep our attention all yesterday afternoon, and of course, I've been hearing all morning. That's what you're going to be looking at when the sun gets up and starts doing its magical thing with heating the ground. But again, we'll have to see how that goes, and so far so good, at least with everything else leading up to it. Now we are currently in a 2.5 hour built-in hold. I get asked this question all the time, public and media, so that's why we ask, why do you intentionally stop the clock? Why not just start at whatever point you want to and then keep counting down?
Well, that's a really good question, and you know, I get that question as well. If you think about how we use the countdown clock, we really use it to synchronize work, not just here in this firing room, but across the country. And if you think about when we have those holds that are built in, they're usually at strategic locations. A lot of times they'll bracket major milestones in the countdown or major hazardous activities, and the reason is that as you go into those, you want to make sure that you have all the work complete and that you're ready to go. And then a lot of times you'll have a hold after one of those activities because you want to have a little bit of margin there if you need to go catch up. If you know, we have a hold at T-minus 27, and then we have another one at T-minus 19. Those bracket our PRSD load. Both of those, I mean, that bracket is, you know, PRSD load, so weather-sensitive activity, and so it gives us an opportunity that if we're running a little bit late, making sure we got all of our work complete, and then again, a little bit of a catch-up point afterwards. T-minus 11, that's where we do the RSS rotation. COM activation involves a lot of, also we do COM activation, that involves a lot of centers across the country. And then at T-minus 6, of course, that's our hold prior to tanking, and then T-minus 3 is our one just after tanking. So when you look at the holds in terms of where they're placed in the countdown, it kind of makes sense because it allows you, like I said, either an opportunity to catch up or take a collective pause as a team before you go into a major activity, or it gives you a little bit of margin on the backside of it in the event that you're running a little late.
Now, I think pretty much everybody has heard this is the obviously expected to be the last space shuttle flight ever. So, and you've been with the program a while, so I have to ask the question: how do you feel about this being the very last mission? You know, do you have any special stories you could share with everybody?
Well, let's see. I have been here a long time. You know, I came here to Kennedy Space Center in 1988. I just graduated from Clemson University, and I was just a kid right out of school. And I've had the pleasure of working in this firing room at different locations during those 23 years, and that's a really wonderful feeling as we close out the program. As far as a special story as it relates to the Atlantis mission, you know, we all have special stories about all the orbiters, and there's so many with regard to Atlantis, but one that's very personal for me is my first launch as the shuttle test director was the STS-1 was supposed to be the STS-125 mission, which was an Atlantis mission. So when I did all of my training and Su-44 runs and Su-17 runs and the preparation for that, it was all with the Atlantis team and with the Atlantis vehicle. And so that's a very special mission for me, and because it was during my training as a shuttle test director, and it turned out that it didn't end up being my first launch because we had an issue with Hubble on orbit, and the launch ended up getting delayed, if you recall, for some months. And so the way it worked out, it wasn't the first vehicle that I was able to launch, but certainly very sweet memories for me as I was coming up doing all of my training.
So I have to ask, with the end of the shuttle program, officially 30 days after wheels stop, what's next for you?
Well,
oh, I've stumped you. That's not so good.
Well, you haven't really stumped me. I guess, right now, this is such a wonderful time for me that I just want to savor, what we're doing now. Again, having been a part of this team for a long time, and I really think that they do amazing things and really achieve great results. There's not a problem that you can't put in front of this team, a challenge that you can't put in front of them that they can't go meet. And so right now I'm really focused on this launch, this mission, and this landing. But once 135 is back home here at Kennedy Space Center, I will transition to the ground processing directorate, and so I'll be working there, and we'll certainly be focused on that next generation of customers and vehicles, and I look forward to being in a firing room, either this one or one like it, when we launch a vehicle here from Kennedy Space Center or Cape Canaveral Air Force Station, returning to the International Space Station or to that next era of exploration.
But way before that can happen, like you said, you've got a launch and a mission and a landing to have in front of you, and we're not there yet. So I'm going to let you get back to that, because we're getting, obviously, I know you have other operations you need to take care of, and I know that I appreciate you taking a couple minutes out of your schedule, because this is when you really start, now that tanking's done, this is when you really start ramping up your particular set of responsibilities. So thanks for taking a few minutes to talk to us.
It's my pleasure, Allard. Thank you.
And that was Charlie Blackwell-Thompson, the head of NASA's Test Director Office here at the Kennedy Space Center, and the STS-135 Chief NASA Test Director. And as you heard Charlie talk about, we're not working any issues that would prevent us from launching on time at 11:26 a.m. Eastern, with 1 hour, 42 minutes, and 27 seconds remaining in this current built-in hold. We're at T-minus 3 hours in holding. This is shuttle launch control. This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida. We're at T-minus 3 hours in holding, and there are currently 1 hour, 36 minutes, and 27 seconds remaining in this 2.5-hour built-in hold in the countdown. The launch team is not working any issues right now that would prevent us from launching on time at 11:26 a.m. Eastern. Currently, forecasters are calling for a 30% chance of good weather for this morning's launch of Space Shuttle Atlantis on its STS-135 mission to the International Space Station, the final flight for the Space Shuttle program. The recap of our tanking times. Tanking started on time at 2:01 a.m. Eastern and wrapped up at 4:58 a.m. Eastern. The closeout crew and final inspection teams are at Launch Pad 39A, and they're now carrying out their responsibilities related to Atlantis. And as you'd imagine, there's been a lot of attention leading up to this morning's launch attempt for Atlantis. This final Space Shuttle launch is getting a high amount of media and public attention, of course, as well. There are about 45,000 people, official NASA guests, that are expected to be here this morning on Kennedy Space Center property to watch Atlantis' launch. Those include VIPs and the general public at the Kennedy Space Center Visitor Complex and U.S. Astronaut Hall of Fame. Also includes media. But that 45,000 official guests don't include the thousands of employees who work here at Kennedy, and of course probably will go outside their offices and take a look at launch this morning. And it does not include the anticipated, the possibility of having as many as 1 million people who may come to the area to line the beaches, roads, and riverfronts around Kennedy to see the liftoff. Joining the couple thousands of media that are at Kennedy's press site this morning, across the street from the Launch Control Center, are more than 150 people who use the social media site Twitter. They've come here for NASA's 5th Space Shuttle launch tweet-up. The 150 tweeters come from 44 states and the District of Columbia and 11 other countries. Yesterday, the group had the time to talk to engineers and scientists and astronauts who are also part of the launch experience, and of course Bill Gerstenmaier, the head of spaceflight operations. And between them they have
our first guests are going to talk about International Space Station.
So 1.5 million different followers. Of course, they were joined by a special guest.
A few things. One thing that's important, Elmo, is to be able to get...
NASA is always, of course, heavily involved in trying to inspire the next generation of scientists and engineers and astronauts through focus on science, technology, engineering, and math, or all known as STEM. So there's no reason to not start the very early of the next generation, even the preschool next geners. And one of those tweet-up attendees, you can see, was very big with the 4-year-old and younger crowd at Sesame Street's Elmo. That crimson crusader of education from the Muppet world is at Kennedy to learn about the importance of space exploration at NASA.
Case scenario, so. Look, you see different things that you don't normally see down on Earth. You get to see the moon and the stars up close. And you get to move like this.
Elmo's doing some filming here at Kennedy, and you'll likely see some of that online at Sesame Street's website. Of course, as being part of that tweet-up of their 1.7 or so million followers, it's that old shampoo commercial idea that they tell two friends and so on and so on and so on. And you can see that through the 200 or so tweeters that we'll have today. We invited back 50 or so who were of the previous tweet-ups were not actually able to see the launch because of delays or whatnot, have been invited back to actually get a chance to see one last shuttle launch. So through those 200 people, we'll be reaching millions of other people just through that social media network. Turning our attention back to the launch countdown, let's look at what some of the major milestones coming up. We look to launch at 11:26 a.m. Crew will begin suiting up in the operations and checkout building, crew quarters in Kennedy, at 7:06 a.m. and the countdown will officially resume the current 2.5-hour built-in hold that we're at 7:31 a.m. 5 minutes later, the crew will depart the operations and checkout building for Launch Pad 39A. And by 8:06, the crew is expected to be boarding Atlantis. And obviously we've been talking a lot this morning about this being the final Space Shuttle program flight, but obviously this isn't the last of NASA's human spaceflight program. There are 2 NASA astronauts living and working aboard the International Space Station who are proof positive of that. We expect there will be astronauts launching from NASA's Kennedy Space Center in the coming years, first on U.S. commercial spacecraft to the space station, and then on NASA's heavy lift rocket inside the Orion multipurpose crew vehicle, to locations that are farther out into our solar system. And it's been said that every new beginning comes with some other beginning's end, and yes, this is the shuttle program's end, but it's helped start a new beginning in human spaceflight, one that builds on the successes of the people who flew this spacecraft for 30 years and learns from them. And we will reach farther into space because we stood on the shoulders of the shuttle program giants. Again, the launch team of the shuttle program is not working any issue to prevent us from launching on time at 11:26 a.m. Eastern. We're going to take a short break from commentary right now, but we'll be back at 6:30 a.m. Eastern with NASA commentator George Diller. And 6:30 a.m. also is when NASA's official Shuttle Atlantis launch blog will begin at www.nasa.gov/shuttle. That's also where you can follow anytime Space Shuttle Atlantis' STS-135 mission to the International Space Station, the last flight of the world's first reusable spacecraft. At T-minus 3 hours and holding, this is Shuttle Launch Control.
From Launch Complex 39 at the Kennedy Space Center in Florida, this is Shuttle Launch Control at T-minus 3 hours and holding. We have approximately 1 hour and 45 seconds remaining in this planned built-in hold. And we're now in the final 5 hours of the countdown for the launch of the last flight of the Space Shuttle program and Space Shuttle Atlantis on STS-135. The countdown is being controlled from Fire Room 4 at the Launch Control Center, and we're on schedule for a liftoff targeted for 11:26 a.m. This is the 135th launch of the Space Shuttle program, the 33rd launch of Space Shuttle Atlantis, its 12th to the International Space Station, and overall the 37th flight to the International Space Station by the Space Shuttle. This is currently planned as a 12-day mission that would have the landing at Kennedy Space Center occurring on July 20th. We're going to look now at some video of the rotating service structure, the gantry being pulled back from around Space Shuttle Atlantis yesterday afternoon. That occurred at 2:38 p.m. in conditions not unlike what we have at the moment. It was cloudy with some showers. And altogether it took about a half an hour to move the rotating service structure back into the fully parked position. Rotating service structure is the gantry that surrounds the Space Shuttle when it's on the launch pad. It provides access to the Space Shuttle and particularly to the payload bay so that the payload can be installed into the orbiter. And as well, it is also the weather protection for the shuttle while it's on the launch pad. The rotating service structure is 130 feet in height and rotates a third of a turn away from the shuttle before launch. Once the payloads are in the payload change-out room with a rotating service structure, they can be installed into the orbiter with a telescoping device called the payload ground handling mechanism. This also has 5 levels of access platforms that extend inside the payload bay of the shuttle to provide working access to the payloads. And the shuttle, as we see it there, weighs about 4,500,000 pounds. And once the orbiter is on its own and comes back for a landing, it'll weigh only about 6% of what it weighed at launch. We're now at T-minus 3 hours in holding with 57 minutes remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours in holding with 54 minutes, 45 seconds remaining in this planned built-in hold. We're going to look now at some video of some of the activities that were underway to prepare Space Shuttle Atlantis for its launch today, going all the way back to the beginning of the flow when our first flight hardware began to arrive. These are the solid rocket boosters. They arrived by train customarily, making a long cross-country trip all the way from Wasatch in Utah, coming across the country on Union Pacific, Kansas City Southern, CSX, and Florida East Coast Railway. The barge brings in the external tank. This was on July the 14th of 2010. The solid rocket boosters that arrived just ahead of that in May of 2010. Once the tank is in the turn basin, it is offloaded from the barge and towed to the vehicle assembly building, where inside it will undergo some brief initial checkout before it's rotated to vertical and put into a test cell. And then it is later, after the solid rocket boosters have been stacked on the mobile launcher platform, it is lowered into position between the two solid rocket boosters. The solid rocket boosters are built up first, then the external tank is lowered between the two of them, and then the orbiter will join them later. Here is the main engine installation. Customary 3 engines are installed and then tested. This is the landing gear test. This was on January the 25th, 2011. One of the numerous activities that go on in the processing to prepare Atlantis for launch. These are the many thermal protection system tiles. That was the elevon being raised into position. This is some of the tile work. One of our tile engineers from United Space Alliance. We have a combination of high temperature tiles on the underside and lower temperature tiles on the upside. This is the closing of the hatch between the payload bay and the orbiter's airlock and mid-deck area. Here the hatch is being cleaned as it's closed for flight. The payload remaining still to be installed. The KU band antenna is deployed in a test to assure that it will deploy properly. Before the payload bay doors are closed, the KU band antenna will be providing a lot of the video that we'll see during the mission.
So once there's still over, if the sensor worn off, it down.
This is the power-up of the orbiter in the high bay, the orbiter processing facility, to some of the checkout activities, particularly the crew equipment interface test activities. And then Atlantis is ready to be backed out of the orbiter processing facility and takes about a 20-minute trip over to the vehicle assembly building transfer aisle. Opportunity for the crew who's worked on Atlantis to wish her well. Once in the vehicle assembly building, the lifting sling is attached and Atlantis is rotated to vertical so that it can be hoisted and mated to the external tank solid rocket booster stack. And once it's hoisted up, it will go across the transom. It's rotated slightly, clears the transom by about 8 inches, and then it's lowered. As we see right adjacent and next to the external tank, that sets us up for the rollout, which was on June the 1st of this year, heading out to Launch Pad 39A for the final flight of the Space Shuttle program. About a 6-hour trip at about 1 mile an hour on the way to the pad. And that's a live picture of Space Shuttle Atlantis now on Launch Pad 39A. And joining us here in the firing room is Angie Brewer. She is the flow director for Atlantis, OV-104 as it's known. And Angie, can you tell us a little bit what's been different about this flow compared to others?
Well, to start out with, this is our second last flow. 132 was supposed to be the last flow of Atlantis, or the last launch of Atlantis, but it started out as a launch on need. This mission, STS-135, was originally STS-335, and we were going to be a launch on need mission if STS-134 needed it. Earlier this year, we got approval to fly STS-135, so when we started the flow, we didn't know if we were going to fly, but we were processing like we were, and we were able to get a flight, and we're happy to be here.
Well, one of the things that we did this time was a tanking test. We filled the external tank with propellants, much as it is today, but in what ways did that turn out to have benefited us for this flight?
Yeah, we did a tanking test, and that was as a result of the STS-133, ET-137, where they had a crack in the tank, and because our tank is similar in pedigree to that tank, we chose to do the modification and then perform a tanking test to verify that modification worked, and it did. And it turned out to be a blessing in disguise, because the main fuel valve on engine 3 had a leak, and we were able to find that, because it would have been a scrub on that day if that had been our launch day and we hadn't done the tanking test. But fortunately, we found that, and we were able to replace it. And today, when we did our tanking test, it's working just fine.
Well, once Atlantis comes back, what will happen to it, since this is its last flight?
Once it comes back, it'll do its down mission processing, get the payload off, and then get all of its commodities and hazardous commodities off the vehicle, and it'll be prepped for wherever it's going, or to the visitor center here
right,
at
it's
Atlantis.
going to be the one that stays here at Kennedy. So, well, Angie, thank you very much, and best of luck today. And I'm sure that weather permitting, certainly Atlantis will certainly represent the agency well for the last flight of the Space Shuttle program.
Yeah, thank you, George.
Thank you very much. 45 minutes remaining in this built-in hold. We're at T-minus 3 hours in holding. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours in holding. Just under 44 minutes remaining in this built-in hold. And joining us now is Joe Delay. He is the STS-135 payload manager, and he has been busy for some time stocking Atlantis with all of the supplies and spare parts that the space station is going to need for the next year or so. Joe, first of all, tell us: is the understanding basically correct that this is a logistics flight? Is that what this is intended primarily to do for us?
George, you're absolutely correct. One of the main objectives of this flight was to get ISS supplied again for about a year. Cargo, supplies, personal items, spare parts, science experiments, and as you mentioned, we have the MPLM filled with all these supplies up to about 8,200 pounds, which is volume-wise the most we've ever brought up in the past. So this is a very important mission for all of us.
Well, Joe, we've got some video now of some of the activities we did to prepare the payload for the launch. So if we could go ahead and roll that tape, and Joe, if you could tell us what we're seeing.
You bet. Okay, so it looks like we're in the SSPF, and they're getting ready to install the RRM onto the external carrier. That is the remote refueling mission, and this is a very unique experiment for us. It's kind of a first of its kind, where they're going to be robotically checking out and experimenting how to refuel aircraft on orbit, and we'll be watching that very carefully for future missions. And then what you're seeing here is you're seeing the racks that are being stowed with cargo, and they're being lifted and installed into the module. So total, we have 16 racks, and each rack holds various amounts of weight. We actually did some modifications to some of the racks down here that increase its weight by 200 pounds. This picture is we are getting ready to take our external carrier, which has the refueling experiment down below, and there's an adapter plate on top, so we can bring back the filled S1 pump so we can take a look at that. And it's going into the canister so we can get ready to go to the payload. The LMC that you're seeing, the external carrier, weighs about 2,906 pounds, and then when the module's done, you'll see that being lifted in. That weighs 25,359 pounds total weight, and you can see it's very very tight. Volume-wise, a lot of packing went into the module, and now we're getting the aft end cone secure, and then we'll be doing purges and leak checks, pressure checks in the module. And then here in a few minutes we'll be lifting that and putting that also into the canister. Most of this work happened around the April-May time frame. The goal originally was to get the payloads out to the pad based on the original launch date of June 28th at L-12, because we wanted to keep the hatch open as late as possible so we can make sure we get all the assigned cargo into the MPLM. So we're lifting the MPLM, we'll do a wait and CG, and then that will be brought over to the canister. Really interested, going back to the robotic refueling mission, it's the future refueling and repair of on-orbit spacecraft. The robotic refueling mission will perform what we call representative tasks, George. We're going to be turning valves, opening up QDs, transferring simulated fuel. The objective here is to prove that we can do that in space and eventually have robotics go up and service and repair on-orbit spacecraft and satellites. So we're in the canister, and we're at the canister rotation facility. And that was around June 14th of this year, and we're going vertical, and then from there we'll go out to the pad 2 days later, which will begin on the 16th. Another payload that we have on here that I'd like to mention is the DoD PicoSat. It's a PicoSat Solar Cell 2. The second time we've flown this will be on a sidewall in the orbiter, and the DoD will be working that. And basically, what that does, George, is it's going to allow them to perform different types of tracking demonstrations at various orbits in space. Well, that's a beautiful picture of getting the canister to the pad, and then lifting the canister up into the payload changeout room, so we can move the payloads into the PCR and open up the doors, and then get ready to put the rotating service structure back over the orbiter, so we can get the payloads into the shuttle. And while that's happening, we also have a lot of different science experiments flying on this mission in mid-decks. This is probably the busiest launch that I've seen probably since my Space Lab days. We're bringing up 6 powered mid-decks, all science related, fluids research, materials research, medical research, plant research, and we're bringing up 5 passive experiments. All those have been loaded over the last day or two, and right now they're on board the spacecraft and everything's operating well. So you can see a picture of the external carrier, the LMC towards the bottom, and the MPM right on top of that. And once we get that installed, of course we have to check it out. We have various IVTs that we perform, and once everything looks good, we do our final closeouts, and eventually the orbit doors are closed for flight, and I think that's what we're seeing now. So eventually on this 12-day mission, on flight day 3, the orbiter will dock. On flight day 4, the MPLM you saw, the module, that will be attached to Node 2 on orbit. And then flight day 5, we'll take the robotic refueling experiment and we'll attach that to space station. And then the failed PM pump, the pump module, which is used to circulate the coolant on station. And we have 3 other spares up there, but we want to bring that one back, take a look at it, we want to understand it. And then that's flight day 5, and then flight day 12, we'll go ahead and deploy the DoD PicoSat satellites.
So we're not leaving this one on station. It needs to come back because it's got hardware to come back and other things. What all would be coming back with it?
So yes, the module is just temporarily stowed on Node 2 Nadir, and basically the idea is we want to bring back. There's spare parts that we don't need anymore. There's items that have to come back and be fixed, trash items. So yes, we'll be bringing back a variety of items that are not needed anymore on ISS. And then of course, as we mentioned on the external carrier, we'll be bringing back the pump module because it did fail. We don't know why it failed, and we need to take a look at that and learn from it.
Well, Joe, thank you very much. And I know the payload test team is also looking forward as much to launch today, but also to the activities after we get up there, because what's going up in the module and what's coming back is really the focus of this mission. So thank you very much for talking to us about the payload, and best of luck to your team throughout the remainder of the mission.
Well, I appreciate it. It was an honor. Thank you very much.
Yeah. And we have 35 minutes remaining in this built-in hold. We're at T-minus 3 hours in holding. This is shuttle launch control. This is shuttle launch control, 3 hours and holding. 32 minutes, 55 seconds remaining in this built-in hold. Joining us right now at the console here in Firing Room 4 is Master Sergeant Margaret Howard, weather officer with the U.S. Air Force 45th Weather Squadron. And Margaret, welcome. We know the crew is getting a weather briefing right now, so we're going to discuss that here very shortly so you can tell us what it is that they're hearing. But first of all, we have a new tool that is just making its first real use on a shuttle flight for STS-135. It's a brand new radar, and this has been undergoing construction and testing for almost 2 years now. Margaret, as we go along, maybe you can tell us some of what we're seeing as we look at the tape. But if we could go ahead and roll that. This was shortly after the groundbreaking on August the 8th, 2010.
Okay, here we can see that the contractors, they are putting the radome together. This tower is about 100 feet above the ground as opposed to the older one, which was only 60 feet. And with the radome on top of it, it puts it at about 130 feet. And you can see them there lifting it with the crane. Some of the advantages that this radar has over the old one is that this newer radar is dual polarization. This allows the radar to view precipitation particles both horizontally and vertically as opposed to just horizontally with the older radar. This can help identify the type, size, and number of precipitation particles, which greatly improves our warning accuracy. And you can see there also the new site is about 23 miles to the west of many of the launch pads on Kennedy Space Center. The reason it is here as opposed to on Patrick Air Force Base, where the older WSR-74 was located, was because one reason was the height. This one here, it would have intruded into the airfield safety corridor on Patrick Air Force Base. And another reason that it is here at the current site is because it has an unobstructed view to Cape Canaveral Air Force Station and Kennedy Space Center. On Patrick Air Force Base, the older radar had to transmit across many large buildings in Cocoa Beach to view the Cape and Kennedy Space Center, which greatly increased ground clutter. And there you can see the VAB. So there's a clear line of sight there from the radar to Kennedy Space Center, which greatly helps us a lot. And here we have Todd McNamara. He's our radar launch weather officer, and he is actually manning the radar as we speak.
Right here, we got the center line actually over Cape Canaveral on the radar.
There you can see some radar, some shower, thunderstorm activity moving over the Cape and Kennedy Space Center. And actually to his right there, that's Staff Sergeant David Van Squake, and he's actually at one of our TAL sites overseas supporting the launch mission.
Well, right now the crew is getting a weather briefing, and I wonder if you could go into that for us. Tell us what the forecast is today, what the outlook is, what do we see coming up over the next few hours, particularly when we get to launch time.
Okay, well, there's a tropical wave in the eastern Caribbean, which has been slowly pushing towards the north. For today, we're looking for almost the same weather conditions as yesterday, mainly rain showers and some isolated embedded thunderstorms. We still have a 30% chance of favorable weather for the launch. However, as the days progress, our chances do get better because the system pushes toward the north, and which makes it much more drier than it is currently. Our weather conditions at all three TAL sites are good to go, and also the abort sites at Edward and Northrop Strip is also good. So mainly we're just concerned with the weather here at Kennedy Space Center.
What probability is Kathy Winters currently putting on our forecast?
Yes, currently the probability is 70% no-go, which is 30% favorable.
All right. Well, if we go into tomorrow, what does Saturday look like, and what does Sunday look like?
On Saturday, our chances are 40% favorable, and on Sunday, it's 50% favorable. So we're still looking for the same almost weather conditions.
All right, but at least the trend is in the right direction.
That's correct,
So
yes.
we live in hope.
Yes,
so,
we do.
All right. Well, thank you very much, Master Sergeant Howard, for telling us about the new radar and bringing us up to date on the forecast. And I know the crew is just finishing up their weather briefing and getting ready to go suit up. So thank you very much.
Thank you very much for having me.
We're at T-minus 3 hours in holding, and we're at 27 minutes now remaining in this built-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding. Here's our commander, Chris Ferguson. He's in the suit-up room. He's having a fit check of his helmet. He's our commander on this flight, and going over to pilot Doug Hurley. This is his second trip into space. He completed his first space flight on STS-127, and he's logged more than 376 hours in space. And here is Mission Specialist number 1, Sandy Magnus. This is her third space flight. She spent more than 4 months in space aboard the International Space Station. She flew on STS-112, logged 11 days in space, and then 4.5 months after being on board the space station as a member of the Expedition 18 crew. This is Rex Walheim. He's our mission specialist number 2. He's making his third space flight. He's spent more than 24 days in space on STS-110 and STS-122, and he's had 5 spacewalks totaling more than 36 hours. And he's served very effectively as the chief of the EVA branch. So the crew now is finishing their suit-up activities, and they are scheduled to leave for the launch pad in just about 25 minutes. Shuttle countdown is continuing to go very well. There's nothing amiss there at all. And so weather is only the only concern. Main thing will be continue to be the low cloudiness, particularly at the shuttle landing facility, should we have a need for the crew to turn around and come back with the shuttle for a return to launch site, and any precipitation. And we have now exactly 20 minutes remaining in this hold at T-minus 3 hours. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours in holding. We've just had a weather update, which was passed to Kathy Winters, our shuttle weather officer, on the sea conditions offshore for the solid rocket booster recovery after launch today. And the ships are reporting that the seas are 4 to 6 feet. The sea temperature is 83 degrees in the water. Air temperature is 80 degrees. The winds are from the south at 20 knots, occasionally gusts to 24. Excellent visibility, at least 10 miles. And it is overcast, though, just as it is here. And Mike Leinbach, our launch director, has just asked for another update on the weather. The astronauts touched down at the shuttle landing facility at KSC, arriving from Houston on Monday, the 4th of July at 2:31 p.m. Since that time, Commander Chris Ferguson and pilot Doug Hurley have been honing their landing skills in the shuttle training aircraft. The astronauts have all done a final inspection of Space Shuttle Atlantis, had a fit check of their launch and entry suits, received a briefing on the status of Space Shuttle Atlantis and also the payloads. They've been following the weather forecast very closely since they've been here, knowing that marginal weather was moving in. And they've had their final medical exams and did a final review of their flight plan and then packed their flight data files and their personal effects, and they were sent out to the pad to be placed aboard the middeck of Atlantis. Today the crew was awakened at 4:30 a.m. Had a brief checkout by the flight surgeon before having breakfast at 5:45. And as we've heard, they've had their weather briefing. The walkout from the astronaut quarters is scheduled for 7:36 a.m. in about 20 minutes from now. And they're scheduled to begin boarding Atlantis at 8:06, and then the access hatch will be closed and sealed at 9:21 a.m. The ice inspection team, the final inspection team, has completed walking down the entire length of the fixed service structure, and they're just about now to go down to the pad surface and they'll do some final inspections around the mobile launcher platform area of the aft skirt, some activity to do there, and then they'll leave the pad. And they'll come back here to the Launch Control Center and report to our shuttle launch director, Mike Leinbach, and the engineering community about what they found during their walk down. The closeout crew is in the White Room now, and they are ready for the astronauts to arrive. Members of the closeout crew are in the white coveralls, and they'll be assisting the astronauts with their helmets and other equipment as they enter the orbiter. White Room is at the 195-foot level of the fixed service structure. The White Room's on the end of the orbiter access arm. There are 6 people altogether who make up the closeout crew. These include a pad leader, a support astronaut, a suit technician, a quality control engineer,
and 2 orbiter mechanical technicians. And the final inspection team has now left the pad. They're en route back to the Launch Control Center. Most of the communications channels are really quite quiet right now. There are no significant issues in work for the engineering team to discuss, so they'll be awaiting to hear what the final inspection team has to report. So other than weather, we continue to have a very smooth countdown going. And we have only 10 minutes now remaining in this hold at T-minus 3 hours. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding, 6 minutes 45 seconds remaining in this built-in hold. The final inspection team is now back at the Launch Control Center.
Shuttle Weather Officer Kathy Winters is briefing Mike Leinbach once again, but from the briefing, what we heard being given to the flight crew, it doesn't sound like very much has changed. We're going to have astronaut Rick Sturko a little bit later on flying weather reconnaissance. A little bit before 9 o'clock, he's scheduled to take off in a T-38 jet to fly for an hour to do some of the initial weather reconnaissance. And based on what we've seen from radar and satellite, he's already been given some direction on where they'd like him to go out and reconnoiter. And then a little after 10 a.m., he'll take off in the shuttle training aircraft to further assess the current weather, as well as the weather's direct effect on the handling characteristics of the orbiter in the event of return to launch site. He'll be shooting approaches to the runway at the shuttle landing facility and judging the visibility and the wind conditions and its effect that it would have on the shuttle. And he'll be passing his observations to John Casper, the weather coordinator here in Final Room 4, and to Lee Archambault, the weather Capcom and mission control in Houston. And the forecasters at the Spaceflight Meteorology Group in Houston, part of the National Weather Service, are going to be listening very closely to what he has to say and providing any updates to those forecasts, either for here at Kennedy for a return to launch site if that's necessary, and for the overseas landing sites in Spain and France. Right now those sites all look good. All of the standard weather observations and forecasting normally performed before launch are being done today. The final phase began yesterday with a series of balloon releases. In the last 24 hours, about 24 weather balloons of all different types were released. And today we have 9 Raywinson balloons. Those are instrumented balloons to collect data on temperature, humidity, wind speed and direction, and barometric pressure up to about 100,000 feet. 6 gem spheres are being released. These provide very highly accurate data on the wind speed and direction up to about 60,000 feet. This data from the gem spheres is reduced, and late in the countdown, the flight dynamics officer will select the proper computer program that will allow the Space Shuttle's onboard computers to respond properly to the wind conditions that the gem spheres have observed as the shuttle Atlantis climbs through the lower atmosphere. Three and a half minutes remaining in its built-in hold. This is shuttle launch control.
This is shuttle launch control. About 10 minutes remaining in this built-in hold. Coming out in 5, 4, 3, 2, 1. T-minus 3 minutes and counting, or 3 hours and counting. And right now the primary ascent guidance data is now being transferred into the backup flight systems on board Atlantis. These are the flight profiles called I-loads. This is part of the ascent profile that we talked about, where they'll be updated with the weather coming in from the Gyn-sphere weather balloons. Flight crew will be leaving the astronaut quarters in about 5 minutes. As we saw in the suit-up room, there are 4 astronauts on this last flight who will shortly be en route to the launch pad. They'll be rendezvousing with Atlantis with the International Space Station on Sunday. Atlantis will be delivering the Raffaello multi-purpose logistics module, which is filled with supplies and spare parts to sustain space station operations when the space shuttle is retired after the current mission. There is one planned EVA, or spacewalk, on STS-135 outside the International Space Station to do as Joe July told us, to remove and replace a failed ammonia pump module used for thermal control, and to install onto the space station a technology development payload for robotic refueling. And the rest will all be devoted to offloading Raffaello with all of the supplies, spare parts needed for the station for much of the next year, and then bringing back a lot of things on the space station that are no longer needed. And here they come. Crew going down the elevator, where they'll be greeted by employees from Kennedy Space Center and members of the news media. This is the same elevator that's been used by the astronauts ever since Apollo. And there they go, escorted by NASA security. Also be a helicopter flying overhead. It's about a 20-minute ride out to Launch Pad 39A. About 10 miles altogether for the drive. We see the NASA headquarters building in the foreground and the Launch Complex 37 in the background where Delta IV is launched. Here we see the crew go by. And NASA Test Director Jeremy Graeber has advised NASA security that the Astrovan should be cleared through the roadblock to get to the launch pad just after they pass the Launch Control Center. NASA Test Director Jeremy Graeber now is pulling the primary systems here in the firing room to assure that there is nothing amiss before we send the astronaut van out to have the astronauts begin boarding. That's a customary thing to make sure we have no launch commit criteria violations before we put the crew on board and they begin to board. And there are not. Range reports, they are go at this time other than weather. And we're now at T-minus 2 hours, 50 minutes, and counting. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 2 hours, 48 minutes and counting. Space Shuttle Launch Director Mike Leinbach has just completed having a discussion with Houston Flight, the Spaceflight Meteorology Group, the 45th Weather Squadron, and some members of the mission management team. He, with the weather uncertainty, wanted to be sure we had a consensus that the right thing to do was to continue with the countdown and put the crew on board. And what he told the launch team was that we do have a shot at this today. So while it's not ideal, there is a chance for a launch, and the direction is to press on. So we'll be following the crew. They're letting off Rick Sturko so that he can go out to the shuttle landing facility and begin flying a T-38 to do some weather reconnaissance. And he'll later be on the shuttle training aircraft. And then they'll probably stop in front of the Launch Control Center to drop off some senior management and then head on out to the pad. At T-minus 2 hours, 46 minutes, 34 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 2 hours, 38 minutes, 26 seconds and counting. The Astrovan is now on the pad surface. The crew will be disembarking, and in just about 5 minutes they'll be headed up to the White Room to begin boarding. Our commander, as is customary, will be first aboard. Crew is doing what many of the crews like to do before they go up and board. They like 5 minutes or so to go up on the pad and take a look at Atlantis, pose for some pictures in front of the shuttle before they board. And then head over for the elevator. On the pad surface, they'll be going up to the 195-foot level of the fixed service structure. And we'll see the crew coming off the elevator here in just a moment. Commander Chris Ferguson and pilot Doug Hurley will enter the White Room shortly. Our mission specialists, Sandy Magnus and Rex Walheim, will probably
wait outside a little bit and take the time to look around, enjoy the view from up there while the commander and pilot board. Very pleasant weather at the pad today. The temperature is about 82. Little humid, but other than that, it's not raining and the sun is starting to peek out. This is Shuttle Launch Control, T-minus 2 hours, 31 minutes, 5 seconds, and counting. The flight crew is now in the white room of the orbiter access arm. Members of the closeout crew are in the white coveralls, and the astronauts, of course, are in the orange pressure suits. The closeout crew will be assisting the astronauts with their helmets and other equipment as they enter the orbiter. And the closeout crew is scheduled to seal the orbiter access hatch at 6:56 a.m., but this can be done up to an hour later if that's really necessary. Right now, Chris Ferguson is being assisted with his launch and entry suit. He's our STS-135 mission commander. He's making his third space shuttle flight. He's logged more than 28 days in space, and he served as the spacecraft communicator, or the Capcom, on 4 space shuttle missions. He was the pilot on STS-115 and the commander on SAS-126. So during those 2 missions, he's logged more than 28 days in space, and he's also previously held the position as the deputy chief of the astronaut office. Joining us right now here in the firing room is Jim Kelly. Astronaut Jim Kelly is from Burlington, Iowa. He received his Bachelor of Science degree in Astronautical Engineering from the U.S. Air Force Academy and a Master of Science degree in Aerospace Engineering from the University of Alabama. He graduated from the U.S. Air Force Test Pilot School at Edwards Air Force Base in 1984. He was selected by NASA to become a NASA astronaut in 1996. And he was pilot on STS-102 in 2001 and STS-14 in 2005. He's logged more than 641 hours in space, and he's currently chief of the Capcom branch at Mission Control at the Johnson Space Center in Houston. So, Jim, welcome. It's very good to have you here today and to be able to talk us through some of the activities as the crew gets on board. Tell us a little bit what the crew has been doing besides the obvious things that they customarily do when they get up in the morning. What's been their activity like this morning so far?
Well, it's great to be with you here, George. Yeah, they've been basically getting ready for the mission this morning. They're towards the end of their day. They've been up for quite a while before they get to this point. And a little bit of a leisurely morning, relax a little bit, but then all business over the last several hours as they get their final briefings on weather, any changes in flight plans or anything like that. They sit down and talk about and eat a little bit of something before they go fly into space and then get ready to go. And all dressed up now. And Chris Ferguson, as we can see in the White Room, is just getting ready to go on board.
Now, you mentioned they're sort of at the end of their day, so once they reach orbit, what are the things that they'll be doing since this is kind of at the end of the crew day? How does all that work? How do you phase that?
The crew day is phased based on when they're going to rendezvous with the International Space Station. That's why the first day is kind of a short one on orbit. They'll actually get up there and open the payload bay doors, establish complete orbit, and then they'll change the rocket ship into an orbiting vehicle. They'll make sure that everything's set up for the next day. They've got all their equipment set up, their computer systems set up. They'll be just essentially preparing for the second day, which is going to be very busy, especially with the crew of just 4 people. So they're going to be one of the busiest crews in memory, maybe the busiest because they've got less people than normal to do all the normal tasks that have to get done. So they're going to be busy getting all their suits off, getting everything stowed, getting everything pulled out that needs to be pulled out, and all ready to go for tomorrow.
And let's see, I think that's is that our pilot Doug Hurley there that's just being assisted into his equipment, I think. Is the order always the same? I know you always start with the commander, but is the pilot always next, or does sometimes they put somebody else on next?
Usually when you have a mid-deck crew, meaning people on the bottom side of the orbiter, you trade off. You have the commander going first, and then you have one of the downstairs folks going next, and then you go back and forth. The upstairs order is always the same. It's always commander first, then pilot, then mission specialist 1, then mission specialist 2, just because of the way the seats are arranged, and you have to have access to each different one. So the order we see today will be the order that you always see for the flight deck, but normally you have people that are down in the mid deck, 1, 2, or 3 people that are interspersed amongst these. So it'll be a little bit strange because we only have 4. And I'll tell you just a little bit about the closeout crew here. The closeout crew has been in existence, obviously, since the beginning of the shuttle, and they're just an outstanding group of folks. They've been together for a long time. We might not even see him here for a little while, but Travis Thompson's the lead. He's number 1. They all have numbers on the back of their gear and on their hats and things like that. And number 1 is called the OVCC, Orbital Vehicle Closeout Chief. He's been the crew lead, has 28 years on this team. This is an incredibly experienced and dedicated team that gets the people on the orbiter, and Travis is in charge of the whole thing. And not only is he in charge of this one, but he's in charge of the whole closeout crew. We can see here Chris Ferguson getting put into a seat. And the folks that are helping him get in his seat there are number 2. If you can see the number 2 on him is Randy Brezhnik. He's actually a Marine Corps colonel. He's one of our astronauts. You can see him in the one screen. And Randy is actually getting on there to help out with the communications sections and all those kind of things. But the guy running the operation is Drew Billingsley, who's number 3. And you can see him kind of climbing all over there. If you look in the view there, you can see Chris Ferguson right in front of us, and kind of behind to the right, kind of leaning over, is Randy Brezhnik, number 2, and now disappeared from sight is Drew Billingsley. He's called the flight deck crew insertion technician, the one that gets him on the upstairs. Born in Santa Monica, California, and grew up in Huntington Beach. Served in the U.S. Army. He's been in this role for a long time. He was initial suit tech in STS-86 back in 1997. What they're doing as they go through here is, as Chris gets in the seat, there's probably about 9 different connections that need to be made, both to the vehicle itself as well as within his own gear there. And as you can see, we're pretty much, as astronauts, just hanging back and letting them do it. The best thing we can do is let these professionals do their job. So you can see Chris is just concentrating on getting his hands out of the way and making sure that Drew has access to what he's working over on the right there is his liquid cooling. You've got all the straps that have to come around. It's a 5-strap harness. You have to get the parachute, which is what you're seeing there. Randy has the close one, and Drew has the far one. You get the parachute straps that are waiting for you. The parachute's already in the seat when you get in. They put those over the side and they connect those in. You'll see a real good shot of that right here. You'll see them connected into the straps that Chris is already into, that he came in with his chest strap and everything. So that gets connected there, and they're essentially doing all these connections to make sure he's nice and snug in there and all ready to go. So you talk about the 2 guys in there. Drew is this is be his 11th mission. I'm trying to remember Randy. And this is Randy's first one as the number 2, so this is the first time he's actually inside the vehicle doing this setup here. So I'm sure he's having a lot of fun.
And this looks like Doug Hurley.
Yes, it'd be Doug Hurley going in, Marine Colonel. He is flying as a pilot on this flight. This is his second flight. Flew a few years ago on 127. And he's being helped there. You can see the guys out in the white room. They get everybody ready to go. Number 4 there is Renee Arians. He's another longtime member. And by the way, all the guys that we've talked about so far are USA employees, other than Randy Brezhnik, of course, who's the astronaut. But Renee has been with the United Space Alliance for a long time. 27 years in the space program. He's been for 40 launches. And he's just doing a great job for us. He's been the OVCC. He's actually had Travis Thompson's job. Travis is number 1. There's only about 3 or 4 people that are qualified to do that job at any one time, and Renee is another one, but in this flight he's actually filling the number 4 role. And so he does a great job with it. He's going to be the hatch technician when they close the hatch and take care of all that stuff.
You mentioned Randy Brezhnik. He's the ASP, right? Astronaut Support Person.
Yep, it's called Astronaut Support Person, yeah.
When does he get on board? He gets on fairly early, doesn't he?
He does. He comes out and gets everything prepared inside the crew cockpit before the crew gets out there and make sure that all their gear is in place. There's a lot of things they don't bring with them. They don't carry out with them that we take out for them. And I did this job quite a while ago, and there's a lot of things you take out there, get ready. You essentially triple check the cockpit to make sure everything's in place. So he's like the first one that gets in the vehicle out there, as well as the number 3 to try to get things ready. So he's out there before just to, like I say, triple check, make sure everything's good to go.
What have the crew's activities been like since they got here in the last couple of days?
There's a lot of briefings when they get in town, weather, technical stuff that's going on with the shuttle, making sure everything's okay, which so far everything's going well. You can see the thumbs up there from Chris as he's getting strapped in. And hopefully what we try to get him is a lot of rest and relaxation time. Last chance to see their spouses. They can see their kids from a distance because they're in quarantine for the last week. So kind of a last chance to see the ones closest to them and get some time to relax. And we really beat crews up sometimes in training before they get to flight. And we try to get them down here to the Cape and essentially give them a few days where they don't have much to do so that they can relax, get a little bit extra sleep. We allow them to sleep a little bit extra. And also there's the time shift. If there's any remaining shift that they have to do to get to the correct work day for the space station and the shuttle when they're connected, they do that. So they've been doing a little bit of sleep shifting as well.
So when did they have to start sleep shifting for today?
It depends. We normally start our sleep shifts about 7 days prior, but these guys don't have a huge sleep shift. They'll be going to bed tonight. I can't remember the exact time, but it's around like 8 o'clock tonight, so it's not a big shift for these guys. It's a huge deal if you happen to be one of those flights that your day is exactly opposite, that you're getting up and going to work in the middle of the night and sleeping all day. So for this crew, it hasn't been too bad. They only had a couple hours to sleep shift, so it hasn't been a big deal. But in general, we'll start at about 7 days ahead of time while they're actually still at Johnson Space Center.
Well, I guess it's good they have a little bit of time to launch into space more relaxed, because when they're here for the countdown dress rehearsal, the TCDT, it seems like every minute is filled with things that they have to do.
Absolutely, and there's a reason we do that. For the Terminal Countdown Demonstration Test, TCDT, when they come out, we actually have, through the years, taken many things off of the launch flow and moved them into that flow, so they didn't have to do so many things before launch. It used to be that launch was as packed as that, and we just learned that, especially with post-Columbia, the crews have so much to do on flight day 1 and flight day 2 with the inspections and everything else that it's just critical that we send them up there relaxed and with a little bit extra sleep. So we've really tried to scrub the launch timeline to take out anything that's unnecessary. So what we're left with is practice STA flights, shuttle training aircraft flights for the pilot and commander, some briefings that they have to do. The crew will normally go out and check out all their computer lines that are set up. It's called the pre-wiring, that they set up all their computers and cameras and things like that. They go out and check that. But other than that, we try to give them free time. You can see Drew there working with Chris Fergie's communication gear. That's the white line that's coming down. It's actually from the back of the helmet that connects into the system, but that's the line that communication comes through. So you see that wraps around a couple times. And the black piece of gear we call the hot dog there, that's the quick disconnect. Everything that he's being strapped into the shuttle with has a quick disconnect, so they can just pull things instead of having to tightly undo things. Everything just has a quick pull that they can take apart in case they would have to get out. If there's some kind of emergency at the pad and instead of launching they're going to have to get out, there's a bunch of quick disconnects you pull so they can just, for Chris, he would roll to his right, drop down on the MS2 seat, which Drew, or not Drew, but Randy Brezhnik is kind of on over there on the left. He would drop down on the seat down there and then get out of the vehicle. So that's part of the reason why it takes so long, is because everything's an intricate thing. You don't want anything to be tangled up. You don't want anything that can slow the crew member down if they need to get out of the vehicle. So,
well, if I can fast forward 12 days after the shuttle lands, who helps them get out? Do they do this themselves, or does somebody help them get out of their seats, or how does that work?
When they land, we actually have folks that will go in and help them out if they need it. But most of the time, by the time you get the hatch open, because you have to do all the external checks, make sure the vehicle's safe, we're not leaking any hazardous gases or things like that. By the time they've done everything and get in the vehicle, usually the guys are unstrapped and pretty much ready to come out on their own. They've already got their helmets off, they've got their gloves off. And a lot of times, like the guys in the front seat will take all those things off. They'll hand them back to the mission specialist behind them. They'll stack them all on the flight deck, kind of right above the ladder. And when the technicians get in at the end of the flight, they'll come up and take those things out. And actually, usually the first person in, I don't know if it'll be Randy on this flight, but it'll be another astronaut support person that comes in and starts clearing out all that gear. And then, of course, there's doctors available and all that kind of stuff. But usually the crews get themselves out, they get themselves unstrapped, and they don't need any help. People would seem to think, too, this is a pretty involved process. Usually takes about 50 minutes from the time the first person goes in the door to the time the last person's strapped in. And you'd think with 4 people rather than 7 it would take less time, but it really doesn't, because the flight deck drives the process. You've got 4 people. It's much more cramped upstairs. And the mid-deck is actually done in less time than the flight deck does, and they're concurrent. So it's a little bit odd. You think, okay, there's only 4 people. It's going to take, 25, 30 minutes because there's less people. But really it takes the same amount of time, because this is the timeline, the flight deck, and how long it takes to get those 4 folks strapped in is what drives the time.
Now, having all 4 crew members on the flight deck, did that allow any extra room for more things to go into the mid-deck, since we're trying to do so much resupply on this mission, or not?
I can't tell you specifically, but there are hard points down there, and if you have less seats, you do have some capability to put more gear down there. But it's not a huge amount of extra gear. You can't add extra lockers, for instance. The lockers are set, and they can't be changed, so you can't add extra lockers down there, so it's not a huge change. You can see in the white room there, you can see Travis Thompson, number 1, over on the right. You can see number 5, which is Chris Minert. And this interesting flight, we talked about the number 1 being such a critical position. We actually have 3 number 1s on this closeout crew. We have Travis, who is number 1, Renee, who's working number 4, and then Chris Minert here is number 5. He's also a hatch technician who grew up in California as well. He's been working for a long time, worked the SR-71s and U-2s, and came out here. He's been working on the closeout crew since about 1990. And he actually won a Silver Snoopy Award pretty recently, back in 2010. So Chris is another person that's capable and qualified to be a number 1, but today he's working as number 5.
And this is Sandy Magnus. She's our mission specialist number 1. So when she gets in, I think she's going to be on the flight deck in the aft right seat.
Step 628.
That's correct. We got a good view of it now.
They are complete.
Doug has gotten in from the mid-deck, and you kind of have to go in through the mid-deck through the hatch, and in the mid-deck you kind of take a right, about a 90-degree right. You have to go through the ladder access, which normally when you're vertical you'd be climbing the ladder. In this case you're going right, and then you actually crawl on the aft panels, and you can see that Randy's actually standing on the aft panels there as he gets folks ready to get in the vehicle. So we've got things down there that protect the aft panels, a certain place where you can stand. Like you notice, for instance, Randy's not standing on the switches. We can't stand there. But it's kind of intricate. You have to weave your way around, and so you come in the hatch, you turn to your right for about 90 degrees, go about 5 feet, you drop down to the aft panels, aft lower panels of the flight deck, and then you climb up on the Mission Specialist 2 seat, and then you have to get yourself up in the pilot or commander seat. So these are the hardest 2 seats to get into, and it's kind of a monkey bar thing. Wow. There's a grip up there that they grab with their hands, and then they put their feet up there, and oftentimes you'll see the technicians, either Drew or Randy, helping them get their feet up there and get all situated. And then the critical thing is getting yourself on the parachute correctly. You want to get yourself all the way down in the seat as far as to the seat pan as you can, because the shoulder straps of the parachute can be quite painful if you don't get those a little bit loose. So you want to make sure you're as far down in the seat pan as possible. So you'll see a lot of adjustments here where they're pushing on them and pulling on people and getting them in the right place. And it's kind of a manhandling task. Obviously with the suit weighs a lot. It usually weighs about 50 to 60 pounds. And so they're carrying a lot of extra weight, and it's bulky, and it's hard to get where you want to go. And that's why we have so much extra help in there for these guys. This job is almost impossible to do yourself on the ground. On orbit, it's pretty easy. You just have to set things up and you're floating, so it's a lot easier. You can move around a lot more readily, and the bulkiness doesn't hurt you nearly as much when you're in 0G.
GMT and MET adjustment is complete. Ready for IMU platform positioning. Copy that.
Okay, can the astronaut, is he on the flight deck for some time before launch? Is he at the ability to shift his position any or move around to get a little bit more comfortable, or is that
not a whole lot? You have just maybe an inch or two of play in each direction as you move around. You can see there's a certain equipment to make him more comfortable. You can see behind his head there's a headrest there, and those are actually by size. Each crew member picks what size they want that headrest to be, and it depends on how high they want their head up. If you didn't have that at all, you'd actually be holding your head up the entire 2 or 3 hours before launch, which would be incredibly painful. But they get to pick how big they want that headrest to be. Everybody has a lumbar support. It's hard to see here, but there's a little black tube down by Doug's right hip. It's a little black bladder that you can see in your hand. He would take that and squeeze that up, and you can actually get lumbar support from that. You can reach down to the seat pan and pull yourself down a little bit, which is good. There's a monkey bar that's right above Drew's head. It's about directly in front of Doug. He's actually almost looking at it right now, where you can pick yourself up and move yourself around. The other thing that we do for comfort that's the absolute best thing we can do, and we'll see this a little bit later with Fergie, is once you get your helmet on and your gloves on and your suit is completely one piece, so it's all sealed, then you can pump air into your suit. And what that does is it gets all the wrinkles out of your suit. Because right now, the way Doug's sitting, when you lay down, obviously there's extra material. It all gets kind of lumpy, and you can get folds. And if you get a fold underneath you, that can be very uncomfortable. So we actually can pump pressure into the suits and over-pressurize them so you kind of look a little bit like the Michelin Man. And that gets all those things out of the suit so that you're much more comfortable. If you don't do that, then you can be very, very uncomfortable. Once you've done that, though, things are usually pretty comfortable. So it's pretty critical to get in and get set, especially with your parachute straps. If you do that blow up of your suit and get all the wrinkles out of your suit, then once you do those two things, you can actually be pretty comfortable as far as laying on your back for 3 hours goes.
JMQC, can I get somebody on 162? That's sir. And CJLS, we're ready for 651. Yes, ma'am. Thank you.
Kind of see here once again, Drew is reaching around and making all the connections for Doug. He's just keeping his hands out of the way. Sometimes as an astronaut, the best thing you can do is nothing, and this is one of those times.
Thank you.
There are other little tricks these guys do as well. You can see that Doug right there on the right side of his, he's got a comm cap on, communication cap, which actually hooks around, and it's got the boom mics that come out you can see next to his mouth. And then that white cord that goes in next to it, that's the cord that actually connects into the helmet. So the comm cap connects into the helmet, and then the helmet connects into that white cord we saw earlier on Fergie that had the hot dog on it. And they tuck that back in the communication cap so it doesn't go flailing all over the place, because it's real easy to get that thing in between your connection where you put your helmet on. And it's critical to make sure that there's nothing on the seal of your helmet, and there's a lot of things hanging out, microphones and chin straps and that communication gear there, and your suit can get up in the way, and you've got a bladder inside your pressure suit which can get over there. So it's really critical when they put the helmet on to make sure that they've got a clean seal there to get that thing mated correctly so that the suit will work properly. So that's one of the reasons you've got that white communication line there tucked into the communication cap, the comm cap, so it doesn't fall all over the place.
Well, it's nice to see here in the firing room we have some sunshine coming through the windows, so hopefully that's a positive sign. How closely has the crew been watching the weather here for the last couple days?
In general, as crew, we don't watch the weather. It's a 50-50 shot. Either you go or you don't. It's not something you really want to worry about. There's a lot of other things we need to worry about, and weather's just not one of them. You hope for the best, and you trust the launch team to make the right call, and they always do. And you just get out there hoping that you'll go, and if you don't, you shut things down like you're supposed to, and you get ready to go another day. It's happened so often for so many folks. There are very few astronauts that have 3 or 4 flights, or even 2 flights that haven't had a delay of some kind or another, so it's something you get used to. You just leave that to the other professionals, not something you can control. You just strap in and hope you go.
OTC CBSC 212.
You can see here it's really good to have two people helping out. It's kind of a two-person job. Randy's kind of the underneath man there. He's handing things up to Drew. Drew's kind of standing on the mission specialist 2 seat and reaching across Doug and making sure everything's connected. And so the three of them really work as a team together, helping each other out.
SRT, OTC. Yeah, can we get new digital tapes for the range safety monitor station, rack 8234? Okay.
You can see Doug pulling down on the bottom of his seat like we talked about there. He's kind of pulling himself down into the seat, which is pretty critical. And Drew back there is kind of pulling on his shoulder straps to make sure that the shoulder straps are a little bit looser so he doesn't get that shoulder discomfort that you can get very easily if they're a bit too tight. This is a great shot from the very front coming down that we just had there, and we'll come back to it. But that shows you a little bit more of what the inside of the cockpit looks like. You can see Chris Ferguson, Fergie on the other side, actually getting his gear in place. Once you're strapped in, you got your helmet on, everything like that, there's a bunch of checklists and your own personal gear that you take up with you that you want to get put in the right place. And you can actually see Chris hanging things in front of himself over there. And he's just, you kind of make your own little nest. Everybody has the way they do things, and there's Velcro all over the place, so you can put your checklist in the right place. And you always have a couple pencils hung up, a couple egg timers, we call them, because you want to write things down that the MCC or LCC calls to you before launch and then after launch. You want to make sure you've got a timer in case, we use timers for any number of things, but usually if any kind of problem happens, you're immediately hitting a timer because it's very important in many cases to have a timer going from the start of a problem to when you fix it. So there's a lot of things that you're doing there. So Chris is over there getting his nest all built while we finish Doug up on the right side.
And all those items are already on board when he gets on board?
They're all on board when he gets there, and they're either waiting for him on Velcro and he just moves them around, or once he's on, Randy will hand them to him. And Randy's got him sitting down there on the bottom, and he'll actually hand those things to him and make sure that they're all ready to go. So in some cases there will be things that they have in their pockets. That's usually not the case, but sometimes they'll have a thing or two in their pocket to carry up there with them that they put up. And they bring the last checklist out with them because they actually have a checklist when they have the pre-flight weather brief that happens right before they suit up. That's the last thing before they suit up. So those actually come out with Randy after the crew, because the crew's writing in those based on the weather briefing. And after they write in them, they hand them to Randy, and Randy brings them up to the pad, and he hands that to him. So it's kind of a handoff from the crew to Randy, and then Randy back to the crew. You can see there with the helmet going on, as I said, that seal is critically important, and it was very illustrative of why we have that comm cap. Why we have that communication cord tugged into the comm cap there. You can see that Drew's working really hard here to get the bladder out of the way and make sure the helmet, when it goes on, clicks. It's got dogs, we call them, all the way around. You want to make sure it clicks down very well, and if it doesn't click down, you take it back off. Probably means there's a bladder in there or something like that. You can see he just took that communication wire out of his comm cap and got the one from inside the helmet. So that's the connection from the comm cap that Doug's wearing to the helmet, the white helmet, and then that other connection we saw in Fergie earlier is the one that goes from the helmet to the vehicle. So it's a white cord. You see those white cords, and those are all communication. And that's what Drew's going to do now. Same thing. He's going to take that hot dog, wrap it around twice, and then connect it to the communication system of the orbiter.
It's time to come home. How do they do all of this without help?
Like I said, when you're coming back home and you're in 0G, this is so much easier because you can float, you can grab things and all that. And usually the mission specialist number 2 will be helping everybody else get in. And then once that person's ready, so in this case Rex, on orbit will be helping the pilot and commander in and helping Sandy get in her seat and getting that all set. And then once everybody else is in, Rex will get help from Sandy because Sandy's sitting right next to him. So Sandy will be helping hand him things and stuff like that. You can actually do it all yourself. I did it on orbit all by myself. Got in a little bit early, to get situated and stuff. And if you set things up right before you get there, think ahead a little bit, you can actually do everything yourself, including get your helmet on, your gloves, and it's just so much easier in 0G. So you can see in Drew's hand right there, he's got a checklist, and that's a personal checklist of Doug's. And what Doug's doing with that there is that's his personal clipboard that you write things down on. You keep track of emergencies and things like that. You can actually see Drew taking that. It's got an elastic band which goes around the left thigh. and you can actually see him hooking that around Doug now. So each crew member, things are pretty standard when you get strapped in. All the straps are standard. The 5-point harness, the parachute, the liquid coolant, the communication gear, all that's the same for everybody. What's different are these things like that, and the crew briefs the closeout crew members, in this case Drew and Randy, tells them exactly what they want and how they want it, and they work together as a team, and it's a very tight choreography. And that's one of the things you do at the TCDT is they go through the choreography, make sure everything works, and there's always a debrief afterwards to say, okay, I want to do this a little bit differently, or we've got something extra, we're going to change things up a little bit. So these guys work together as a very tight team.
Did I understand you to say earlier that even though there's only 4 crew members, that because of the way the process works, it's not going to take any less time to get everybody on board? Is that what you were saying?
It's not going to take any less time to get folks on board. That's because whenever you watch a strap in, the timing is all set by the flight deck, because you've got 4 people instead of 3 downstairs, and so much less room. Like downstairs, there's so much room to get people in. It's easy to move around, much easier to do things. You can see how cramped it is up here. I mean, it's very hard not to bang your head on things and bang your hand on things. And of course, there's 400 plus switches that you could hit, none of which you want to. They're all right now. They're safed or they're covered, and that's one of the things you'll see Randy do later is he'll be taking the cover off the most critical switches, because we make sure they've got covers on them when the crew goes in. There's plexiglass covers that cover panels. There are switch protectors that cover panels, and those will all get taken out by Randy. But you have to be very careful on the flight deck and be very deliberate about your motions so you don't hit any of these switches. You don't knock something at the wrong time. And so you'll see that, like Drew right now, his head jammed all the way up against the front cockpit panel there. And he's got to watch his head as he does all of these things. But at the same time, you have to get the job done. So it's very difficult to do. And that's why the flight deck takes so much time. And really, the mid-deck happens during the flight deck. And so it's time that you don't, right now we don't have anybody doing it, but we don't need them. Seems like a lot more activity when you're strapping 7 in, because you're cutting back and forth between flight deck and mid deck. There's a lot more going on, but it takes about the same amount of time. You can see back in the white room here, you can see Sandy saying goodbye to everybody. Everybody gets pretty close. Like I talked, these guys are really proud of the job they do. We actually got a nice shot there of number 6 and number 7. Number 6 is the guy that's not USA. He's actually NASA quality. So USA has the contract to do all the operations there in the white room, make sure everything's done right. They're the guys getting all the equipment out of the vehicle. They're the ones taking care of the hatch. They're the ones taking care of all the crew equipment that has to go in. But NASA has their own representative out there. In this case, it's Jack Burrett. He's number 6 on your screen before. 25 years in the space program. He's done 15 launches, and his job is really to check everything else that's being done. He's got the checklist that he looks at, and he watches over and behind and goes after and makes sure that everything that the USA technicians do is absolutely perfect. And so he's the quality control, if you want to look at it that way, to make sure that everything's done right. So everything we do in the space program, whether it's on orbit or down here on the ground, it's not one person doing it. It's usually 2 or 3 or 4. You have somebody doing the work and somebody checking them, and sometimes a third person coming back and checking. And really on the closeout crew, you have 2 guys doing that. Travis Thompson is a true professional, is number 1. He's checking everything that everybody's doing as a USA guy. So he's checking out his whole USA team, making sure they're good to go. And then Jack, as the NASA guy, is checking everything as well. And then Randy, as he comes out, will be triple checking everything. So we've really got the OVCC number 1 Travis checking everything out. As a USA guy, you got the number 6, the NASA guy, checking all the quality of everything that's being done. And then you get the astronaut number 2 as he comes out.
Now this is Rex Waldheim. He's mission specialist number 2, but he's also the flight engineer, correct? And what does that mean that a flight engineer does, distinguished from, say, what Sandy Magnus will do?
Okay. Yeah, this is Rex that we're seeing there, that he's getting put in his suit here, or in his harness. The flight engineer is, the way to think about that is he's the right-hand man of both the commander and the pilot. He actually sits in that center seat right between them, and he's backing both sides up on everything that happens, especially if there's any kind of emergency or off-nominal events. He's the guy that's handling that and letting them know what's happening. He's running a lot of timers. He's keeping track of other checklists and what's going on. He's kind of, the commander usually has the bigger picture, but you want your mission specialist 2 kind of be, he's a little bit further back. He doesn't touch any switches. He's got like one switch that he touches, and that's only on landing. Everything else pretty much is handled by the forward guys, and so he's kind of the big picture guy to look at that. He keeps track of checklists, and he helps the guys out in the front. So he has to have as much knowledge as the pilot and commander do of all the systems, and it's kind of interesting. He almost has to know both. As well as the pilot and commander do, so it's a very difficult job, and they're worth their weight in gold.
Good morning, good.
Some of the communications checks now just getting underway, which we'll hear from time to time.
So the last guy we haven't talked about, while we're watching Doug finish up his strap in here, last guy we haven't talked about is number 7. That's Ray Cuevas. He's also a USA guy. He's actually the mid-deck crew insertion tech. So today he has nothing to do inside the vehicle because there's nobody on the mid-deck. However, if you noticed, and you can kind of see here, Rex is kind of done with the process. Outside the vehicle, when they get their harness on, we have a crew insertion tech like Drew, who's on the flight deck now, or Ray, for the mid-deck, that actually makes sure that everything's set on the outside. So Ray was making sure that the shoulder straps were on there. You want to make sure you pull the material out from underneath. And once again, shoulders are a really hard thing to make sure that you get them comfortable with all this gear on. And so they were pulling the material out to make sure that it's all completely, the neck straps are right underneath the neck, the shoulder straps are underneath the neck there, making sure everything's nice and comfortable for the crew before they go in. So normally, Drew would come out for each of his flight deck crew members, and he would check everybody before they came in. Since we have 2 insertion techs and we're not putting anybody in the mid deck, you can see there that Ray was actually doing that job. So Drew's actually staying in the cockpit, so this will shorten the time a touch. Drew is actually staying inside the cockpit to get everybody strapped in, and Ray is getting everybody in their harness the correct way on the outside. So the insertion suit techs, which are the number 3 and number 7, they're the ones that are totally in charge of making sure the suit's on properly, everything's connected, probably everything's good to go, and the crew member's comfortable.
Switch reconfigured per your ascent checklist.
Ray was born and raised in New York City. He's been working for a long time, EMU technician since 1983. Transferred to Crew Escape after that. He became an entry suit technician in 1990. He's been a closeout crew since 1999. I've actually worked with Ray in this job, and Drew for that matter, and he supported 17 flights, so Ray's done a lot of flights. Matter of fact, all these guys are high experienced guys, so every single one of them that's out here. Kind of see Doug's already done his comm checks. You can see that he's got the helmet on, everything there, so he's all set to go. They should be working on Sandy now. Matter of fact, you can see, well, we'll go to that shot here in a second. We're showing Rex out in the white room, and you can see once again that Ray is working on the shoulder straps and everything there to make sure that everything looks comfortable. He's pulling that material out from underneath. And inside the vehicle, we've got Sandy just starting to get strapped in.
So Sandy's in the back on the right, and Rex Walheim is right in the center between the commander and the pilot. Is that his vantage point?
That is correct, yeah. The center seat, which is actually where Randy's standing right now, he's actually standing on the seat that Rex is going to go into. And what he's doing is he's actually throwing some switches for the pilot and commander, make sure they can reach and make sure that they're in the correct configuration, because there's a few switches that need to be thrown, as well as checking the caution and warning system before they're done strapping things in. Meanwhile, you can see Drew, number 3, is actually kneeling on Rex's seat to help take care of Sandy. Sandy's in the seat, like you said, it's in the back right. From a flight deck perspective. She sits behind the pilot. She doesn't have much of a view of anything. She can kind of see crossways over to Fergie's displays, but she can't see really anything in front of her because Doug's sitting right in front of her. She does, however, to her right-hand side have a computer display that she can control and see the data on there. So if there's any data that needs to be looked at in the back 2 seats, it's actually Sandy that'll be looking at that because she's the only one that has access. So the mission specialist number 1.
Switch reconfig is complete.
Copy that.
The mission specialist number 1 is not like the flight engineer, but they help out a lot too. They take a lot of notes, they keep track of things, and they can check backup check data on the screen, set timers, things like that. So they're kind of the overrun person. Anything that can't be handled by the rest of the crew, they pick up.
OTC asks, we're going to take a do not perform on the caution warning adjust. We're good with where it is.
Okay, leave it the way it is. Copy that. Thank you. CMQC, take a not perform under the header. Copy.
See out in the white room, that's Chris Menard again, number 5. You get Travis, number 1, and they're just getting Rex in. So hopefully, if things go well today, this will be the last astronaut you'll see climbing into a vehicle to go fly in space on the shuttle.
644 through 647 are complete.
Copy that.
Got that front view again. You can see that Drew is still working on Sandy over there, so they'll bring Rex in, and Rex will actually, that interdeck access that I talked about where the top of the ladder is when they come in and turn to the right, you'll see that Rex will actually pause in there. We can't quite see him in this camera, but he's just behind Fergie and below. He's actually right there ready to go, paused and waiting, because Drew needs to finish up getting the helmet on Sandy and taking care of her before he vacates Rex's seat, which he's kind of commandeered here for a little while. And you can see why you actually could not get Sandy in her seat if Rex was in his, so that's why the order goes this way. The mission specialist number 2 seat takes a lot of abuse because Randy and Drew, as you've seen, are all over it. They're standing on it, kneeling on it, crouching on it. They have to be all over that seat to get the commander in, the pilot in, and the mission specialist number 1 in. So that seat takes quite a beating, but luckily it's built for that, and it was built with that in mind. Randy actually, at the top of the screen there, he's actually standing on the aft windows. So we have aft windows that go to the back of the payload bay that you can actually see the back of the payload bay. When the payload bay doors are open, you can look outside. We actually have hard panels on top of those. They actually sit and they're anchored by the metal around the window, so not actually touching the window at all. But we put a lot of those kind of things in there, so there's places for Drew and Randy to step on and the crew to step on as they come in. That's one of the most critical parts of Randy's job. Is it's kind of like painting a room. You don't paint yourself in a corner. When Randy comes out, he's going to pull every bit of non-flight gear with him. And you'll watch when we get back to the white room later, there's 2 people actually taking inventory as it comes out. Every individual panel or a red flag that says remove before flight, or any protective gear, all those switch guards we're talking about. There's covers that go over the rotational hand controllers, the flying controllers that the pilot and commander have. All those things come out of the cockpit. Randy pulls all those out as he leaves and essentially paints his way out until he gets to the hatch. And when he comes out, the last thing he'll do before he leaves the vehicle is he'll check with the USA techs and with Jack Burr at the NASA quality, and he'll make sure that everything's out of the vehicle.
Now we hear the orbiter test conductor every now and then. How is the orbiter test conductor in the firing room at this point in time interacting with what's going on the flight deck?
Well, they're keeping track of, like we talked about before, there's some switch checks that they do on board. There's a caution and warning check that they do. So anytime a switch is being thrown on board, which there are several once the crew's strapped in, OTC is completely dialed into that. So it's kind of a choreography that's well thought out ahead of time. None of this is, on the fly. None of this is something they're thinking of right then, unless you get an off-novel situation. It's all done per checklist, and the crew is following their checklist. The OTC is following their checklist. NTD here down at Launch Control Center, the NASA test director, the launch director, and then all the folks at MCC are watching the same data, listening to the same thing. So everybody's watching this as they get ready to go. Everyone's on their checklist. We heard the Capcom from Mission Control, Butch Wilmore, talking a little bit earlier, doing the comm checks with the crew. So there's comm checks for all the different systems, and it's all the choreography has been honed over many, many years, decades at this point, been honed to the point where you can get this to a minimum, because we would like to spend the minimum amount of time out at the pad once the vehicle's fueled. So they've got this down to a very tight choreography to make sure that everything can get done. We can get everything done safely and get the crew off as quickly as we can. Plus, the faster you can do it, the less time you're laying on your back, which is a nice thing. There's a good shot back there of the panels that they were standing on. As Randy moves to the side, you can see his foot's right down there. There's yellow tape all over that panel back there. Anything that's coming out of the vehicle has yellow and black tape on it or red tape. It's very garish, because you don't want to miss it. It's good. They've got these huge remove before flight red tags that oftentimes you see on airplanes, on covers on airplanes. They've got this little banner, red banner hanging banner hanging down, and that's all so that comes out. You notice the cord for the camera that we're seeing now is not a camera that goes on orbit. It's actually a camera we use just to show folks, like we are right now, what happens inside the vehicle, and Randy will pull that out when he goes. And if you look above Randy's head in the upper right hand part of the picture there, you can see that yellow cable going across. It's just hanging there. It looks kind of not good because it's just swinging. Well, that doesn't actually go up with the crew. That's part of the whole camera gear. And so as Randy pulls the cameras out with him, which he's about to do there, it's looking like he's adjusting the camera. As those come out, all those wires come out. You can see one in this picture here behind Doug's head. You get kind of a yellow cord there. That yellow cord comes out. So anything that's in the vehicle that's coming out is yellow or red or yellow and black, so that Randy, when he leaves the vehicle, can make sure that he sees everything and pulls it out. Because the last thing in the world you want to do is leave something that's not supposed to be on flight up there, especially because once you go 0G, those things could start moving around and banging, and that's why we have such a tight system for 3 people checking to make sure everything's come off the vehicle.
So how's this camera that they'll take out different from the ones that are going to be on orbit?
We actually have, these are called lipstick cameras. We actually have a few of these that we fly on orbit, so they're flight-like. And they could be flown, actually. They're the same as the flights, and the cables are the same as flight, except they're colored yellow, so that we know to pull them out, so that's a good thing. And there's a video camera, so most of the gear is the exact same gear you would use for flight, but anything that's going to launch has to be stowed and in padding and behind doors and closed and all strapped down. Obviously, this one's just out in the open like this.
So you'll take those out after you get up there?
Once they get up there, they'll pull all those out. As a matter of fact, a lot of the place where they're standing behind Sandy and Rex's seat, almost all the camera gear is in the lockers down there, and it's all lockers, and that's why they can walk all over that, because it's just locker doors. It's not switches or things like that. So most of the camera gear goes back there. So they'll spend a lot of time later on today, once they get on orbit, taking care of that. You can see both Doug and Fergie in the front are both completely set up with their gloves. They've got their helmets. They've already done that pressure check I was talking to you about, where they fill up the suit completely and get that all done. You can see Sandy back there is doing her final adjustment. She's getting her microphones, her booms that come off the comm cap all set there. Randy's kind of going up above her now. Once Drew gets done, Drew's responsible for making sure all the connections are good. Once he's done, like I said, everything gets double checked. Then Randy will come by after him. He'll check all those connections, and then he'll ask the astronaut. So he's talking to Sandy right now. He'll be asking her to check all her connections. You know, show me where your harness connection is. Show me where your bladder connections are for your lumbar support, the bladder for the lumbar support. Show me where your green apple is. The green apple is the emergency oxygen that they fly with. And so on their right hip, we've seen it a couple times with Doug. You can see a green apple there, as we call it. If you pull that out, then you get an emergency supply of oxygen that goes into your suit. So Randy is busy talking with Sandy and making sure she can feel all those connections are all set for her. She's all set, and he's doing that.
MS1, this is OTC. I got you loud and clear. How many? And I have you loud and clear as well. Good morning, Sandy. Good morning.
Kind of see that first communication check for Sandy is done with the helmet open, just to check only the comm system. Now we're going to...
MS1, comm check. MS1, this is NTD, and I have you loud and clear. Good morning, Sandy. And good morning. I have you loud and clear as well. Houston, MS1, comm check.
MS1 Houston, we read you loud and clear, Sandy. Good morning.
And good morning to everyone there in Houston. I have you loud and clear as well.
As I was saying, we do the first comm check with the visor open, so it's just to check the communication system. After that, we'll go ahead and close the visor and make sure the communications work with the visor down, that nothing gets upset by there. There's no comm cable that's stuck in the visor or anything like that. So we do a comm check with NTD and then with Houston with the visor down. Sandy's currently right now pumping up her suit. There's actually suit controls that Randy makes sure that she can reach, and you can pump up your suit like we're talking about for the comfort. And once that's all done, then they can do whatever they want to do.
I can verify step 684.
Copy.
You can see it's really tight quarters in there now. Randy's kind of working in between Sandy and Rex's head while Drew's still hanging over Rex and getting him all set. So it's very difficult. You'll see Randy has to go above Rex's head to get out of there. It's very difficult in tight quarters to be able to do that.
This is SCP.
Yeah, based on your
For Fergie and Doug, they're both completely strapped in. They're doing well. They're actually talking with each other. You can kind of see making sure their checklists are all set. Pilot and Commander are a very close-knit team getting everything done with their mission specialist number 2. So they're making sure all their checklists are all set to go, all their gear's in the right place. Everything's all good to go for launch.
I copy.
What's it like in the crew compartment once you get inside 9 minutes, particularly 5 minutes?
Well, really, once you get inside 9 minutes, you're just hoping everything's going well. You're hoping you get the go for launch, weather's all good, that there's no airspace incursions, which we've had a few times. You're looking to see what's going on, and really you're in your checklist at that point. You're watching all the systems come up. You're making sure everything's pressurizing correctly, and really you're the 50-second redundant check to everybody on the ground, both here at the Launch Control Center and Mission Control Center. They're looking at the same data you are. But obviously you're going to do it again because you're the crew that's on the vehicle, and so they're looking at all their gauges and going through their checklist. Inside 9 minutes, there's a lot of checklist items you have to do, including probably the most major one is at 5 minutes, the pilot will start up the auxiliary power units, the APUs. So there's a lot of stuff happening inside 9 minutes. There's comm checks going on, final briefings to make sure that if there's any changes to the winds or weather at KSC, if they have to come back and land here or anywhere else. You're going through your checklist. You've got all the displays for the different systems, and you're usually paging through those displays one at a time, just checking to make sure that everything's nominal and good to go, and making sure that it all looks good to you. Got a great shot of Doug here over on the right. He's looking over pretty much directly at the camera. What he's actually looking at is he's got a checklist over there that he's taking a look at. And he's talking with Fergie right now on the intercom. So we can't hear the intercom, but that's what he's talking about. A lot of times when it comes time to go, Randy probably can't reach that camera because he'd be like crawling all over Sandy's head. So a lot of times the pilot will actually reach over and give that camera. He'll actually take it off the wall and hand it back to Randy. So it's kind of a handoff between the two of them. But this camera system's great. It came in about 10, 15 years ago. It was added, which I think has been great for people to understand what goes on in the cockpit. It seems like it'd be an easy thing to do, just like an airliner, hop on, sit down, and get ready to go. But it's really a very intricate ballet, making everything work. And the dedicated professionals on the closeout crew team, you heard all these guys are like 15 years, 28 years, 30 years. We've got 3 number 1s that are actually working the number 1, 4, and 5 today. So a huge amount of experience, huge amount of talent. I worked with this crew extensively for about 3 or 4 years, and they are one of the most professional and dedicated group of individuals I've ever had the pleasure to work with in my entire career. They know what they're doing. They do it well. They take a tremendous pride in their job, and it's kind of sad to see them doing this for the last time. I know they've all been around for a long time, and they're trying to make this the best one ever and get this crew off safe and sound. And my hat's off to every member of the closeout crew now and the history of the shuttle from the very beginning. They're the ones that take care of the astronauts right before they leave the planet Earth and make sure everything's perfect for them right as they go out the door. So my hat's off to Travis and his whole team today and all the other ones that came before him.
Talking about the cameras that were added, one of the cameras that we get the most comments on that people really watch for now is that pilot's point of view camera. As you're coming around the heading alignment circle, everybody wants to see the shuttle lined up with the runway turning final. It's so impressive.
Yeah, it's always cool to see it from their perspective, or like this, seeing what's going on. It's nice, and we've tried to do that more and more, is give the public more of a view of exactly what's going on. Space is not easy. There's nothing easy about going into space, staying in space, working in space, coming home from space. It's all very, very difficult and requires a huge amount of drive and thousands and thousands of professionals down here on the ground. We see the guys in orange now, or blue flight suits, and oftentimes they're the focus. But really, the focus should be on the folks like the closeout crew team, or all the folks that are in front of us here in the Launch Control Center. Back in the Mission Control Center in Houston, I work there all the time. Butch and MCC, the ascent entry Capcom back there and the flight directors and flight control team members there and everybody trying to make this work and get it all good. But it's always great to see that point of view of what's happening, the pointing into the spear, and that is one of the neatest things, is being able to get that HUD camera view coming around. And boy, you see that runway come in sight, and it's a really good thing. Once it gets to this point, after we're done with everybody, there'll be a crew comm check that they go through around the horn to make sure that everybody's good to go. And then actually there's a relatively quiet period on board. Once the hatch is going closed, there'll be a pressurization check. Once the closeout crew gets the hatch closed, there's a pressurization check, which essentially we overpressurize the vehicle to make sure that it's airtight, that there's nothing leaking out. And if it doesn't hold that pressure, we know something's wrong, more than likely with the hatch, but it could be a few things. So they'll do that, and then after that's done, the crew actually sits for a little while, and it gets pretty relaxed on board. Sometimes they're telling jokes. The ICOM actually comes down to a few people on the ground, and so they can talk to a few people on the ground over the intercommunication loops that we actually can't hear. And so it can be a pretty light time. It's kind of your relaxation time before you really get down to business, about half an hour, 45 minutes before the launch. Then you're starting to get locked back in, but it's hard to stay locked in while you're laying on your back for 3 full hours. So we kind of have a, I wouldn't necessarily call it a break, but it's a little bit of a slower time in the schedule there, where the crew can, you know, check and make sure all their gear is ready to go through all their checklists, look at all the displays, get everything all set up, and get ready to go.
Now, it kind of looks like, looking at the white room, some things are already starting to come out. How soon can they start taking things out, as far as removing things that have to be out of there before flight?
We take things out as soon as you can possibly take them out. So once you're done with a piece of gear, it comes out. As a matter of fact, there's a lot of things we haven't seen come out just because we weren't looking at that view. But like, for instance, once the pilot and commander and they've got their protector over their rotational hand controller, which is their stick that they fly with, those come out immediately. So as soon as you're done with a piece of protective gear, as soon as you don't need it to protect anymore, it comes off the vehicle. You don't want to wait till the end. So as you go through, a bunch of stuff's come out. I guess at this point, probably a third of the things have come off the vehicle. And there's a lot of things. We normally have protective stuff on the middeck, which is not required today. So, of course, that stuff never went in. But the last probably 2/3 to half of it comes out when Randy comes out after we're done with the last comm check. And we're getting pretty close to that here. You can see Drew's finishing up work on Rex, and Rex has his helmet on already. Not quite to the gloves yet, but he's finishing up all the connections. So we'll actually, if we get to keep this camera for a little bit, we might not be able to, but you'll actually see Randy start pulling all those pads that they're stepping on. You can see that Drew, number 3's left foot is on a white pad back there he's stepping on. You've got the window covers that Randy's stepping on. You've got the video cables that we talked about. And then there's actually, to the left of Fergie, there's a plexiglass panel that covers all the circuit breakers over there that has to come out. There were HUD covers that had to come out that get taken off. There were the RHC covers that had to come out. So there's a huge amount of gear that comes out of there.
Well, meanwhile, while all this is going on, the activities here in the firing room continue with the launch team. And we just heard that the Ground Launch Sequencer is ready to support. That's our master computer here in the firing room that'll be controlling the countdown down to T-minus 31 seconds, and that's active now. But the last 31 seconds are actually controlled on board Atlantis. Isn't that right?
That's correct. They're actually controlled by the computer. We kind of hand it over to the computer within the last 31 seconds because there's so many things happening so fast that it would be an impossible position to put a person in for them to hit the button to stop things. You just can't process the data that fast. So there's a certain number of things that the ground launch sequencer takes care of. That it's essentially getting a go vote from the equipment. It tests the equipment. If it works, then it keep going. If any piece of equipment that's in that GLS sequence goes down or doesn't work correctly, it automatically stops the launch. Now, that doesn't mean that we don't have other ways to stop it. There's, in Launch Control Center here, they can still stop it. If they see something that's outside the ground launch sequencer, like, for instance, an airplane that comes within the no-fly zone or something like that, they can stop the launch from inside the Launch Control Center. On board, also, we can do the same thing, because one of the checks as it goes through is it checks to make sure all the equipment's working. Well, we've actually got a piece of gear on board that we can turn off that's not critical to flight, but if it gets turned off, the GLS will see that and it will stop it. So the crew has a vote as well. If something went wrong inside the cockpit and they thought, hey, you know, inside 31 seconds we don't need to go here, the commander can reach up and throw a switch, which backdoor stops the GLS sequence and you won't launch. So there's still overriding control inside the vehicle and outside the vehicle to stop the launch. There's no overriding to go for the launch. If the GLS says you're not go for launch, it's shutting down, and it's doing its automatic system. And it's built that way specifically because it just can't be done. any other way.
Close each here. He's standing by. Thank you.
OTC, MS2, com check.
MS2, this OTC, I got you loud and clear. How me?
I have you loud and clear also, Roberta, thanks.
Good morning, Rick.
Good morning.
So that was our last comm check with the OTC, and you can see Rex after the first comm check is bringing his visor down and locking it with that bar that comes down, and that's what makes the seal airtight. And now he'll be doing his communication check with the NASA test director here at Florida, and then with Mission Control in Houston.
NTD, MS2, com check.
MS2, this is NTD, and I have you loud and clear. Good morning, Rex.
Good morning, Jeff. I have you loud and clear also. Houston, MS2, com check.
MS2 Houston, we read you loud and clear, Rex. Good morning.
Good morning, Butch.
You can kind of see Randy taking the last check here. He's actually standing up and looking at everything. He's making sure that everything's coming out, that the crew has everything where they need it to be, and he's checking to make sure that all the gear comes out. You can see in his left-hand sleeve there, he's got a green glow stick, and all the crew has glow sticks in their sleeves as well. That's in case you know, something happened, all the electrical power is taken off the vehicle. There are glow sticks that are put all around the vehicle, and this especially works at night. During the day, you can see the light coming through the bottom windows. It's not as big of a deal, but once they get into orbit, it could be. If they lost electrical power to the lighting, they've got those so they can see where the hatchways are. They can see their way out. If there's anything happens in the vehicle, they can kind of follow a trail of those to go along. And each crew member wears them as well, because if something were to happen to the closeout crew is looking for them, it's easier to find people, obviously, with that. So they have those not only for here on the ground, but also if they had to go transatlantic aboard or something like that, where the crew actually has to shut the vehicle down. If they were to go over there and say it's dark in Europe and they shut the vehicle down, all the lights go off, you need a little bit of light. So they've all got flashlights as well, but we're always thinking ahead to the next thing, hoping that it doesn't happen. Kind of see in the front there, on the front lower left of the thing, you've got Doug actually has a checklist out and he's looking at it. Fergie's doing the same thing. They're both looking at checklists and talking to each other, getting all ready to go. They're comparing notes, making sure that everything's set on both sides. They've both got the same information down. Even though you've checked it 10 times before, you'll check it again before you go launch, making sure everything's good.
OTC asked.
Go ahead, Ask.
OTC, the crew's ready for astrocom and air ground checks.
Okay, and you're going to start with your crew module closeout, right?
Say again, OTC?
You're going to start with your crew module closeout? Or are you going to wait till after that? Okay.
We're going to get started on the closeout.
Alrighty. And CDR on Air to Ground 1, verify all crew members are ready to proceed with astrocom checks.
And OTC, all crew members are ready.
Copy that.
Well, Jim, thanks very much for being with us. We're going to listen now to the comm checks going on with the crew. So thanks for coming by and talking with us.
It's been my pleasure, George. It's good to be here, and I'm going to turn over to Tim Seymour, another professional from the closeout crew, the guys I've been talking about, and my best to all those guys, and another great job, and thank you very much.
As needed.
Thanks very much, Jim.
Not change the audio panel switch configuration.
CDR copies.
And let's start with 212 since we're already there. Flight crew to OTC on 212 for a comm check.
CDR loud clear. CLT.
MS1.
MS2.
Copy that, and I'm switching to air to ground 2. Flight crew, this is OTC on air to ground for comm check.
CDR loud and clear. JLP.
MS1. MS2. Copy that. And I'm be switching to UHF. Or ICOM A, I'm sorry, ICOM A.
CDR loud and clear. JLP.
MS1. MS2.
Atlantis Houston for the CDR and PLT, configure for air-to-ground 1, comm check.
That's in work. Configured.
Atlantis Houston for the CDR and PLT, comm check on air-to-ground 1.
CDR loud and clear. PLT loud and clear.
We read you loud and clear also, guys. You can configure now for air-to-ground 2.
In work.
Atlantis Houston for the CDR and PLT, comm check on air-to-ground 2.
CDR loud and clear. PLT loud and clear.
We read you loud and clear also. You can configure now for air-to-air.
Configured.
Atlantis Houston for the CDR and PLT once more. Comm check on air-to-air.
CDR loud and clear. PLT loud and clear.
We read you loud and clear also. You can configure now for SIMO voice check.
In work. Figured.
Atlantis Houston for the entire crew. Comm check.
CDR loud and clear. PLT.
MS1. MS2.
Nice job, Atlantis. We read you loud and clear, and this completes the air-to-ground voice checks.
Copy.
TCC, OTC?
Yes, ma'am.
Okay, they're going to have to change LOX pumps. The one that they're on trending towards bad. Anyway, they're switching pumps. There is a very slight possibility they'd have to do a LOX vent, which is very loud. Let you guys know, and please let the flight crew know.
All right, I will pass that on right now, if you'll give me a second. CDR heard it. Thanks, OTC.
Thank you.
This is Shuttle Launch Control, T-minus 1 hour, 22 minutes, 48 seconds and counting. And as we just heard, we're going to do a little activity out at the pad involving a recirculation pump. And joining us here in the firing room now at the Public Affairs Console is Tim Seymour. He is a closeout crew member, and the closeout crew is about to be briefed on what's going on, and so that they will be fully informed of the activities that for various reasons they may become aware of. So they wanted them fully in the loop as to what was happening, as well as the astronauts on board. So Tim, could you tell us a little bit about what your understanding is about to happen?
Sure. Good morning, George. Thank you for having me here. The closeout crew will be informed that at the LOX area we have a series of pumps that pump the liquid oxygen up to the vehicle, and we have a bearing problem, temperature with one of the pumps. But what they'll do is NTD will come over and they'll let the OVCC Travis Thompson know exactly what's going to happen. There's a possibility there'll be a loud venting noise when they swap over the pump, because they'll have to shut it down, bring the other pump online. Pressure might come up. They might have to vent the LOX tank, and in the event, the crew and our closeout crew in the white room will be able to hear that, because it's right out of the top of the tank, you know, 70 feet above them. The switchover probably won't take very long, and it really won't affect our guys in the white room or the crew. It's a GSE function, and the ground support guys will take care of it in a timely manner, and it won't cause any holdup, I'm sure.
OTC, CST.
They'll be right in and out, and it looks like work in the white room's going right along. Travis has got the crew. They've been pulling potty platforms and some other platforms out. You know, we have a temporary install document that we work to, George, and we make sure everything comes out. And we had 26 line items this morning that were put in the ship, and they're in process of taking part of those out right now.
Well, the crew's on board. They're doing their communications checks with the firing room and mission control in Houston. Right now, the
Still don't hear you coming through, George.
The closeout crew right now, they're getting ready to do a number of things. At this point, the items are coming out of the hatch, Tim, right? And then once everything is out, and I gather that's got a while to go yet, there's still a lot of red tag items, I guess, that we heard Jim describe, that the closeout crew has to help with removing. And then what's their next function? What's the next thing they'll do?
Well, once all the appropriate items have been pulled from the ship, George, they'll take and they'll clean the hatch seals. They'll get ready in preparation for the hatch closure. Then they'll go into crew compartment pressurization. They'll hook up the probe. They'll bring up pressure into the crew module. And our NASA quality, Jack Burrett, number 6, that's one of his main objectives and priorities, is to make sure that everything is out of that vehicle. We don't want to leave anything in there that's not supposed to be. So between Jack Burrett and Travis Thompson, the OVCC, they concur with each other. As each piece comes out, we check that off. one by one, and at the end they buy that off and verify that everything's out of the ship that needs to be.
Well, Tim, we've got a video of the closeout crew that shows a little bit more of them personally and some of the activities that they did during the terminal countdown demonstration test. So if we could go ahead and roll the tape and tell us who the closeout crew members are that we're seeing.
Okay, George, I'll be happy to do that. Well, obviously this is Travis Thompson. Travis is our OVCC. Travis is a really close friend of mine. We've been together since Little League Baseball. We've worked together for 30 years. Travis has been an OVCC and a closeout crew member for over 100 launches. Travis was born in Vandenberg Air Force Base. His dad was in the Air Force out there. And this is Drew Billingsley. Drew is one of our insertion techs from Houston. And they call him Hollywood, but he's got a little Hollywood in him. But Drew's very, very professional at what he does. He's a top-notch suit tech. He's right on time. He knows exactly what he's doing, and he makes our job easy. Now, our number 4 is Renee Arians. Renee has been part of the crew for about 20 years, and Renee's done probably over 40 launches himself. Jack Burrett, our NASA quality. Jack's been here for over 20 years, and actually 26 years with NASA. Jack was raised in Melbourne. He was born in Wisconsin and grew up and down in Melbourne and went in the Marine Corps and then came back to work here at the Space Center with us. Now our number 5 sitting inside the hatch there, that is Chris Meinert. Chris is probably our senior closeout crew guy next to Travis. Chrissy's done a lot of closeouts. I'm guessing probably 60 or 70. Chris was born in Long Beach, California, and grew up in Palmdale. And Chris actually worked in Palmdale at the plant building some of the orbiters in the early days. And this is our ass, Randy Bresnick. And Randy's been part of the astronaut office for at least 7 years and done 5 other launches. Ray Cuevas is our other suit tech from Houston, and Ray's been with us for 14 years, I think, as a closeout crew guy, and he's worked a total of 28 years and has done 17 launches, as a matter of fact.
And here we are back live in the White Room. Still, we can see them taking out some emergency breathing air packs right now.
Yeah, Randy just came out. They finished their air-to-ground checks. Randy brought the comm out. You see Renee just pulled what we call the diving board. Drew's taken that gold-looking piece of equipment out. That's the diving board that goes across from the White Room into the vehicle. That makes egress and ingress out of the vehicle much easier. The big yellow hose, that supplies air cooling air into the crew module.
NOTC of ECC.
When they're talking, we stop, right, George?
Yeah.
And my TIRs are clear. My ass has left the ship. I'm getting ready for hatch closure.
Okay.
Yeah, like I just said, I heard him talk to Travis. George, we've got all the TIRs. Everything that's temporarily installed has come out.
Getting ready for hatch closure.
And we're going into hatch closure.
Items removed, including the ass, huh?
That's affirmative.
Okay.
What you see now, George, is Chris, the number 5, is wiping the seals on the hatch. That seal, when we pressurize the crew module, keeps that valuable pressure inside the crew module. A single hair could cause it to fail, and we'd have to go back in and repressurize. Now, NASA Quality is looking at the seal as Chris cleans it, number 6, Jack Burrett, and now Chris is going to the board side of the ship, the onboard hatch, the inner seal, and he'll be wiping that down. They've already pulled the protective cover and the tape off of it, and Chrissy's actually cleaning that seal now in preparations for closing the hatch. Renee's just holding the air hose to keep them cooled off. It gets a little warm up there when you start working around in tight quarters with 4 or 5 people standing there. But Chris is doing a really detailed inspection.
This is Nancy.
Yeah, you ready for a momentary loss of downlift?
I can verify that we can lose downlift in the next 3 minutes.
Okay.
So Chrissy's finished wiping.
NOTC of ECC. I'm ready for 769. That's your call.
Yeah, we just heard confirmation that they're ready for hatch closure. About what temperature do they keep it in the white room?
About 76, 74 degrees.
You want to go to 142 with AFM?
Yes, ma'am. It's your concurrent.
All right, I'll send the QC over there. CMQC OTC?
Go ahead.
I need somebody on 142 with Op 267 AFM.
Copy.
And PVD OTC?
Copy. PVD?
Yeah, you ready for opening the vent doors?
Yes.
Okay. And CGLS OTC?
Yeah, let's go.
Orbiter vent doors will be moved momentarily, step 765.
Yes, ma'am. We copy. Thank you.
Okay. And PVD, you've got to go.
Okay. For 764, please record left hand. Or correction, position of vent door is in purge position.
Purge, okay.
Can you explain a little bit about what we just heard there about the vent doors?
Yeah, as we just heard, George, they were talking to vent door positioning, which is critical to keeping the vehicle in a certain pressurization point. Those doors open and close. We close them completely, partial open, full open, and it helps with the purge on the vehicle. They just got to go to close the hatch. Chris and Renee have closed the hatch at this time, and it looks like they're probably, they're going to put on the carrier panel that covers that portion. They pulled the handle off, our GSE piece that we use to handle the hatch.
768, leeward vent doors open.
Okay. OVCC OTC?
Hello.
Okay, and back like I was saying, you see Renee walking out there. That's our GSE hatch handle that we use, George, to close and open the hatch. They've got that off, and there's protective tile that goes back over those two places that that Renee and Chris will put on. Once the handle's taken off, it gives you access to where we can go into pressurization. That'll be one of the next things they do, is they'll pull the big line off the ceiling, we'll hook it up to the hatch, and we'll pressurize the vehicle, kind of like they do with an airliner. When you get ready to go up on an airliner, they pressurize the cabin, and we do the exact same thing on the shuttle. Now we've got everybody in the white room now. Ray Cuevas and Drew Billingsley and Randy. Randy's holding the hose. They don't want to leave Randy out. They want to give him something to do, so they're letting Randy hold the hose. And you see Travis is walking back and forth. Our OVCC is telling the guys that are actually doing the work that they have a go to do certain things. Everything comes from the OTC or the NTD telling we have a go for this. So that's exactly what Travis is telling those guys. Okay, you've got to go to do the hatch, do your pressurization, do your carrier panels, whatever the sequence of events that comes through from OTC goes through the OVCC and then on to the number 4 and 5 that do all the mechanical work on the hatch itself. And our NASA quality is right there with them. You really can't see Jack, but he's standing in front of Randy and he's watching what Chris is doing right now, and Renee is talking to ECL, probably going to bring up pressure, getting ready to do pressurization of the crew module. I know what they're doing now. Yeah, at this time, I see now, George, they're doing the seal leak check. When I told you before that Chris was wiping down those seals, we take a handheld unit and we pressurize between those seals. And what we do there is we're verifying we don't have a leak. So there's a time frame that we pump up, we bring up to pressure. We shut the pressure off and we do a decay check basically, where if we're allowed 1 psi drop in 2 minutes, as long as we don't go below that 1 psi drop, we've got a good seal, everything's holding the hatch, everything's sealed tight. That's exactly what we want to see.
And did they see if that's correct, or is that being conveyed from the firing room tells them that that is good and correct, or how do they know, how do they get the word that it's good?
Well, we work to a procedure there.
GNC. Step 780 is complete. I am user in alignment maintenance mode.
Thank you.
So we've got a procedure, like a checklist that we go through, and that calls out the parameters that we're allowed to. Our GSE piece of equipment is ready and charged when we go to the hatch. We put it on, we open the valve, it pressurizes a very small space around the hatch. And we're allowed an allowable leak rate, but it can't go beyond a certain point. If it does, then that means we have dirt or...
VCC on 212.
Go ahead.
Yes, ma'am. Hatch is closed and latched for flight. Ready for cabin leak check.
Okay.
That's also 16774 in your dot 2.
Okay. And just to let you know, we did reposition the vent doors. Leeward vent door opening is complete.
I copy that.
They just...
And I do have a buy for you if you want me to go to 132. If CMQC is still there, I got a dot 100 buy for part C.
And CMQC, do we still have somebody monitoring 132?
It would be me.
I'll meet you there real quick.
Copy.
Hey. Yeah, so the OVCC just called in that they have the hatch latched and locked. Good seal leak check, and the next thing we'll go into hatch pressurization.
CDR and ECL, stand by to perform cabin leak check. Master alarm and light will come on as a function of high cabin pressure. CDR, you should notify ECL that we've got the alarm, and you can reset when you get it.
CDR copy.
And CDR, you have a go to perform cabin leak check per your checklist.
Good work.
Okay, George, what they've done, they've got the okay from OTC to start cabin pressurization.
OTC, CDR, the L2 steps are complete in cabin leak check.
Copy that. And ECL, OTC?
ECL.
You've got to go on 778.
Copy, that's in work.
And you'll need one of the techs on 143 with you?
That's affirmative. I think we have them.
All right. And OVCC, you've got somebody on 143?
Back on 212, yes, we do on 143.
So they're all participating in this.
Yeah, it takes all of them to do this portion here, George. And OTC gave them the go. Our number 4, Renee, is going to be running the panel, which that gives the pressure through the hose into the crew module. And like they were saying, the commander will get a series of alarms of overpressure going off in the cabin, which he will just nullify the caution and warning alarms, and will pressurize right on up to 15 pounds. And that's what Chris is getting ready to do up on the hatch now, is they will hook that pressurization hose up, and Renee with ECL Engineering in direction over the net.
Yes, ma'am.
You got somebody over on 143, right?
That's firm.
Okay.
Renee will be talking to ECL Engineering, and she will give him the direction of where he needs to go, what valves he needs to open, and what pressure they're expecting to see. At that point, we'll pressurize the vehicle, and we'll get it all ready for the crew. And at that time, you see the cap Renee has in his hand right now. That's the cap that will go over the pressurization port. It's just basically a hole in the hatch that once we pull the probe out, it's been putting pressure in the vehicle, that cap right there goes on. That's one of the last pieces of hardware that we put on the vehicle right there, that cap. And that cap has 2 O-rings in it, and it's not torqued like a lot of things. That cap is basically hand tight, as tight as we can get it by hand. And once it's on, that's the way it'll remain all through the flight. And that'll be one of the first things they take off when they get back. Once they get the carrier panel off, that comes back out, and that'll all be taken off when we get back on the runway. It looks like Travis is up with a hatch with Chris giving a hand too. It takes just about everybody to do this, George. OVCC's up there because Renee's running the panel. You see the NASA qualities going over the steps with Renee on the book through engineering direction, and we've also got a hard copy up there in case there's any kind of comm loss or anything. That way they know exactly where they're at in the book, and they can disseminate that back to the OTC and ECL Engineering that's directing them to do this job at the time right now. It looks like they've given Chris a go. I think he's got the he's got the hose in his hand. He and Renee, they'll be putting this, it's about a 1-inch braided flex hose with a series of fittings and a little bitty probe that goes through the hatch into the crew module. And yep, that's what Chris is doing right now. He's hooking that up. We take and we count the threads, George, when we screw that on. That when we get ready to take it off, we know exactly when we get to that last thread. And that way when we pop it off, we don't want to lose any pressure out of the crew module more than we have to.
One thing I'm going to mention real quick, we just hit T-minus 1 hour and counting in the countdown. So that puts us just a little less than 2 hours for launch, considering the built-in holes remaining at T-minus 20 minutes and T-minus 9 minutes. But the good word is right now that everything is still pressing on as planned for an 11:26, and we get down to T-minus 9 minutes. That we'll be taking a good hard look at where everything stands, particularly as far as the weather goes. But looks like, Tim, they're hard at it right there.
Yes, sir, they are, George. They're this is one of the final preps. Actually, it's the last thing that we'll do inside that's actually going into the crew module. It's air, and Renee is talking to engineering. Chris and Travis are over there, and they've got the probe hooked up, and they'll sense the pressure inside the crew module. And ECL will tell them, and Renee will back the pressure down. And once they get to the pressure that they're looking for, that probe will be disconnected, and the hatch cap, what we call the hatch cap, will be put on. And that's all done within just a matter of seconds, because we can't lose too much volume of air out of the cabin, or we'd have to go back and repressurize it again. And we all trained for this. We've done it 100 times, and it's a coordination between the 4 and 5. When the 5 pulls the hose, the 4 puts a cap on, and you're right there together. And there's a considerable amount of pressure blowing that back off. And once the probe is pulled off, you try to get that cap as quick as you can.
Go ahead.
Yes, we need a panel reading from the crew.
All right.
CDR, ECL.
Go ahead. If it's cabin press, it's 14.9 on the gauge.
Copy, 14.9. Thank you. OTC, ECL.
But ECL.
Just a heads up, we're about to begin pressurization. There will be a master alarm and klaxon.
Copy. CDR, you copy?
We copy OTC, thanks.
Okay, George, it sounds like they just got the go, so they're going to start bringing up pressure. The commander gave them the pressure inside the vehicle right now. ECL's calculating that pressure. They'll open the gauge, they'll open the valve, and they'll start pressurizing the crew module. That's what Renee's doing right now. He's talking to ECL Engineering. The probe's hooked up. They're ready for pressurization.
CCSE and RCRT OTC?
CCSE.
Yeah, can you guys go to 232 for S-band to high power?
Yes, ma'am.
And Tim, what they're about to do right now is to take the Mila tracking station. The big tracking antennas are now going to be going from low power to the high power mode. So that's what that direction was, because that's about to happen. Usually happens at about 55 minutes, T-minus 55, and we're coming up on that in about 40 seconds.
So that's the Mila tracking station. Okay, George, that the big hose, the yellow hose is nothing more than an air conditioning hose. They're keeping the crew in the white room, the closeout crew, and the white room cool down. That's the only air that we really have in there right now, because the ducts have been diverted and all the air is coming out of the yellow duct. And that's why Randy's holding it, point it towards the guys, trying to keep them cooled off, because it's pretty warm in there right now. I imagine it's probably close to 80 degrees. And as you see, Drew's putting on his lap pack. So that means we're getting pretty close, George, to getting to where we want to be this morning with a closeout crew. Drew and Ray will take the final pieces and parts out of the white room. They'll put it.
OTC, we received and silenced the master alarm.
Copy that. Thank you.
The number 6 and the number 4 are donning safety harnesses. As you see the green harness that Jack's putting on right now, and Renee will have one, that's for breaking the white room down. Opening the doors, closing doors, breaking it down, getting it ready for launch.
So is this harness, is this for them or is this for the equipment? It looks like it's for them. They're putting it on. Okay.
Yeah, the green harness that NASA's putting on right there, once they open the big door where the hatch is, it's a long ways to the ground from there, George. It's 195 feet to the top of the MLP. So they'll hook off to the ceiling on approved tie-off points, and then that door will be, it'll come back to the right, and the other door will come back to the left, and they'll open and they'll put a handrail out. If in the event that the crew would have to get out without us there, we extend a handrail out, they blow the hatch open, the arm will swing back, they'll be able to get out safely. Now the diving board won't be there like we talked earlier, that big gold diving board. We put it in the locker so the crew knows, they train, we train on the pad with them, and they know they got to crawl across that threshold where there will be nothing at that time.
Once the orbiter access arm is back, if they have to put it back into position because there's been some kind of emergency, something goes wrong, have you any idea how long it takes to put that orbiter access arm back in place?
Yeah, George, we have what they call an emergency extend. It goes into a full mode, no restriction, and the arm can extend back in less than 10 seconds. From the time they energize it to its full back against the vehicle, it only takes about 10 seconds. Now on launch, when they rotate it back, it's nice and easy, it's methodical, it comes back. But in the emergency event, that we've got a mode and we go into emergency extend, and it's there now. I mean, if the crew could get out, when they extended that arm, they couldn't get out as quick as the arm could be there. And that's what Renee and Jack are doing now with their harnesses. You know, when those doors and the dock seals are all deflated, the protective cover.
OTC. CCME, OTC.
CCME.
Yeah, we're ready for 807, our source verification.
Yeah, we'll be doing number one on that.
Number one?
Yes.
Okay.
Two is not performed.
All right.
Renee's putting a protective cover over the ELSA rack there, George. Those are the ELSAs that we put in the vehicle. When the crew's getting strapped in, we have a ELSA in there for every person that's in the vehicle at that time. In case we'd have an O2 deficiency, they could grab an ELSA and breathe.
Emergency breathing air. Right.
It's emergency breathing air, exactly right.
And that's Roberta Wyrick from United Space Alliance, who's the orbiter test conductor that we've been hearing interacting with the closeout crew and with the flight crew while all of this is going on.
Yeah, we worked a lot with Roberta over the last 30 years, and she's been here a long time, and she keeps us straight and lets us know what's going on when we need to know it, and very helpful for the closeout crew because she keeps them abreast like the guys going out to fix the LOX pump. You know, they knew there was no second guessing. They weren't alarmed by a venting. But you know, Roberta's worked with us for an awful long time, and all our guys are very appreciative of Roberta and her whole group. The OTC office all does a fine job for the closeout crew guys because we're out there by ourselves. You know, there's nobody else there with us, but so they keep us abreast of what's going on around us. You're kind of in a confined space there in the white room. Yeah, there's an awful lot of work that goes on there in a short period of time, George. You know, from the time that we get to go to close the hatch, you're making sure everything's done. You know, and as the folks out there can see, that that silver hose that's hooked up to the hatch, that'll be the last piece of equipment that's actually hooked to the vehicle before launch. We take that off. The closeout crew takes that down. They put a cap on. They put a carrier panel on, and that's the last piece of flight hardware that'll be put on the vehicle for this flight, and that's part of the closeout crew. You know, when you put that last piece of hardware on, you go through your mind, we all do it, that everything is done just perfect as we can make it, because when we walk out of the white room, we got to know that things are just right. And all of the fellows that are up there today have done this many, many times, and unfortunately it'll be their last time of doing it, and but I can guarantee it'll be done right. You know, these three guys that we have in our NASA quality are all very experienced and are very good at their jobs, and I've worked with them all for 30 years, so it's going to be a great day, especially if we get to launch. And I think the weather's probably going to help us out a little bit, George, and we'll get to do this today.
A little more optimistic. We live in hope here. So they go back when they leave the white room. Where do they go to?
Go ahead. Our RF step verification is complete.
Copy that.
Once we leave the white room, George, we'll go down to the closeout crew truck. We'll unload the elevator, and you know, we've got just a few minutes to depart the pad. We normally stop at the top of the pad and gaze back at the vehicle one last time, make sure everything's right, you know, because the RSS is back, and we look at it and everything's just pristine, you know. And my last one was a night launch, and that's really pretty with the lights on it. But today, hopefully the sun will shine on us, and we'll get it done. And once we leave the white room, we go down and we pack our truck up. And from there,
Got to go on 8:58 mainline activation for the clock.
For the clock.
and then once we leave the pad, George, we come back. You can see out the firing room windows here. We park at the AB-11, and we park the closeout crew truck. The OVCC hooks up OIS. He tells the launch director and NTD that we're back, and we tell them when we leave the pad, and then once we get back there, we're stationed in the event that if we would have to go back to the pad in an emergency situation, or just very quickly go back to the pad.
CPS. You ready for step 870, your LDB redundancy check?
That's affirmed.
You need a QC?
Negative.
Okay.
And I think we also heard them say they could pick up with activating the ground launch sequencer at the nominal point in the countdown, so that's another encouraging sign that there is no reason not to continue to press on down to T-minus 9 minutes.
Yep, that's a good sign.
OTC, CGLS on 212.
Go ahead, GLS.
Yes, ma'am. GLS mainline activation is complete. That's steps 859 through 864, and 861 is as listed.
Copy as listed.
So are they getting close to where they would be leaving the right room at this point, or they still have more to do?
They still got about 10 minutes worth of work to do, George, after they pull the probe off the hatch.
OTC?
UCL.
How are we doing on crew module press?
It's still in work.
Okay. Any estimate?
I will need a...
Okay, George, sound like we just got word from ECL Engineering that we got about 5 or 6 more minutes in the pressurization of the crew module. And at that time, Renee will bring the pressure off the panel. Chris will disconnect the hose, and they'll put that cap ready for flight. And after that, we'll have about 5 minutes, 8 minutes it takes to break the white room down. Jack Burt and Renee, that you can see with their safety harnesses on, they'll be the two breaking the white room down. And then once the white room's broke down, the OBCC goes through, makes one scan, makes sure nothing's left in the white room, no FOD, everything's cleared out, and that'll be the last thing that the closeout crew will do in breaking the white room down and making sure everything's out of the white room. So it won't take long, and they'll be...
Well, Tim, we just got some good news about that pump change out that we had going on underway out at the pad. Tell us what we've learned.
Well, they had a successful changeover, George. They went to the other redundant pump, and the temperature was going down, and they decided to do the changeover. And that pump's up, running. Temperatures are all good. We got a few more minutes before the temperature actually will come up to where they want it to stabilize at, but it looks like everything's going and coming right up to where they want it to be. That's why we have 2 sets of pumps. That way we got 2 motors, 2 pumps. That way if we have a problem, just like that, it's a short fix, a quick changeover. And without that, we might not have launched today if we only had 1. That's why we got redundancies almost everything that we do. So it's a good thing we had another pump today at the LOX area.
And so that they actually removed and replaced it and put in another one.
Actually, all we had to do, they had to go in and just change over. They wasn't actually a physical change. They just redirect the from pump 1 to pump 2.
Oh, okay.
It's just a quick changeover. It wasn't like they had to unbolt that pump, put another pump in. There's actually a pump there, but they got to do some valve diverting in order to do that.
Okay.
OTC detail.
Those pumps were changed out about 15 years ago, George, or better. I worked that system for a while, and we did that back when I was there, as a matter of fact. We put new motors, new pumps, and all in.
CDR copy.
Okay, looks like they got to go. I didn't hear them, but I think they said they had to go for... Yeah, it looks like, George, we got to go. Renee and Chrissy are going to take the pressurization hose off the hatch at this time. Renee's pulling the hose off, and Chris is going to put the cap back on.
OTC. OTC, CMC.
Go ahead.
Page 1177. Did we give completions on all that?
Yes,
And step 16861, that was performed?
Yeah, and as written, just with the 1X there, the 1 bypass.
Copy that, thank you.
Okay, George, Renee just pulled the pressurization hose off. There's a good shot of it right there. Kind of looks like a pistol grip and a safety protector that he's putting over it right now. It's actually a little 1/4-inch piece of tubing that goes through that port, you know, with a large adapter. And the number 5, Chris Meinert, is putting the hatch cap over the port, and ECL and the commander will come up and tell them where we're at in pressure. And the way the exchange went there looked like we probably didn't lose anything at all, hardly. So with all probability, everything will be just fine. They'll give them a go to put a carrier panel on, and they'll start breaking the white room down, and closeout crew will be out of there in a short period of time. They just disconnected it from the ceiling. As you see Ray Cuevas there, you know, it's a whole team effort with these guys. Everybody's got a little piece of the part they need to do. And Ray and Drew are wrapping that hose up. They're going to put it in a storage cabinet there behind where the OVCC stands. And Chris is actually doing the safety wire now on the cap. Like I said, that cap is hand tight. Where everything else on the orbiter just about is all torqued, that cap is actually hand tight. But once it's hand tight on, Chris will safety wire it with a piece of safety wire, which will hold it in place where it won't come off. And the carrier panel goes over it, so there's no way for it to escape if it were to come off, but we've never had one come off. So, but it looks like Chrissy's got it safety wired, and they'll go in. Renee's looking at the hardware now for the carrier panels. There's 8 screws and washers that go on the carrier panel, and once he gets those ready, they'll take that carrier panel, they'll put their protective gloves on to keep your skin, your oils off your skin. We don't touch the carrier panels or the tile on the orbiter with our bare skin. We do it with gloves on. So once Chrissy has that all safety wired on, and next thing they'll do, they'll give them a go, and they'll put the carrier panel on. And looks like they're probably going to start getting ready to take the air conditioning away from them. So it'll get hot in there in a little bit. But I see Jack Bird, our NASA quality. He's in the corner of your picture there. You can see he's probably going over the last bit of look-see.
Good, ma'am. Yeah, step 890. Now that the hatch is closed, can we get that step from you?
Copy that. I can give you step 90.
890, thank you.
Yeah, Chris just finished what we call a Bergen safety wire tool, George. I seen him walk back with it. He's got the hatch cap on and safety wired.
GLS OTC.
That's on 212?
Yeah, GLS, you can verify 887, is that correct?
My please.
You see the red streamer on the hatch there, George?
CTLS on 212.
Go ahead.
Yes, ma'am, that is verified.
Thank you.
You know what that red streamer is?
I would assume it's a remove before flight tag.
That's exactly right, and it's on the hatch window. And you know, that little bitty window is the most optically clear window in the whole vehicle. It is as perfect a piece of glass as you can get, and it's in the hatch. That's why that covers the last cover that we take off. All the mechanical doing are done. We wouldn't want to scratch that window whatsoever. A lot of our great photos that come from space, they actually take out of the side hatch window.
Really, right through the hatch window.
Right through the hatch window, because it is so optically clear. It's amazing. But Jack verified Chris's safety wire job. that the cap's safety wired on. He's going through his book right now, making sure that all those steps are bought off and complete, and he's giving them a go to put the carrier panels on.
OTC, CGLS on 212.
Go ahead, GLS.
Yes, ma'am. I've got a couple steps to buy off with you if you've got some available time.
Okay, go ahead.
Copy. We have steps 814 through 820 complete, and I've got some fill-ins for you if you're ready to copy.
QC, you ready?
QC's ready.
Go ahead, GLS.
Yes, ma'am. On 814, the first fill-in should be 0 hours, 9 minutes, 6 seconds. That's for window open. For preferred, it would be 0 hours, 4 minutes, 33 seconds. On 818, step 818, for the T-minus 20-minute hold, that would be 0 hours, 10 minutes, 0 seconds. And for T-minus 9-minute hold, the time remaining shall be 0 hours, 41 minutes, 13 seconds. And for preferred, 45 minutes and 46 seconds.
35 or 45?
45. 45 minutes, 46 seconds.
Okay, thank you.
Yes, ma'am. And that should be it.
Thank you.
So that last preferred was 004546.
That's correct.
Copy.
OTC, ECL.
Go ahead, ECL.
I can give you step 865, crew module pressurization and initial cabin integrity check is complete. We're ready to proceed with cabin vent redundancy.
Okay. CDR, OTC, perform cabin vent redundancy per your checklist.
That didn't work.
Yeah, what we just heard, George, was that the cabin pressurization all went well. The CDR shows good pressure in the crew module, and OTC.
Cabin vent redundancy config is complete.
Copy that. UCL, you copy?
UCL copies.
So all of our pressurization is good inside the crew module. The vehicle's pressurized and ready for flight. And it looks like Chris is putting the last carrier panel on at this time. He's got, actually there's only one carrier panel now. Back when we started we had 2 carrier panels, and we were able to go away from the old style hatch handle, and the new handle we only got 1 carrier panel to put on, which was a big relief. We've had more than one time where fastener would gald and we'd have a problem, and so we took out half of that equation by going back to 1 carrier panel.
OTC, QC.
Go ahead.
Step 16-866. We show that complete, correct?
That's complete, yes.
Copy that, thank you.
CDR, OTC,
CDR, go.
perform past BFS transfer prep per your checklist.
Fast BFS transfer inward.
OVCC, OTC.
Yes, ma'am.
Looks like you're working ahead, but you've got to go to close out the white room.
Thank you very much.
OTC pass BFS transfer prep complete. And we're waiting on the asterisk.
All right. And you have a go for ohms GN2 press per your checklist.
Ohms GN2 press and work.
And PLT OTC?
Go ahead.
Got to go for water spray boiler GN2 supply activation per your checklist.
I'll put that on work. OTC ohms GN2 press is complete.
Copy that.
Water spray boiler GN2 supply activation complete.
Copy that. Thank you. CDPS, can you give me step 909?
I can verify step 909.
Thank you. And that takes care of 910. HYD, can you verify 922?
That's verified.
Okay, thank you.
Okay, George, they gave him a go to close out the white room. Chris just took the protective cover off of window 11, and they'll start into breaking the white room down.
APD OTC.
APD go.
Mech pre-flight bite, step 930.
Copy and work.
Yeah, Renee's hooked into the ceiling at this time, and Jack will hook in right in front of him, and they'll...
OTC. CHQD OTC.
Go ahead.
Step 935.
We'll put that in work.
Thank you.
OTC CGLS 1212.
Go ahead.
GLS limit change and dual notification for BRS is complete. That's step 936.
Copy.
Okay, they did the group photo for us there, George, and they got all 7 of them in, and I hope it didn't break the camera. As you see there,
Stand by for SIMO air-ground voice checks.
We are standing by.
Well, Tim, they're wrapping up the white room now, so we can see that underway. The crew's about to do their air-ground voice checks, so we're going to thank you very much for coming by at this point.
Com check.
Thank you, George, for having me today. Been a pleasure.
CDR loud and clear.
MS1, NF2.
Atlantis Houston, we read you all loud and clear, and we are ready now for updates. The first one is your altimeter setting on page 1-10. And that setting is 29.96.
Okay, Butch, we have 2996.
That's a good read back, Atlantis. The next update is on flipbook, page 2-4.
All right, ready to copy.
All right, your no-com mode boundaries updates are pressed to ATO 104 or 10.5. Your single engine ops 3 109, we're going to leave at 12.3. Press to MECO 104, 14.4. Single engine press 104 will be 17.4.
Okay, press to ATO 10.5. Press to MECO 14.4. Single engine press 17.4.
Again, a good read back. The next update, the next page on 2-5, your throttle bucket updates. Throttle down will be at 0.96 Mach. Throttle up will be at 1.35 Mach.
Okay, throttle down 0.96, throttle up 1.35.
Again, good read back, Fergie, and this completes your ascent checklist updates.
Copy all, Reg, thanks.
CDR OTC.
Go ahead, OTC.
Perform cabin vent per your checklist.
That's in work.
SAMQC step 899 will be not performed.
Copy. OTC, Steve.
Go ahead.
I can use steps 931 through 934. Mech pre-flight evaluation complete. No mech failures.
Copy that. Thank you.
OTC cabin vent is complete. We received the klaxon and we silenced it.
Thank you. And ECL, stand by to give pro word closed cabin vents on 212 if you see a decrease in PPO2 below the baseline.
ECL copies.
Attention all personnel, our countdown clock will hold in 1 minute and 30 seconds at T-minus 20.
TWS OTC?
Go ahead.
Can you verify 918?
Verified.
And we're standing by to go into the hold at T-minus 20 minutes and 15 seconds. This will be a 10-minute built-in hold.
Attention all personnel, countdown clocks at T-minus 20 minutes and holding. Duration of that hold will be 10
And we are now at T-minus 20 minutes and holding. This is a 10-minute built-in hold. Closeout crew still wrapping up in the white room.
All personnel or all orbiter systems verified program software report only if any discrepancies. JRPS OTC?
JRPS.
Step 968?
968 is complete.
Copy.
And OTC OVCC?
Go ahead.
Yeah, 267 is complete. I can give you the last, I'll have my book.
Okay, so you're saying that you are completely closed out and you're ready to leave the white room?
Yes, ma'am.
This is shuttle launch control, T-minus 20 minutes and holding with 8 minutes and 30 seconds remaining in this built-in hold.
And
joining us now here in the firing room is Hugh Harris. He was the flight commentator for STS-1, the very first space shuttle launch. And Hugh, it's very, it's gratifying that you're able to be here for this, because this means that you've been able to witness the entire history of the shuttle program and were the first commentator for STS-1 for Columbia. And Hugh, we've got a short tape that we want to play right now because it shows Columbia being launched and your last few minutes doing the liftoff.
T-minus 20 seconds and counting. T-minus 15, 14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start. America's first space shuttle, and the shuttle has cleared the tower.
Well, Hugh, what are your recollections of that first countdown?
Well, I think that it was just fantastic to be here for the first one, and I was a little bit nervous. You may have noticed that I missed by a second the main engines lighting up, but this was an exciting place to be, and you know, seeing it get off the ground after all of the years and all of the thousands of people who worked on it was just tremendous.
Vent doors 1 and 2.
Well, I can remember when you were preparing for that launch commentary for STS-1, I can remember seeing you in your office working on that. And I mean, there were papers all around your computer and you're working away. I mean, there's so much going in to prepare for that. And then later, I can remember when you were actually going over the firing room to actually do the commentary, and there was a humongous notebook. This is the White Room crew doing a quick sayonara here. We did want to catch that. And that's a final goodbye from our closeout crew. We did want to catch that since that was going on. But anyway, you know, I can remember you going over to the firing with this humongous notebook filled with all of these notes and your commentary and everything like that. And of course, you had to go through it more than once, as I recall.
Yes, and the reason I had so many notes was that unlike today, the communications were not nearly as extensive. And George Page, who was a very tough launch director, had decreed that we would not talk to anybody in the firing room no matter what happened. So I needed to have the phone numbers of people outside the firing room who might know about a particular system in case something went wrong. And as you recall, on that very first countdown, something did go wrong. The computers were out of sync with each other, and that was something that was pretty difficult for everybody to instantly realize, but we did scrub that day.
Well, I can certainly remember my first launch commentary, which was STS-27, and you were sitting right here next to me, and it was on Atlantis flight. So that's not lost on me that my first launch commentary was Atlantis, and the last one will be Atlantis as well.
and it was a Department of Defense mission. And it's funny, I can't recall the number of commentaries that I've done over the years, but somehow that very first one is still in my mind, almost like it was yesterday. As many years ago as it can been, I can clearly recall the entire activity.
Well, on the DoD launches, we didn't give you much to say because people weren't supposed to know in real time. And that's what this job really is all about, is keeping the news media, the American people informed on a second-by-second basis as to exactly what is happening. And that's really pure journalism in a lot of ways.
And the window closes at 15:31:19.
Well, I think we're about to reach the close of a program that's it's a very storied program, and I think we look back at all of the things that the shuttle has done, the astronauts have done, because it means we had initially delivering satellites to orbit. We deployed the Hubble Space Telescope. We did all the servicing missions. We went to Mir. We did the space station. We did the space lab flights. It is so broad, and it really just kind of has set the stage for what we'll be doing next as we go on.
Well, the important thing to remember is that going to space is really all about the people on Earth. What we're learning is more and more about the environment we live in, and the technology that comes from the space program benefits every single person in this country and really around the world.
Well, Hugh, thanks very much for coming by. It's quite a pleasure to be able to chat with you and actually recall STS-1 and to know that we were both here for the first one and we're here for the last one. So thank you very much.
Welcome, George.
CGSS OTC.
Go ahead.
You can start your second HCU pump, step 1030.
And attention console operators, discontinue all LDB commands and reads during pass ops transition.
ECL OTC.
ECL.
How are we doing on cabin vent?
I was just about to give you 947.
Okay.
Fill in for 948 is 14.75.
CDR, report cabin press per your checklist, please.
Stand by.
The countdown clock will resume on my mark. 3, 2, 1, mark.
And we are now at T-minus 20 minutes and counting. Our next hold is at T-minus 9 minutes.
COT3 is 14.75. On 01, it's 14.9.
14.75, 14.9. And close the cabin vent valves per your checklist.
CDR 1.
NTD SRO 212.
Go SRO.
Range status is go. Weather reports there are clear on all constraints. Range status is go.
NTD copies, thank you.
ECL OTC.
ECL.
Let me know when you can verify 952.
That's verified.
Thank you.
OTC close vent valves complete.
Copy that. Thank you.
OTC DPS.
DPS.
CD step 1035. Pass ops transition complete. DPS ready for BFS transition to ops 101.
NTD OTC copy.
NTD copies.
CDR OTC clear pass fault sum and take BFS to ops 1 per your checklist.
Clear pass fault sum, and we'll take the BFS to ops 1.
NTD Milo 212.
Go ahead, Milo.
Our datacom switch is hung up and we need to reset software.
All right, Milo, can you repeat what you have there in the SPE? Are you with us? And CCSE, I guess, if you're listening as well. Milo, what did you see you had?
Our datacom switch has hung up and we need to reset the software.
Okay, what will be the impact of resetting that software?
No connections lost. Will allow us to make connections when the loss.
Okay, is this an action that needs to be taken immediately, or can we stop and talk about it for a minute?
It's NTD to Smile. It's going to take a couple of minutes for the reset. The reason we need to do it is if right now we're okay as long as we don't have to make any switch changes, but if we lose a line or something happens, we lose a blocker, we won't be able to make any changes on the hand, on the fly to recover without doing this reset. You have to do it.
Okay, and CCSC, any input on this?
No, we don't have any concerns at this time.
NTD.
To establish the comm configuration in case I got to go change something, you know, my concurrence, if you're okay with it, Jeff, to allow the Milo guys to reconnect and see if that's successful.
Yeah, based on what I'm hearing here, I'm go with that as well. Milo, go ahead and make that change and let us know when you get that.
Copy that, sir. Thank you.
NTD SRO 212. Go SRO.
KC radar 19.39 is partially operational. The skin track time has been reduced from 440 seconds to 290. We have removed radar 19.79 and an additional mandatory range status is go.
Excellent, thank you.
NTD CFS.
Go ahead.
I can give you 1049.
Copy 1049. And Houston flight, NTD ready for 1050. Perform BFS pre-flight uplink loading.
NTD Houston flight, I copy, and we will put the BFS pre-flight uplink load in work.
OTC PLT, horizontal set config, and config contingency report, yaw steer, complete.
Copy that. And PLC, you've got to go for MTS helium reconfig for your checklist.
That's in work.
Entity Launch Director 212. Yes, sir, go ahead.
Yeah, how's your constraints list look?
NTD Bala 212.
And Launch Director, we'll check on that, and I'll get right back to you. Copy. Mila, NTD?
Yes, a DATACOM switch has been reset, and we're nominal at this time.
All right, very good. And CCSEU copy?
Yeah, CCSE copies, and we saw no impact from that fix.
Excellent. And SPEU copy as well?
SP copies.
And Mila, you were good to go through launch configuration?
Yes, sir.
All right, very good. And Launch Director, NTD?
Yes, sir.
We still do have 4 open constraints that are all paper at this time that are being worked by our engineering folks in the back of the room to get those off the constraints list.
Okay, so no worries, right?
No worries.
Thank you.
OTC, PLT, MPS helium reconfig complete.
Copy that. Thank you.
OTC, PD.
Ready, PD.
Like a kickoff for 1072.
You've got to go on 1072. FCP.
FCP copies. Copy and work. And NTDSP.
Go ahead.
Let's see, just to let you know, I did just talk to CMQC. All 4 of the constraints that are currently shown on the constraints list are with CMQC for closure. They're doing a final review, and I expect them to come off the constraints list momentarily.
Great, thank you.
All personnel discontinue all non-mandatory LDB traffic for the remainder of the count.
NTD Houston flight on 212.
Go ahead, flight.
VFS pre-flight uplink load is complete.
Copy, thank you. CVFS, you copy 1051?
VFS copies.
And for all personnel, we're going to hold at 9 in about 50 seconds or so.
And NTDSP's with you, sir.
Go ahead.
Oh, I thought you were looking for me.
No, sir.
This is shuttle launch control, T-minus 9 minutes, 23 seconds and counting. We're preparing now to enter the final built-in hold on the countdown. This is approximately a 45-minute built-in hold.
Pete and the folks are working on it momentarily, and CMQC is aware it's on its way to them.
Going into the hold now in 4, 3, 2, 1. T-minus 9 minutes, holding for 41 minutes and 10 seconds.
Duration of our hold will be 41 minutes and 13 seconds based on our window open time.
Right now we're going to go out to Mission Control in Houston. Rob Navius is our flight commentator for STS-135, and we'll go now to Rob to tell us what the status is of Mission Control in Houston and the readiness for launch today.
Thanks, George, and good day, everyone. This is Mission Control Houston at T-minus 9 minutes and holding. Here in the Space Shuttle Flight Control Room, flight controllers belonging to the Ascent team have been on console since 4:30 this morning, monitoring Atlantis' systems in preparation for its final flight into space and the first step in the final mission in Space Shuttle program history. 30 years and 3 months ago, it was Columbia on Launch Pad 39A awaiting liftoff on the first shuttle mission. The Ascent team that day was led by Flight Director Neil Hutchinson, whose call sign was Silver Flight. He was assisted that day by a young astronaut named Dan Brandenstein, who served as the spacecraft communicator, or Capcom. Brandenstein would later fly in space 4 times, 3 times as a shuttle commander. Today, weather permitting, Atlantis will display its power and spectacle one last time under the direction of Flight Director Richard Jones, whose call sign is Sigma Flight. Jones will be assisted by Capcom Barry Wilmore, who will be talking directly to the crew during Atlantis' 8.5-minute ride to orbit. Wilmore is joined on console by astronaut Lee Archambault, who is monitoring weather conditions at the Kennedy Space Center. Archambault is in direct contact with Deputy Chief Astronaut Rick Sturckow, who is flying the shuttle training aircraft around the vicinity of the shuttle landing strip at the Cape. Sturckow is assessing the weather in the event Atlantis has to perform a return to launch site abort. Jones has already polled his team for a go for launch from a systems perspective, as has the International Space Station Flight Control Team, led today by Flight Director Emily Nelson. At the time of Atlantis' launch, the International Space Station will be flying about 235 statute miles over the Pacific, east of Christchurch, New Zealand. Atlantis' launch is timed to match the moment when the Earth's rotation carries Launch Pad 39A into the corridor of the station's orbit. Shuttle flight controllers here in Houston are watching weather conditions at the overseas abort sites in Spain and France, which would be used in the event of an engine failure early in Atlantis' climb to orbit. Zaragoza, Spain is the prime transatlantic abort site today for Atlantis and its crew. The weather there is pristine. At launch, Atlantis will be sent aloft on the collective power of its 3 liquid fuel main engines and its twin solid rocket boosters, combining for a total of 7 million pounds of thrust. 30 seconds into the flight following its roll maneuver, the computers will throttle the main engines down to 72% of rated performance, designed to lessen aerodynamic forces on the shuttle's fuel tank and the orbiter's aero surfaces. The engines will throttle back up to 104% of capability 20 seconds later.
Go ahead, launch director.
Shortly after solid rocket booster separation, the orbital maneuvering system engines will ignite for 1 minute 23 seconds, providing an assist for the shuttle as it heads uphill. And a little less than 6 minutes into the flight, the onboard computers will command the main engines to swivel, allowing Atlantis to roll to a heads-up position above its fuel tank. That maneuver allows Atlantis to gain more favorable communications with the tracking and data relay satellite system. 8.5 minutes after launch, the main engines will be commanded to shut off, and the shuttle will separate from its fuel tank. Atlantis will settle into an elliptical orbit around 135 statute miles above the Earth at apogee, which will be refined to a higher elliptical orbit above the Earth about 37 minutes into the flight through a firing of the shuttle's orbital maneuvering system engines. Additional rendezvous maneuvers will be executed over the course of the next 2 days, bringing Atlantis to its final docking with the International Space Station on Sunday morning. Seconds after discarding the external fuel tank, Commander Chris Ferguson will execute a maneuver to place Atlantis in the correct orientation so that mission specialist Sandy Magnus can use digital cameras to capture high-resolution imagery of the tank as it drifts away. Because there are no crew members on the middeck for this launch, there will be no time for handheld video captured of the tank as it separates, only digital photos. Atlantis' 4 crew members will go to work shortly after the shuttle's payload bay doors are open, activating systems, unstowing gear, and preparing for their first 8-hour sleep period in orbit, which will begin around 7 p.m. Central Time. The sense of history, the legacy of what has occurred here over 3 decades, is palpable here in the shuttle flight control room as Jones and the ascent team stand by to take over control of the last journey of a space shuttle at solid rocket booster ignition. At T-minus 9 minutes in holding and with history in the offing, this is Mission Control Houston.
Houston flight NTD on 212.
NTD Houston flight on 212, go ahead.
Okay, any updates to our launch window and or lock stream back hold times today?
No updates.
All right, very good. Let's see, OTC, TBC, PTC, LPS, MILA, STM, Safety, SPE, LRD, SRO, CDR, and CGLS. We have our final launch window has been selected, and we are going with our preferred time, and that does move our launch window T0 time to 15:26:46 GMT, and that window will close at the same 15:31:19 GMT with a window length of 4 minutes and 33 seconds. Our lock stream back hold time is now 3 minutes and 16 seconds based on performance, and that will give us a T-minus 9 resume of 15:17:46. TLS copies. Thank you, GLS, and let's see, OTC, you copy?
OTC copies.
TBC?
TBC copies.
PTC?
PTC copies.
And LPS?
LPS copies.
MILA?
MILA copies.
STM?
STM copies.
Safety console?
Safe copies.
SPE?
SPE copies.
LRD?
LRD copies.
SRO?
SRO copies.
And CDR?
CDR copies.
Thank you all. And with that, CGLS, go ahead and set the countdown clock to resume at 15:17:46.
Yes, sir. 15:17:46. That's complete.
This is Shuttle Launch Control, T-minus 38 minutes, 43 seconds and counting. Right now, our weather conditions here at the Cape are observed go. So we hope we can maintain that now for about another 45 minutes.
Give us our camera support for launch on 1097.
We're going to look now at
Support
a video about the history of Space Shuttle Atlantis. It's a
long range south 8,
Atlantis
medium range north,
retro video
range south 6,
about Atlantis' storied career.
and short range R6. All right, then I have you.
Since first arriving at the Kennedy Space Center 25 years ago, Space Shuttle Atlantis has made the 4-mile trek from KSC's Vehicle Assembly Building to its oceanside launch pads more than 30 times. The fourth of NASA's 5 orbiters, Atlantis' career has not been lacking in firsts. Among them, the first shuttle to deploy a probe to another planet, the first shuttle to dock to a space station, and the first shuttle to fly with a glass cockpit. Atlantis has traveled more than 115 million miles in the pursuit of exploration. Its legacy enabled NASA and its international partners to accomplish some of the most complex work in human spaceflight history. Work that has yielded immeasurable benefits and allowed us to greatly advance the frontiers of knowledge.
This is Shuttle Launch Control, T-minus 36 minutes 15 seconds and counting. Once the external tank separates from Atlantis, 8 minutes and 30 seconds into the mission, it will be in an elliptical orbit of 136 statute miles by 36 statute miles. And then 45 minutes after launch, there will be a 2-minute burn of the orbital maneuvering system once again to raise and circularize the orbit to 141 statute miles by 98 statute miles. The orbit will then gradually be raised to 253 statute miles in order to rendezvous with the International Space Station. Should Atlantis need to turn around and come back, the primary abort once around location is the shuttle landing facility at the Kennedy Space Center, and there is an alternate backup site also available at White Sands in New Mexico. The primary end of mission site is here at the Kennedy Space Center at the shuttle landing facility, and the alternate is NASA's Dryden Flight Research Center at Edwards Air Force Base in California, as is customary. At T-minus 34 minutes, 50 seconds and counting, this is Shuttle Launch Control.
HGD.
What HGD?
I have some fill-in for step 935.
935, okay.
On page 1198, when you're ready.
Go ahead.
The op number is 80, run number is 1, and the log number is LCC4-062711-011.
Copy that, thank you.
This is Shuttle Launch Control, T-minus 31 minutes, 57 seconds and counting. Shuttle Weather Officer Kathy Winters has just advised Shuttle Launch Director Mike Leinbach that we are still currently observed go for launch. We're watching an area that is inland that we believe will be passing to the northwest by about 3 miles at launch time, so assuming there are no buildups associated with it, and the shuttle training aircraft will be watching that closely, we are cautiously optimistic that we will be go for a launch at 11:26. Right now out at the launch pad, the temperature is 81 degrees and it's 83 at the shuttle landing facility. At T-minus 31 minutes, 10 seconds and counting, this is Shuttle Launch Control.
CCME, OTC.
CCME.
Steps 1077, 1078.
Complete.
Did you do 1078?
1078 was not performed.
Not performed, thank you. CDPS, OTC.
DPS.
Step 1085, 1086. Were those not performed?
That's affirmed.
Okay, and 1087 is complete?
1087 is complete.
Thank you.
SRO on 212.
Go SRO.
Range is go for countdown resumption and the T0 of 1526.46. Range status is go for launch.
Excellent, thank you.
CGLS, OTC.
Yes, ma'am, go ahead.
Step 1095, 1096.
Stand by, please.
This is Shuttle Launch Control, T-minus 28 minutes, 50 seconds and counting. A pre-flight software check of the Space Shuttle's master events controller called a bike check has been completed. This main engine controller relays commands from the orbiter's computers to fire explosive charges to the solid rocket booster hold-down bolts at launch and to separate the tanks and the twin boosters in flight. It's a customary milestone that occurs at about T-minus 29 minutes. Eastern Range has just given a go to pick up the countdown at T-minus 9, so the range is green. Launch weather appears to be good. We'll be watching the return to launch site weather very closely. The Spaceflight Meteorology Group in Houston will be making the call on our RTLS weather, and if we were go to pick up the count at T-minus 9. But we do have some sunshine here now.
And we're going to be watching this area off to the northwest, but right now we're cautiously optimistic. And the post-launch inspection teams are being assembled right now at the roadblock located near the Launch Control Center.
OTC, CHCD.
HGD.
I can give you step 1142. Our confidence checks are complete.
Copy 1142.
And that post-launch inspection team will be going into the pad as soon as it's determined that the pad is safe for crew entry. And the closeout crew has been cleared from the launch pad. As we've seen, the white room is configured for launch. At T-minus 26 minutes, 37 seconds and counting, this is Shuttle Launch Control.
TVD, OTC.
TVD.
Are we going to have to do step 1123?
That'll be not performed today.
Not performed, thank you.
OTC, CPVD.
Good, PVD.
Okay, I can also give you step 1126, payload bay purge flow rate set for launch.
Copy that, thank you.
And NTD SPE.
Go SPE.
Did you have the CMQC here with us?
CMQC?
That's firm. CMQC's here.
Okay, Jeff. One last one on the constraints listed is for our LOX pump. The guys are struggling a little bit inside of IPRACA in order to get the dispositions and signatures in there. We are going to hand sign it back here, and then we will take that back to CMQC. And what I'd like to do is have CMQC remove that wad from the constraints list once it is delivered to him. Technically, we are okay to go fly, and then ought to be sufficient to get that last constraint removed from the constraints list.
Okay. CMQC, you copy and concur?
Copy and concur.
Okay. And also SPE, if we for some reason we can't get that dispo hand done, we can still do it over the net here if we need to.
Understood. But we just hand signed it, so it's on its way back to CMQC.
Okay. Excellent. Excellent. All right.
Okay. And I appreciate that, and thanks CMQC for your support as well.
Not a problem, sir.
This is shuttle launch control, T-minus 21 minutes, 24 seconds and counting, or correction, T-minus 9 minutes and holding with 21 minutes, 20 seconds remaining in this planned built-in hold. Continuing to count down toward picking up the countdown at T-minus 9 minutes. Right now we're looking at a little area of weather that's popped up over Merritt Island to the west. The larger area of precipitation to the northwest appears that it's going to be well biased by the time the launch is scheduled to go. However, the shuttle training aircraft with Rick Sturko is looking at that very closely to try to characterize exactly what it's doing and how stable it is and where it will be, as well as looking at this little small area that is over North Merritt Island that is gradually being characterized as something that could become a rain shower. And we want to see how safe that'll be. We have 18 minutes, 20 seconds remaining in this built-in hold at T-minus 9 minutes. Rick Sturko reports that the weather looks reasonably stable to him. He doesn't see any buildups. We're looking at an area off to the southwest that looks good. However, the Spaceflight Meteorology Group in Houston that's in charge of forecasting weather for return to launch site has a number of factors that they have to consider. A combination of cloud ceiling, any buildups, any rain showers, all of this have to be factored into the flight rules. And then they will be the ones that will give us a go to proceed at T-minus 9 minutes. And if we need to, and it looked like the weather is going in the right direction, but we're not quite there yet, we could even count down all the way to T-minus 5 minutes and see what the weather holds for return to launch site. So it's looking our way. We're not quite there yet, but we're still cautiously optimistic. At T-minus 9 minutes and holding, 17 minutes remaining in this planned built-in hold. This is shuttle launch control.
And attention all personnel, we have 16 minutes of hold time remaining here at T-minus 9 minutes. We're tracking no technical constraints, one paper item that we're looking to remove from our constraints list as we continue to watch our weather approaching our launch time. TLT, OTC, clear hardware, caution warning memory, and verify no unexpected errors. TLT, that's in work. OTC, TLT, clear caution. Hardware memory complete.
Copy that.
This is Shuttle Launch Control, T-minus 9 minutes and holding, 13 minutes 30 seconds remaining in this built-in hold. Joining us now is Pete Nikolenko. He is the Assistant Launch Director for today's countdown. And Mike, or rather Pete, I wonder if you could tell us, first of all, how does the vehicle look? And then tell us specifically what the weather is that we're looking at right now.
Sounds good, George, and good morning. The vehicle's really been performing exceptionally well. We've had a really clean countdown. A couple of very minor ground issues, but we've cleared those. And at this time, the crew's in, teams are ready, and then the vehicle, the pad, and all the teams are ready to go. We have been watching the weather, and we knew that weather was going to present a challenge for us today. We are increasing our optimism. Certainly, things look pretty good on the launch weather side. Certainly, we're looking and working with the Space Flight Meteorology Group and our ascent flight director and the flight control team, because we want to ensure that the weather for our return to launch site abort landing, just in the event if needed, is good enough to support for launch. So currently we're watching some clouds and at a 12,000 foot level that are potentially building and moving into our general area, and so we need to protect this period of time, not just to protect for the launch window, but also for about 25 minutes after launch in order to provide appropriate visibility in case we had to return to this KSC launch site.
So does that mean that the weather reconnaissance aircraft, the STA with Rick Sturko, is providing a lot of input to what he's actually seeing?
Absolutely. In fact, we're relying very heavily on the observed conditions of CJ in the shuttle training aircraft to see what, in fact, that they're really seeing up in the air, and confirming what the meteorologists are working and seeing from their data. So combined together, we get the forecasters as well as the observations, and conclude with the appropriate weather.
Well, Pete, thanks very much, and we'll let you go back to listening to those reports coming back from Rick Sturko. We've got 11 minutes and 18 seconds remaining in this built-in hold at T-minus 9 minutes. This is Shuttle Launch Control.
CMQC, OTC. Go ahead. Yeah, send somebody over to 145 standby with Op 38 for the recorder activation, please.
Somebody should be standing by, ma'am.
Thank you.
This is Shuttle Launch Control. 10 minutes remaining in this planned built-in hold at T-minus 9. Before we come out of the hold, we're going to be listening very carefully to our launch director, Mike Leinbach, and our NASA test director, Jeff Spaulding, because they will be strategizing based on what is being observed, what we want to do as far as, first of all, picking up the count, whether we will or should not, and then if we do we want to press down all the way through, or might we take advantage of an optional hold at T-minus 5 minutes. So we should begin. I think they may hold off a couple of minutes on doing some of their polls before they get give that go. But at any rate, we're going to be monitoring that, and you'll be able to hear what Mike Leinbach and Jeff Spaulding have to say about what the strategy will be and what the directions to the launch team are. At T-minus 9 minutes and holding, this is Shuttle Launch Control.
CISL, JRPS, and Houston Flight. Perform the L-15 recorder activation, ISL. ISL copy. JRPS. JRPS copies. And Houston Flight.
Houston Flight copies.
TLT, OTC. Panel R1, payload aux switch on.
That's a work.
And MS1 OTC.
MS1, go ahead.
Activate the V10 recorder.
And that's in work.
Paradox is on OTC.
Copy.
Somewhere. Board there. Yeah. We got a red light. Where's this there? Dot up here somewhere?
And attention all personnel, this is the NTD conducting the launch status check. Verify ready to resume count and go for launch. OTC.
OTC is go.
TBC.
Tank and booster go.
PTC.
PTC is go.
LPS.
LPS is go.
Houston flight.
Houston flight, if you pull me at the end, I would appreciate it. Stand by.
Yes, sir, we'll pull you later. Mila.
Milo's go.
STM.
STM is go.
Safety console.
Safety console is go.
SPE.
SP is go.
LRD.
LRD is go.
SRO.
SRO is go. You have a range clear to launch.
And CDR.
CDR is go.
And Launch Director NTD, our launch team is ready to proceed with the exception of Flight, who still needs a little bit more time to make his evaluations on RTLS weather.
I copy that. I'll do my poll at this time. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
Safety and Mission Assurance is go, Mike.
Thank you, Terry. Payload Launch Manager.
Hey, Mike, on behalf of the ISS Ground Processing Team, I want to say thanks to you and the shuttle team. It's been a great partnership, and we are go.
Thank you, Bill. Appreciate that. Range weather.
Launch weather has no constraints for launch.
Thank you, Kathy. Atlantis Flow Director.
On behalf of the Atlantis and KSC Shuttle Processing Team, we are go.
Thank you, Angie. Ops Manager.
See, Mike, wait to get final go from Flight here. Let's hear what he says, and we'll get back to you.
Copy that. Atlantis Launch Director, Air to Ground 1.
Atlantis, go.
Okay, Fergie, we're starting to feel pretty good down here on the ground about this one today. So on behalf of the greatest team in the world, good luck to you and your crew on the final flight of this true American icon. And so for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, and have a little fun up there.
Hey, thanks to you and your team, Mike. Until the very end, you all made it look easy. The shuttle's always going to be a reflection of what a great nation can do when it dares to be bold and commits to follow through. We're not ending the journey today, Mike. We're completing a chapter of a journey that will never end. You and the thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's light this fire one more time, Mike, and witness this great nation at its best. The crew of Atlantis is ready for launch.
Thank you, sir. We'll get you going here in a couple of minutes.
NTD, Houston flight on 212.
Go ahead, Flight.
For the record, I'm go.
NTD copies, and Launch Director, that is our entire launch team, we are ready to proceed at this time.
I copy that. Ops Manager. Ops Manager.
Launch Director, Ops Manager on 212.
Yes, sir.
So you discussed it with the MMT and the Flight Director. We're going to take a waiver to the RTLS forecast no-go based on the potential that there will be light precip if we ended up in an RTLS. They've looked at that. Chances of thunder showers are very low, and they believe that's an acceptable risk. We have plenty of energy. We only need one end of the runway on the RTLS. I think we got some sound rationale here to take that waiver on the RTLS forecast being no-go. So with that, we are clear, no working, no issues. You're go to launch.
Okay, thank you, Mike. Appreciate that. And Fergie, you heard those words, so we'll get you going here shortly. Good luck, guys.
Fantastic news. Thanks, Mike.
NTD, with that, you are clear to launch Atlantis.
I copy that, sir. Thank you. And for our entire test team, we have 1 minute and 15 seconds of hold time remaining here at T-minus 9 minutes before we will pick up the clock. And we do have a clear to pick up the clock at 9.
right, gentlemen, we're on.
NTD ISL. Go ISL. Order activation complete. Copy, thank you.
Hopefully this thing won't come off. I think I got it in there pretty good. Yeah, what happened? I don't know.
His book came over the top of his head.
Yeah, it just kind of de-velcroed.
This is shuttle launch control, T-minus 9 minutes and holding with 30 seconds remaining in this plane built in hold.
Yeah, hold on. Yeah. Got some time. Yep. You would need to open the page so you can see that you're placed accurately right over
We'll pick up the countdown in 15 seconds.
And then get the... Let's try to get this...
Picking up in 10 seconds.
Come on your face. Oh, much better. There you go. Now you're sticking on this
The
Velcro.
countdown clock will resume on my mark. 3, 2, 1, mark.
T-minus 9 minutes and counting.
DLS auto sequence has been initiated.
Ground launch sequencer will be checking over 1,000 parameters between now and when it hands off to Atlantis' onboard computers at T-minus 31 seconds.
I agree. And it's these three.
And from 31 seconds on, Atlantis' onboard computers will be completely in control of the countdown and for main engine start. And it will assess in the last 6.6 seconds whether the engines are up to full thrust.
Yeah, you can. That's ready for the electrics, and then you can set
TLT, OTC, connect essential buses to fuel cells per your checklist.
TLT and work. I see him. OTC, TLT, that's complete.
Copy.
In about 20 seconds, we'll be retracting the crew orbiter access arm.
Awesome job, you know. Hey, I'm really proud of every one of you.
Yeah, let's go for orbiter access arm retract.
Atlantis, this is OTC. This day has been over 30 years in the making. There have been many fabulous missions throughout the years. On behalf of KSC launch teams, past and present, we salute the entire astronaut corps for their dedication, not only for our expanded knowledge of the universe, but for the improvement you have contributed to on Earth. Have an excellent mission and Godspeed.
Fantastic words, Roberta. Thank you very much. Great to your team. Thank you, sir.
It's orbiter test conductor Roberta Wyrick from United Space Alliance. At T-minus 5 minutes, the pilot will be instructed to start the orbiter auxiliary power units.
JRPS OTC, start APU display recorders.
This JRPS recorders are running.
TLT OTC, perform APU pre-start.
Pre-start work. Three great talkbacks. OTC, TLT, three great talkbacks.
Copy, three great talkbacks.
They sound like burp switches. They are nice. Looks good, folks. The weather looks great.
Coming up on T-minus 5 minutes in 3, 2, 2, 1, T-minus 5 minutes and counting.
Go for orbiter APU start.
TLT, OTC, perform APU start. CDR, OTC, reconfigure heaters.
That's in work.
Solid rocket booster safe and arm devices are now being armed.
There we go. Lights out.
OTC, TLT, 3 good APUs.
Copy, 3 good APUs.
All right, Fergie, we can, I can probably hook you up from here. That's all.
Next milestone is a check of the orbiter's flight controls.
TLS is go for purge sequence 4.
I don't think I ever noticed that before. There's an auto check. Yeah, feel them. That's cool.
And there will be a steering check of Atlantis' 3 main engines.
This is not.
Spec 99.
Verifying now that the main engines are in their start position.
TLS is go for ET LO2 pressurization.
Starting now the retraction of the gaseous oxygen vent arm, vent hood.
Nothing on there to clear. I know.
TLT, OTC, clear caution warning memory. Verify no unexpected errors.
Good 99.
Fuel cells going to internal. External tank camera being activated at this time.
Yep.
OTC, TLT, no unexpected errors.
Copy that.
There goes a meeting.
Copy that. Flight crew, OTC, close and lock your visors and initiate O2 flow.
That's in work.
All right, you know the drill.
T-minus 2 minutes.
All right.
TLS is go for ET LH2 pressurization.
Solid rocket booster camera is being activated. T-minus
1 minute, 30 seconds. All right. That's good.
Sound suppression water system is being armed. T-minus 1 minute.
1 minute.
But oxygen and liquid hydrogen fill and drain valves are closed. T-minus 40 seconds, handing off to Atlantis' computers at T-minus 31. T-minus 35, 33.
Clock will hold at T-minus 31 seconds due to a failure.
And we have had a failure.
I do.
Grad light
We're holding
sequencer.
at 31.
We have a problem on the GOX retract switches.
The run set is holding.
And NTDSP. Go ahead. So we need to
Eco.
do the
For an SPC flight. Okay. GC, go ahead and make sure that we have a good clock coming.
SCMAC, the LTC says we need to verify using a camera, and we're positioning camera 62 right now.
Okay, let us know as soon as 62 is swung over and you can verify LCC for GVA retract, please.
And all personnel, we're holding here 31 seconds while we get a verification that the GVA has fully retracted for our pre-plan.
This is CMAC. We verify retracted.
Okay, and you can verify that it is fully retracted per the instructions that we've been that we developed, correct?
That's correct.
All right, and SPE?
And NTD, SPE concurs. They satisfy the requirements of GSE 13 pre-plan contingency. I am go.
Okay, I copy. And launch director?
Yes, sir. I heard all that and concur. Press on.
All right, very good.
NTD, SPE?
Yes, sir.
Yes, sir. I need concurrence to GLS and mass to clear the hold, please.
Very good. And GLS, you have concurrence? Go.
Copy that. It's in work.
Thank you. Let us know when that's complete.
NTD, we have it in work.
All right, guidance.
And just a reminder for folks, our lock turn back hold time is 3 minutes and 16 seconds.
NTD, CTLS on 212, we're ready to go.
All right, very good. And launch director, with that cleanup, we're going to go ahead and proceed.
Yes, sir. Please do.
All right, and all personnel, we are going to pick up the clock here momentarily. And GLS, you can resume the clock on your mark.
Copy that. Countdown clock will resume on my mark. 3, 2, 1, mark.
E-minus
Go for auto sequence start.
handoff to Atlantis' computers has occurred. Solid rocket booster nozzle steering check in work.
20.
Firing chain is armed.
15.
Go for main engine start.
All vents open.
T-minus 10, 9, 8, 7, 6.
The start, now I see it.
Up and burning.
T at 100.
0 and lift off.
We are in auto. There goes the power.
On the shoulders of the space shuttle, America will continue the dream.
Program, Houston.
Roger roll, Atlantis.
Houston now controlling the side of Atlantis.
I agree.
Space Shuttle spreads its wings one final time for the start of a sentimental journey into history.
Digitals.
24 seconds into the flight, roll program complete. Atlantis now heads down, wings level on the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station.
15,000 coming up in the cloud deck. There's the throttling.
40 seconds into the flight, the 3 liquid fuel main engines throttling back to 72% of rated performance in the bucket, reducing stress on the shuttle as it goes transonic for the final time. Engines now revving up, standing by for the throttle up call.
Throttle up. What do you see there, Rex? 3 at 104.
DT is about 0.8 to 0.07.
In the positive or negative direction?
Negative.
Atlantis, go at throttle up, no action, DT.
Go with throttle up, no action on
It's probably getting bad and stretch.
That call from Capcom Barry Wilmore, a transducer, instrumentation only, no action required.
90 seconds.
Atlantis now 15 miles in altitude, already 16 miles downrange from the Kennedy Space Center, 1 minute 40 seconds into the flight. Atlantis flexing its muscles one final time.
Heads up, Joe.
Atlantis traveling almost 2,600 miles an hour, 21 miles in altitude, 24 miles downrange, standing by for solid rocket booster separation.
Stand by.
DC less than 50. Awesome.
All right, close your shoes to open your visor.
Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. The main engine steering the shuttle on a pinpoint path to its preliminary orbit. 2 minutes, 20 seconds into the flight. Atlantis already traveling 3,200 miles an hour, 35 miles in altitude, 50 miles downrange.
Bid pressures.
The propulsion officer reports the orbital maneuvering system engines have ignited. Atlantis kicking on its afterburners for 1 minute, 23 seconds for the final phase of powered flight.
coming down.
Atlantis, 2-engine TOW.
2-engine TOW.
That call from Capcom.
Single pane day, so in the event of contingency, you're in plane plus 230 on the ecal page. No comm VIs when you're ready to copy.
Okay, in plane plus 230, go ahead.
Press to ATO, 10.8. Press to MECO, 14.7.
Press to ATO, 10.8. Press to MECO, 14.7.
That's a good readback, Atlantis.
Because of the slightly late launch time, Capcom Barry Wilmore reading up to pilot Doug Hurley the updated abort boundaries for Atlantis, which is flying on the singular power of its 3 liquid fuel main engines, draining 1/2 ton of fuel per second from the shuttle's large fuel tank. 3.5 minutes into the flight, Atlantis traveling 4,200 miles an hour, 54 miles in altitude, already 120 miles downrange from the Kennedy Space Center. 3 good main engines, 3 good auxiliary power units, 3 good fuel cells for Atlantis.
It's nice up here at 300,000 feet.
Atlantis, negative return.
Negative return.
That call from Capcom Barry Wilmore indicating that we're too high in altitude, too far downrange to return to the launch site in the event of an engine failure. However, Atlantis' 3 engines performing perfectly. 4 minutes, 20 seconds into the flight.
Now press the ATOs next. Copy.
Atlantis currently traveling 5,500 miles an hour, 62 miles in altitude, almost 200 miles downrange. 4 minutes of powered flight remaining.
I'm looking forward to this story.
Atlantis speeding straight as an arrow toward its date with the International Space Station Sunday morning.
I don't remember liftoff being quite that violent. I do.
Yeah, I do too. Yeah.
Coming up on the 5-minute mark. Atlantis now traveling 6,500 miles an hour, 66 miles in altitude, 250 miles downrange.
Atlantis, press to ATO.
Press to ATO.
That call indicating we can make minimal orbital targets in the event of an engine failure. All 3 engines continue to function normally. Atlantis will begin its slow roll to a heads-up position shortly. Five and a half minutes into the flight. Atlantis traveling 7,700 miles an hour, 315 miles downrange.
So I can't lift my head.
Atlantis, single engine, ops 3.
Single engine ops 3.
There's a roll.
And the guidance officer here in Mission Control confirms that the computers are commanding the main engines to swivel.
Zaragoza, 104.
Single engine Zaragoza 104.
We've rolled to a heads-up position now, providing better communications to the tracking and data relay satellite system as Atlantis heads uphill.
Wow.
6 minutes, 20 seconds into the flight.
2.1.
Atlantis, press to MECO.
Nominal shutdown.
Press to MECO.
That call indicates that we can make our normal orbital cutoff targets in the event of an engine failure. However, all 3 main engines continue to function normally.
Nominal. Fergie, go the plus X, go the pitch.
We got it.
Nominal shutdown plan. Go for the plus X, go for the pitch.
All right, Sandy, all ready?
Yeah.
That call indicating that we will be in good shape for the orientation of Atlantis for external tank photography following main engine cutoff. Now 7 minutes into the flight.
How many switches you think you'd be throwing now? 0. Coming up on throttling. I agree.
1 minute, 20 seconds till main engine cutoff. Atlantis traveling 12,000 miles an hour. The main engines will soon be throttling down once again to limit the stress on the shuttle and its 4 crew members to that of 3 times the effective gravity. Atlantis currently traveling at a speed of more than 4 miles a second. 1 minute of powered flight remaining for Atlantis. Three good main engines, 3 good auxiliary power units, 3 good fuel cells. Approaching the 8-minute mark into the flight. Atlantis now traveling more than 15,000 miles an hour. Eight minutes, 15 seconds into the flight, standing by for main engine cutoff.
Stand by.
That'll be followed a few seconds later by the separation of the external fuel tank.
Miko. That was a Miko.
Miko. Booster officer confirmed main engine cutoff. For the last time, the Space Shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation.
That's the tank. Wait for 104. There's 104. I see an HA grader.
Atlantis off the tank.
Data. There we go.
Commander Chris Ferguson will be maneuvering Atlantis now into an orientation to enable Sandy Magnus to capture digital still imagery of the external fuel tank as it drifts away.
OHMS 1 is not required. Your preliminary OHMS 2 TIG, 37 minutes.
37 minutes, no OHMS 1 required, thanks.
All right, everybody, we're out of the book. Sandy, you're unstrapping.
I'm working on it.
Trust OHMS 1. I agree. It's a lot easier at 3Gs. Welcome to space, everyone.
Yeah.
Good to be back.
Yeah, I'm gonna. Oh, I can't go off comm while I talk to you. Do you hear me?
Go ahead, I'll yell at you.
I'm gonna go off comm.
Now, ready for ref? Ready for ref. Here's ref. I'm there. Okay. All right. Body flap light is on. Double started. All right, we're waiting for OHMS 1 tick plus 30 seconds. So that's 45 seconds from now. Sandy, you're doing real good time-wise. Everybody feeling all right? Yeah, not bad. Okay.
Okay, I'm getting the water out.
Yeah. It's going to be a minute. I got to get my gloves on. We'll get a stable config here. All right. Here's inertial. Here's pitch to pulse. All right, we're starting to pitch, Sandy. We are pitching. Okay. This is your call. Let me know. All right. You got a ways to go. Probably about 60 degrees. No, you do what you need to do. Do what you need to do. About 45 degrees to go. All right. Just tell me when to stop. There's pitch discrete rate. Should be coming to a stop, and we are.
That's okay, you're fine.
Danny, take your time. Take your time.
What's that?
Waiting for the dump to complete chunky, that's next. I'm watching that, Fergie. Take my clothes off. I'm going to take flight control power off. You can do the same. All right.
Hand me your gloves, Chunky. I'll put them back here.
Flight control power's off, Fergie. Great. Back has gone to auto.
Okay.
I see the body flap light out. It's out. Good. Tab has gone to auto. We're ready on height MPS TVC ISOs. You want me to give him a call for you? I got it. Houston, Atlantis, you ready for MPS TVC ISOs?
That's affirmative, Chunky. We are ready.
Here you go, Rexy.
I've got it.
Great news. At 13 minutes. Wow, that's wonderful.
Chunky, also, after you get those closed, we'll be ready for APU height shutdown. On 3-4, the only delta is tell-only control is not required. And when you get ready for Ops 105, we are ready as well.
We got the APU height shutdown, no deltas on 3-4, except tail-only control not required, and we're ready for 105. There you go.
That's a good readback.
Okay, you guys ready to get you got the flight control powers off yet?
Yep, they're done. Okay, great. ISO valves are done, guys. I'm going to work on APU height shutdown. Okay, here you go.
I can read them to you if you want.
Yeah, go ahead if you don't mind.
Okay, check APU auto shutdown. 3 switches are enabled.
That's good.
Okay, take boiler power. 3 switches to off.
Okay.
Okay, take boiler N2 supply. 3 switches to off.
That's sweet.
Okay, take APU operate. 1, 2, and 3 at 5-second intervals to off. Expect master alarm.
Okay, I agree. 5 seconds. All right, Sandy, everything all right? Can we help you with anything? All right, great news. Expected. Got him for you. Thank you. Here come the fuel tank valves, Rexy.
Okay, fuel tank valves. 3 switches to off to close.
You're in manual focus, right?
I see 3 high pressures are 0.
I agree.
Controller power, 3 up to off.
Alright, just do your best. You can only do what you can do. There, no, Rexy, I'm complete.
Okay, you got the main pump pressed in norm?
They never came out of it.
Yep, that's right, just check.
Hey, Rex, I'm on the 3-4.
Okay, what step
I'm with you guys. Best pry A is on. Line heater. 2 switches are in 1. A12 steps, Rex.
Okay, 12 steps. I'm gonna have to unstrap a little bit.
Okay.
Chunky, you want some water? I got it whenever you need it.
Ready, as soon as I get the bus sensors. Rex, here's Ops 105.
I see 105.
Alright, hold on home targets. Chunky, if you're ready, you got the comm, I'll go off helmet. I'm ready for that, Fergie. I'm holding on 3-5. That the works.
Hey, Chunky, Ferg, you want to read me those steps for the A12 just so I make sure I get them?
Chunky's, can you hold on? Yep, I got it. Alright, A12, it's the APU, heater, tank, fuel line, water system, 1 alpha, 2 alpha, and 3 alpha. That's 3 switches going to auto.
They're complete.
Alright, this camera's still running, guys, so if you want to run it around. Get them all, Rexy?
What's that? Yeah, I got
Atlantis, we see your onboard TIG of 37:45. We like that, and no deltas to 3-6 or 3-7.
Okay, we copy. No deltas to 3-6 or 3-7. We'll put 3-5 and subsequent in work.
Thanks, Atlantis. We're watching.
And Fergie, you can do a 22 and a 23, and then we'll check the BFS targets.
And Chuck, if you don't, I've got a scope deck still tied to there if you want to use that one.
Yeah, that's good. I'll get this one.
I see Adam 22, Fergie. And Chunky, you got your R1, O2, and H2 tank heaters, right?
You betcha.
Okay, great.
Thanks, brother.
And just double checking. Where I got those already. Yep. Hang on one second, let me get the water over.
And Houston, Atlantis, here comes MPS ISIL.
Sandy, I'm gonna toss the helmets, just float them down gradually downstairs. Actually, I can, until we get to the ohms too, I'll,
That's expected. I think I said that once, but it surprised me too. That's the helium missiles. Expect multiple alarms, healing pressures as the rigs breathe down. You can see them bleeding down.
Not worth it anymore. How do you hear?
Loud and clear.
Very good.
Yeah. Watch. Okay, Fergie, I'm done up to MPS power down. If you want to just keep me honest, I'm going to take my helmet off. All right.
Ow, sorry.
Hey Houston, just to tag up with you, we show ourselves complete through the MPS power down, just waiting on your go when the time comes.
Yeah.
Okay, we are ready for MPS power down when on time, and if you could check the MPS pneumatic helium ISO at the GPC, that should get them.
Okay, pneumatic helium ISO to GPC, thanks for the check.
I'm feeling pretty good. Okay, Chunky, I can carry that. Hold it for you. I got it. You want to hand me your gloves? Let me see. This is wrapped around you probably. That's the way you want to be, yep. under the hair. No problem. Take your time. I can't hear you. Yeah.
Rock check.
Put your helmet bag back here unless you want to hand me your gloves. Oh, that's right. They're back here. I'm sorry. I will. Got it.
Houston, Atlantis, MPS power down is complete, and with that, we would like to thank the Pratt & Whitney Rocketdyne team and the SSME team for their flawless performance over this 30-year shuttle flight history. 135 flights. It's a 7,000-pound engine that puts out 1.5 million pounds of thrust, and they pitch the equivalent of a perfect game every flight. From everyone who's ridden on these rockets, we thank you.
We concur with that assessment, Atlantis. Good and pertinent and true words.
We're putting ET umbilical door closure in work, Butch.
Mechanical Systems Officer here in Mission Control watching over the closing of the external tank umbilical doors. Words of compliment from pilot Doug Hurley for all of the propulsion system engineers who presided over 135 flights of the Space Shuttle, and the performance of Space Shuttle main engines, the external fuel tank, the solid rocket boosters that propelled these vehicles, and hundreds of humans to orbit. The external tank umbilical doors now closed and latched, confirmed by the mechanical systems officer here in Mission Control. Atlantis soon to maneuver into the correct orientation for the firing of the orbital maneuvering system engines about 9 minutes from now, the OMS 2 burn that will help to refine Atlantis's altitude as it now begins its trek to catch up to and dock with the International Space Station on Sunday.
Hey, Houston, we're ready for the maneuver if you are.
Affirmative, Atlantis, we are ready.
Atlantis now beginning to maneuver into the correct orientation for the firing of the orbital maneuvering system engines 7.5 minutes from now. This will be a firing of both orbital maneuvering system engines at the rear of the shuttle that flank the vertical tail fin. The firing of this OMS 2 burn, as it is called, about 1 minute 4 seconds in duration. This is Mission Control Houston, less than 2 minutes away from the orbital maneuvering system burn to increase Atlantis' altitude. This will be a 1 minute 4 second firing of both orbital maneuvering system engines. The guidance, navigation, and control officer reports Atlantis is in a good configuration for the burn, as does the propulsion officer here in Mission Control.
Hey, Houston, we think we're in a good config for the burn.
That's affirmative, Atlantis. We show you in a good config for the OMS 2 burn.
Standing by for the firing of the orbital maneuvering system engines. And the propulsion officer reports that the OMS 2 burn is underway.
We see a good burn, Atlantis. No further trim is required. We'll meet you in the post-OMS 2 tab.
Copy and concur. Thanks, Houston.
And as we watch the replay of Atlantis separating from its external fuel tank following its launch almost 40 minutes ago, the confirmation from Capcom Barry Wilmore here in Mission Control to Commander Chris Ferguson that we've had a good firing of the orbital maneuvering system engines, the OMS 2 burn helping to refine Atlantis' altitude as it begins its trek on the road for its 2-day chase to catch up to the International Space Station. Atlantis now at an altitude of 143 by 98 statute miles.
Here comes the gimbal check, Houston.
We are watching. And Chunky, no deltas to your post-burn reconfig.
Copy, no delta.
This is Mission Control Houston, now back here at the Johnson Space Center. The ascent team of flight controllers on duty, led by Flight Director Richard Jones, along with spacecraft communicator Barry Wilmore, following the launch of Atlantis 42 minutes ago, following a very, very slight delay while the ground launch sequencer at the Kennedy Space Center verified that the gaseous vent arm, the beanie cap, if you will, was fully retracted from the top of the orbiter's external fuel tank. With the launch having been completed, the first major maneuver of the flight, the OMS 2 burn of the orbital maneuvering system engines, has just been accomplished. Atlantis now flying at an altitude of 143 by 97 statute miles in pursuit of the International Space Station, flying from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator.
On 5-3 if you're ready.
Affirmative, we are ready for 106, Fergie.
Houston, contact from the mid-deck. How do you copy?
Sandy, we have you loud and clear. How us?
Very good. I have you loud and clear as well.
Yeah, it's good talking to you, Sandy.
Mission Specialist Sandy Magnus now out of her seat on the flight deck, having made her way down to the mid-deck to begin the preliminary configuration of the systems down there. In the meantime, Rex Walheim will be working to begin the configuration of the aft flight deck hardware. Commander Chris Ferguson and pilot Doug Hurley will be checking out the shuttle's robotic arm, unfurling it from the port sill of the shuttle's payload bay at about the 6.5-hour mark into the mission, performing a checkout of its systems before it is used tomorrow to grapple the orbiter boom sensor system for the initial inspection of Atlantis' thermal protection system.
Hey, Houston, we show ourselves complete with the ascent checklist. If you agree, we'll meet you in post-insertion.
We do agree with that, Atlantis. And while I got you, Fergie, if you'd like to set up a timer for your NC1 TIG, it's at 3:39.
3 hours, 39 minutes. We appreciate that. Thanks.
You bet.
Here in the Space Shuttle Flight Control Room, the ascent team looking over the shoulders of Atlantis' quartet as they begin to set up shop for at least a dozen days of on-orbit operations. For those keeping track, the exact liftoff time for Atlantis on its final mission was 10:29 and 3.9 seconds Central Time, 10:29 and 3.9 seconds Central Time today. Just about 2 minutes and change behind schedule, while the Kennedy Space Center held the countdown clock at the T-minus 31-second mark, just before the ground launch sequencer would do the handoff to the shuttle's onboard computers to verify the full retraction of the beanie cap, or the gaseous vent arm, that is located at the top of the shuttle's external fuel tank.
Hey, Houston, we're ready for Block 1. Any deltas?
Good question, Fergie. There are no deltas. As you recall, though, we will be going single G2.
Absolutely. Single G2, no deltas, and here we go.
We are watching.
Houston, it's step 1. If you like the INBAT, we'll give you the Ops 106.
Yes, we do like your INBAT, Atlantis.
And as Atlantis' 4 astronauts continue to set up shop, configuring their data processing system for on-orbit operations that will set the stage for the opening of the payload bay doors about 35 minutes from now. Atlantis is currently flying over the southern Indian Ocean, about to swing south of the continent of Australia and back out over the Pacific Ocean. While most of the activity was centered around the launch of Atlantis in the shuttle flight control room down the hall from here in the International Space Station flight control room, the team of flight controllers on console watching over the activities of the Expedition 28 crew, led today by Flight Director Emily Nelson, on the right of your screen. Robert Hanley is the spacecraft communicator talking directly to the half-dozen crew members on board the station. They were watching the launch on a television feed uplinked to them as they watched Atlantis begin its journey to link up to the International Space Station for the final time on Sunday morning at the outset of the delivery of some 4 tons of equipment and supplies that will fortify the station over the next 12 months. Of course, the station is led by Commander Andrei Batasenko, along with Russian crewmates Alexander Samakutyaev and Sergei Volkov, Satoshi Furukawa from the Japan Aerospace Exploration Agency, and NASA astronauts Ron Garan and Mike Fossum.
Block 3 in work, Houston.
With you in Block 3, Atlantis.
Hey, Houston, in Step 4, if you like the MBAT, we've double-checked it. We like it. We're ready for Ops 201.
We do like the NBAT and are ready for Ops 201.
This is Mission Control Houston, almost 1 hour into Atlantis' final flight. The 4 crew members setting up all of their equipment, setting up their data processing system as they convert the onboard software from the ascent load to the on-orbit load. About 30 minutes or so from now, 35 minutes perhaps, we'll get into the time frame for the opening of the payload bay doors and the activation of the radiators to take over from the flash evaporator system that was initiated about 5 minutes or so into the flight to provide cooling for the shuttle's electronics and avionics. The flash evaporator system provides temporary cooling during ascent and entry. Otherwise, the radiators dissipate heat once the payload bay doors are open and the radiators are deployed. Following its launch at 10:29 Central Time this morning, Atlantis settled into its preliminary orbit. That was followed about 30 or so minutes later by the firing of the orbital maneuvering system engines in the first altitude adjustment burn, essentially to raise the apogee of Atlantis' orbit as it began its 2-day trek to catch up to and dock with the International Space Station for the start of almost 8 days of joint docked operations with the 6 crew members on board the orbital outpost.
Hey, Houston, Block 1, Step 6, we double-checked that NBAT as well. We're ready for SM Ops 201.
Ready for that, Atlantis. Thanks for the heads up.
One programming note, At noon Central Time, 1 p.m. Eastern Time, we'll be going back down to the Kennedy Space Center for the post-launch news conference. The participants will be NASA Associate Administrator for Space Operations Bill Gerstenmaier, Bob Cabana, the Director of the Kennedy Space Center, Mike Moses, who's the Space Shuttle Program Launch Integration Manager and Chairman of the Pre-Mission Mission Management Team, and the Shuttle Launch Director, Mike Leinbach. Again, the post-launch news conference is targeted for noon Central Time, 1 p.m. Eastern Time from the Kennedy Space Center, and we'll be going back down there for that. That should be close to the time frame that we'll be initiating the opening of the payload bay doors, but we'll keep you posted on mission audio once NASA television has gone back down to the Kennedy Space Center. Everything going very smoothly, the crew working ahead of schedule in its post-insertion timeline, beginning to set up all of the systems that it will use aboard the orbiter for the next 12 days.
Houston, Block 2 complete.
Block 2 complete. Thank you.
Houston, step 10, ready for the LOG resets.
Affirmative, we will take that, Atlantis.
Here in the flight control room, standing is Paul Hill, the Director of Mission Operations here at the Johnson Space Center, talking with the ground controllers who basically take care of all of the building's functions, anything from air conditioning to the computer systems to the scheduling of time on the tracking and data relay satellite system. He has been going around the room congratulating the flight control team here, as I'm suspecting he will over the course of the next 12 days or so. From time to time with all the shifts in both the shuttle and station flight control rooms as the shuttle program enters its final 2 weeks of a 30-year program. Once again, we'll be switching to the Kennedy Space Center at the top of the hour for the post-launch news conference targeted for noon Central Time, 1 p.m. Eastern Time.
I think we're done with Block 1.
Copy, we agree. Done with Block 1.
While the crew of Atlantis continues to configure its spaceship for on-orbit operations and the opening of the payload bay doors a short time from now, that post-launch news conference coming up at the top of the hour from the Kennedy Space Center will feature Bill Gerstenmaier, the NASA Associate Administrator for Space Operations, Bob Cabana, the Director of the Kennedy Space Center, Mike Moses, the Space Shuttle Program Launch Integration Manager, and Mike Leinbach, the Shuttle Launch Director. Again, the post-launch news conference coming up at the top of the hour at noon Central Time, 1 p.m. Eastern Time. Atlantis launched from Launch Pad 39A in the final launch in Space Shuttle program history 1 hour, 10 minutes ago, flawlessly reaching orbit, conducting an orbital maneuvering system burn about 37 minutes into the flight to increase its altitude. The shuttle currently flying at an altitude of 141 by 97 statute miles over the South Pacific, about to begin a southwest to northeasterly trek that will carry it across the equator and the beginning of the second orbit of the mission. Once the payload bay doors are open and the mechanical systems officer confirms that has been completed, the crew will wait for a go for on-orbit operations.
The attitude we loaded, we'll give you the maneuver.
Ready for the maneuver.
The maneuver reported by Commander Chris Ferguson and acknowledged by Capcom Barry Wilmore on the left here in the shuttle flight control room is the maneuver to the payload bay door opening attitude. The payload bay doors will be opened. The radiators will be deployed to provide cooling for the orbiter's avionics and electronics until they are closed on landing day. Again, Flight Director Richard Jones will first go around the room to get a go for payload bay door opening. Once Once the doors are open, then he will take a poll of the ascent team of flight controllers to get a go for on-orbit operations, after which the crew will be out of its post-insertion checklist and into the timeline that will see Chris Ferguson and Rex Walheim set up a variety of laptop computers on the orbiter before Ferguson and Hurley begin to work from the aft flight deck of Atlantis to activate, unfurl, and check out the shuttle's robotic arm, maneuvering it from its sill on the port side of the payload bay in advance of the grappling of the orbiter boom sensor system tomorrow on flight day 2, and the checkout and inspection of the thermal protection system, starting with the starboard wing of Atlantis, to make sure that the reinforced carbon-carbon did not suffer any damage during Atlantis' climb uphill. The orbiter boom sensor system, using a variety of laser cameras and sensors, will inspect the orbiter's nose and then move over to the port wing. All of that data, coupled with the ascent imagery and the rendezvous pitch maneuver that Atlantis will do during its final approach for docking on Sunday to the International Space Station, will be analyzed by the debris analysis team here at the Johnson Space Center as they begin the process of incrementally clearing the shuttle for its final entry back to Earth and a landing at least 12 days from now.
We copy.
And Flight Director Richard Jones now polling his team to get a go for payload bay door opening.
Atlantis, you are go for payload bay door opening.
Awesome news, Houston. Thanks. Go for payload bay doors. Hey, Houston, how long to Estill?
Yeah, just shy of 16 minutes.
Great news, thanks.
This is Mission Control Houston, with approval having been given to the crew of Atlantis to open the payload bay doors. Commander Chris Ferguson querying the flight control team about how long it will take.
Atlantis, we assured that you probably know this, but just to make sure we're tagged up, you will be auto mode on the payload bay door opening.
Auto mode on the doors, thank you.
The reference to how much time until Estill refers to an FM ground station that is located here at the Johnson Space Center, through which some downlink TV may be available. Typically, about one orbit into the flight, we will get a couple of minutes of television around the time of payload bay door opening, so we'll see how that goes. The payload bay doors will be operated for their opening by Mission Specialist Rex Walheim, backed up by Commander Chris Ferguson.
Hey, ECF sync config.
That is affirmative, Atlantis.
Copy.
One of the other big ticket items for Atlantis' crew will be the deployment of the dish-shaped KU band antenna over the starboard forward sill of the payload bay.
If we missed anything?
Okay, we'll take a look.
Chris Ferguson asking Capcom Barry Wilmore to make sure that the team here is looking over their shoulders to make sure they don't miss anything in the post-insertion checklist. Again, the KU band antenna will be deployed soon. Once the payload bay doors are open, that will enable a high data rate telemetry and downlink television capability from the shuttle.
Atlantis Block 3 does look good to us. Nice work.
The electrical systems officer here in Mission Control reports that the crew has begun the process of turning on the lights in the payload bay. That in advance of the operation of the systems by Rex Walheim and Chris Ferguson to actually open the doors, deploy the radiators, and setting the stage for a go for on-orbit operations. Atlantis crossing the Pacific at an altitude of 143 by 97 statute miles. Soon to cross the equator, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator.
Block 5 complete, Houston.
We copy. Block 5 complete. Thanks for keeping us tied in.
And Block 4's in work.
4 in work.
Hey, we'll plan to go open on the doors at, let me see, an MET of about 131. Does that sound about right, Houston?
That's affirmative. 131 will be right at the beginning of the Estel window.
This is Mission Control Houston. The crew aboard Atlantis is preparing to open the payload bay doors and deploy the radiators on the orbiter to provide cooling for the shuttle's avionics and electronics for the duration of the mission until entry day. We're expecting to receive some downlink television as the crew begins that procedure about 5 minutes from now. So thanks to the Kennedy Space Center, they'll be delaying the start of their post-launch news conference by just 10 minutes. That will start now at around 12:10 p.m. Central Time, 1:10 p.m. Eastern Time. Bill Gerstenmaier, NASA's Associate Administrator for Space Operations out of NASA headquarters, Bob Cabana, the Director of the Kennedy Space Center, Mike Moses, the Space Shuttle Launch Integration Manager, and Mike Leinbach, the Shuttle Launch Director, will be the participants in the news conference at the Kennedy Space Center, which now will begin at about 12:10 p.m. Central Time, allowing us to bring to you the at least the beginning of the payload bay door opening aboard Atlantis.
Hey, Houston, Block 6 is complete, and we'll pick up with the open command for the doors about 31 minutes after.
Okay, we copy Block 6, and we'll be standing by for the doors. Atlantis, I do have a switch throw in R11 when you got somebody there, R11 lower.
Go ahead.
Supply water galley supply valve to open, talk back open.
Complete.
Thank you very much.
And the Mechanical Systems Officer reports here in Mission Control that the latches are beginning to disengage for the opening of the payload bay doors. We're expecting and hoping for some television through the FM ground station here at the Johnson Space Center of that operation. Again, payload bay door opening in work. Waiting to lock up on this ground station that is called Estel here.
Great view on Estel, Atlantis.
I love it when a plan comes together.
Amen.
The doors in the process of swinging open. The starboard door, as you can see, is already open. The port door to follow. You're looking right down at the front end of the Raffaello multipurpose logistics module, carrying some 8,000 pounds of logistics supplies to fortify the International Space Station for the next year. On the far right, nestled against the payload bay door, is the shuttle's robotic arm that will be unfurled and tested within the next few hours by Commander Chris Ferguson and pilot Doug Hurley in advance of its grappling of the orbiter boom sensor system for the initial inspection of the shuttle's thermal protection system tomorrow. Now the port door begins to swing open. In this split-screen image on the left is the shuttle's Ku-band communications antenna, which also will be deployed a short time from now. And the Mechanical Systems Officer reports the payload bay doors have been opened for the final time on Atlantis. Here in the flight control room, Flight Director Richard Jones now polling his team to get a go for on-orbit operations.
Atlantis, we just polled the room, and you are go for orbit ops.
Go for orbit ops. Great news, Houston. Thanks.
So with that, the crew will begin the process of doffing their launch and entry suits. And we'll press ahead now for the deployment of the Ku-band communications antenna and the setup of the laptop computers on board the orbiter. Also on tap, the activation of the star trackers, the stowage of the escape pole, and other items that will clear the path for the rest of the day's activities that will culminate in the crew going to sleep around 7 p.m. Central Time tonight. We'll be switching the NASA television satellite back down to the Kennedy Space Center shortly for the start of the post-launch news conference in about 5 minutes at 12:10 Central Time, 1:10 Eastern Time. Once again, Bill Gerstenmaier, the NASA Associate Administrator for Space Operations, will be participating in that news conference, joined by the director of the Kennedy Space Center, Bob Cabana, Mike Moses, the Shuttle Launch Integration Manager, and Mike Leinbach, the Shuttle Launch Director. Again, Atlantis' payload bay doors now open, a go for on-orbit operations issued by Flight Director Richard Jones, everything going swimmingly in the early phase of Atlantis' final flight into space.
Houston, that's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.